Langchain Community Vector Stores VDMS embedding 2 bytes. Detailed definition of the variable. Detailed definition of the variable goes here. Components. Component 1. A langchain vector store built on top of a vector database management system VDMS. This component combines the power of LangChain's library for building conversational AI applications with the efficiency of vector database management systems. It acts as a bridge between these two technologies, enabling users to store and retrieve information using semantic similarities, making it highly efficient for large-scale data management. Component 2. It's a tool to store and retrieve data from a vector database by using vector embeddings. This component uses a vector database, essentially a database optimized for storing and searching vectors, to handle the storage and retrieval processes. It leverages vector embeddings, mathematical representations of text or data that capture semantic meaning, to find relevant information based on similarity rather than exact keyword matches. Architecture. Description of the variable. Description of the architecture supporting the variable. It operates within LangChain's framework, interfacing with VDMS to manage vector representations of data. This architecture is built on top of LangChain's framework, a popular library for building applications utilizing large language models (LLMs). It seamlessly integrates with the vector database management system VDMS to handle the management of vector representations of data. This integration ensures a smooth flow of information between LangChain's components, the vector database, and the application, enabling efficient semantic search and retrieval capabilities. Explanation of the variable's role in the system. Explanation of the variable's role in the system. It allows for embedding information into vector spaces, facilitating semantic search and retrieval. This component's primary role is to transform data into vector representations, which are then stored and searched within the vector database. This process allows the system to perform semantic search, understanding the meaning and context of the data rather than just matching keywords. This is particularly valuable for applications where retrieving relevant information based on nuanced meaning is crucial. Advantages of using this variable. Efficiently stores and retrieves data based on semantic similarity. This advantage stems from its core functionality of using vector embeddings. By representing data as vectors, the system can identify similar data points based on their semantic closeness, making it highly efficient for retrieving relevant information even if the search query doesn't match the exact keywords. Leverages the power of vector databases for large-scale data management. This advantage lies in its integration with vector database management systems (VDMS). These systems are specifically designed to handle large volumes of data and efficient vector operations, making them ideal for storing and retrieving large datasets of vector embeddings. This ensures scalability and performance even when dealing with vast amounts of data. Challenges of using this variable. VDMS-specific configurations and dependencies might need attention. This challenge arises from the need to configure and integrate with a specific vector database management system VDMS. Each VDMS might have its own unique configurations, dependencies, and API for interacting with it. Users need to understand these specifics and properly configure the system to ensure seamless integration and operation. Requires appropriate embedding models for effective semantic representation. This challenge highlights the importance of choosing the right embedding model for representing data. The effectiveness of semantic search heavily relies on the quality of the vector embeddings generated by the embedding model. Selecting an embedding model that accurately captures the semantic meaning of the data is crucial for achieving meaningful search results. Real-world examples include using pre-trained models like sentence transformers or building custom models based on specific domain requirements. LangChain Community Vector Stores VDMS Client. Definition: a specialized vector database management system VDMS client designed for LangChain. This client enables interaction with VDMS from within LangChain projects. It offers efficient data storage, retrieval, and management capabilities, specifically optimized for large-scale language models and vector-based representations. For example, you could use this to create a knowledge base that can be easily searched and updated with new information. Components. Component 1. A Python library specifically designed for interacting with the VDMS. This library provides functions for performing common operations such as adding vectors, searching for similar vectors, and managing data. Imagine this library is a toolbox for developers to work with the VDMS. Component 2. A specialized server or service responsible for storing and retrieving vector data. This server is like a central storage hub that manages all the vector information. Component 3. The actual vector representations of data, often derived from text or other types of input, which are stored and managed within the VDMS. This vector data could represent words, sentences, or entire documents as numerical representations. Architecture. The VDMS client establishes a connection to the VDMS server, which handles the storage and retrieval of vectors. The client uses the provided application programming interface API to interact with the server, sending requests to perform actions such as adding new vectors, searching for similar vectors, or retrieving vector data. This architecture separates the data management responsibilities from the client, allowing the client to focus on its core tasks, such as interacting with language models or retrieving relevant information. Role: facilitates seamless integration of VDMS into LangChain workflows. It serves as a bridge between the LangChain ecosystem and VDMS, enabling efficient and scalable storage, retrieval, and management of vector representations within LangChain projects. This makes it easier for developers to build powerful applications using LangChain and VDMS. Advantages: designed to handle large amounts of vector data effectively. It allows storing and retrieving vectors efficiently, even in complex applications. Imagine a system that can handle millions of documents and quickly retrieve the most relevant information. The VDMS server is optimized for vector operations, leading to fast retrieval times and efficient data processing. This means that your application can provide fast and accurate results. Seamless integration with the LangChain ecosystem, simplifying the process of managing vector data within LangChain projects. This allows developers to focus on building their application logic without worrying about complex data management tasks. Challenges: requires the VDMS server to be available and accessible. The client relies on the server for data storage and retrieval. This means that your application will need to be connected to the server to function properly. Managing and optimizing the VDMS server can be complex, especially when dealing with large datasets. This requires careful resource planning and management. Ensuring the security and integrity of the data stored within the VDMS server is crucial. This means implementing robust security measures to protect your data from unauthorized access and breaches.
LangChain Community Vector Stores VDMS Client. Description of the VDMS client in the context of LangChain Vector Stores. Detailed definition of the VDMS client variable. Components. Component 1. A vector store component that interacts with the VDMS server to store and retrieve embeddings. This component acts as a bridge between the LangChain application and the VDMS server, allowing users to seamlessly manage vector data. It handles the communication protocols and data serialization required for interaction with the VDMS server. For example, the VDMS client component could handle requests to add new embeddings, search for similar embeddings based on a query, or retrieve embeddings associated with specific identifiers. Component 2. A VDMS server component that manages the storage and retrieval of embeddings, using a distributed database technology. This component is responsible for storing and retrieving embeddings efficiently and scalably. It handles the underlying database operations, ensuring data consistency and availability. The VDMS server could use a distributed database system like Apache Cassandra or MongoDB to manage large volumes of embedding data. The server component would expose an application programming interface API that the VDMS client uses for communication. Description of the architecture supporting the VDMS client. The VDMS client is a LangChain component that enables interaction with a VDMS server, allowing for the storage and retrieval of embeddings. The VDMS client is responsible for connecting to the VDMS server and executing requests. The VDMS server is a distributed system that manages the storage and retrieval of embeddings. The client and server communicate through a network connection, using a well-defined protocol. The VDMS server can be deployed on multiple machines, enabling horizontal scaling for handling large data sets. Explanation of the VDMS client's role in the system. The VDMS client facilitates the use of VDMS as a vector store within LangChain applications. It allows users to perform common operations such as adding, searching, and deleting vectors in a scalable and distributed manner. The VDMS client acts as a wrapper around the VDMS server, providing a simplified interface for LangChain users to interact with the vector store. The VDMS client handles the complexities of communication and data serialization, allowing users to focus on using the vector store for their tasks. Scalability. VDMS provides distributed storage, allowing for handling large data sets. For example, a large language model LLM might generate millions of embeddings during its training or usage. VDMS can efficiently manage this data by distributing it across multiple servers. Efficiency. The server can optimize embedding storage and retrieval, enhancing performance. The server can use specialized indexing techniques and data structures to optimize search queries and reduce retrieval time. This is crucial for applications that require fast response times, such as real-time chatbots or search engines. Complexity. Setting up and managing a VDMS server might require some technical expertise. The user might need to configure the server, manage its deployment, and ensure its availability and security. This might requires some understanding of distributed systems, database management, and network security. Network dependency. The client relies on a network connection to the VDMS server for all operations. This can lead to performance degradation if the network connection is slow or unreliable. It also introduces a point of failure. If the server is unavailable, the client will not be able to access the vector store. Definition. Components. Component 1. Tiled vector store is a vector store implementation that leverages the TileDB storage engine to achieve fast and scalable document retrieval. TileDB is a high-performance, scalable, and open-source data management library designed to store and query large data sets. By utilizing TileDB, Tiled Vector Store offers efficient storage and retrieval of document embeddings, enabling fast and scalable access to large document collections. Component 2. Get Documents Array URI is a method that retrieves the uniform resource identifier URI of the TileDB array containing the stored documents. This method allows you to access the TileDB array holding the documents, enabling further operations such as retrieval of specific documents or performing other queries based on the stored data. Architecture. Tiled Vector Store utilizes TileDB for efficient storage and retrieval of document embeddings. TileDB provides a robust framework for managing large-scale data, enabling Tiled Vector Store to handle vast collections of documents and their corresponding embeddings. This architecture ensures efficient storage and retrieval of data, contributing to the overall performance of the vector store. Role. Get Documents Array URI enables the retrieval of the URI associated with the TileDB array holding the documents. This URI acts as a key to access the specific array containing the document data within the TileDB storage system. It facilitates accessing the stored documents and performing various operations on them, such as retrieving specific documents or executing queries based on the stored embeddings. Advantages. Advantage 1. TileDB provides efficient storage and retrieval of large data sets, making it suitable for storing document embeddings. TileDB's optimized storage and retrieval mechanisms enable fast access to the stored data, enhancing the performance of retrieving documents from the vector store. This efficient storage contributes to the overall performance of the vector store, allowing for rapid retrieval of relevant documents based on similarity queries. Advantage 2. TileDB supports scalable storage and retrieval, enabling it to handle large document collections. Scalability is crucial when dealing with vast amounts of data, and TileDB provides this capability by allowing the storage and retrieval of large data sets, ensuring that the vector store can accommodate growing document collections. This scalability ensures that the vector store remains performant even as the document corpus expands, providing a robust solution for handling increasingly larger data sets. Challenges. Challenge 1. The method returns a URI pointing to the TileDB array containing the documents. The URI provides a unique identifier to access the specific array holding the document data within the TileDB storage system. It allows for targeted access to the relevant array, enabling efficient retrieval of documents based on the specific array containing the required data. Challenge 2. The returned URI can be used to access the TileDB array for retrieving specific documents or performing other operations. This URI acts as a gateway to the TileDB array containing the document data, allowing for various operations based on the stored information. It enables you to retrieve individual documents or perform more complex queries based on the stored embeddings, leveraging the capabilities of the TileDB storage engine. LangChain CSV Agent. Description of LangChain CSV Agent. An agent that processes and analyzes comma-separated value CSV data using a set of defined tools. Component 1. The agent uses a CSV loader tool to load the data from a comma-separated value CSV file into memory. This tool acts as the initial step in the agent's process. It reads the CSV file, which usually contains structured data with rows and columns, and stores it in a format that the agent can easily access and manipulate. This allows the agent to process the data efficiently and perform various operations on it. Component 2. The agent uses a CSV tool to perform operations on the data, such as filtering, sorting, and aggregation. This tool provides functionalities to manipulate and analyze the loaded CSV data. Filtering allows the agent to select specific rows or columns based on certain criteria, such as specific values or conditions. Sorting enables the agent to rearrange rows based on the values in a specific column, which can help identify patterns or trends. Aggregation functions like calculating the average, sum, or count of values in a column, provide insights into the overall data distribution and characteristics. The agent is built using LangChain's agent framework, which provides a structure for defining and executing agents. LangChain's agent framework offers a powerful and flexible approach to building intelligent agents. It provides a modular architecture, allowing developers to combine different tools and components to create agents that can perform various tasks. This framework helps streamline the development process and ensures that the agent can be easily adapted to different scenarios and requirements. The agent's role is to automate the processing of comma-separated value CSV data and provide insights into the data using defined tools. The agent acts as a data processing and analysis tool, automating repetitive and complex tasks that would typically require manual effort. By leveraging defined tools, the agent can efficiently handle large data sets, perform complex operations, and extract meaningful insights from the data. This allows users to gain a deeper understanding of the data and make informed decisions based on the processed information. Automates tasks, such as filtering and sorting. Automation eliminates the need for manual intervention, saving time and effort. The agent can automatically filter data based on specific criteria, allowing users to focus on analyzing the most relevant information. Sorting data based on specific columns can help identify patterns, trends, and outliers, providing valuable insights into the data. Reduces the time required to analyze comma-separated value CSV data. By automating data processing and analysis tasks, the agent significantly reduces the time required for manual analysis. This allows users to gain insights from their data much faster, enabling them to make informed decisions in a timely manner. Limited tool support, such as data visualization and complex data manipulation. The current set of tools may not include support for all data analysis and manipulation functionalities. While the agent can perform basic operations like filtering and sorting, more advanced features like data visualization or complex data transformations might require additional tools or extensions. Potential for errors in data loading and processing. The accuracy of the processed data heavily depends on the quality of the input data and the reliability of the tools used by the agent. Any errors in the data loading process or tool functionalities can lead to inaccurate results. It is crucial to ensure data integrity and validate the output of the agent to minimize potential errors. LangChain Community Vector Stores Tiled Get Documents Array URI. Detailed definition of the variable. The getDocumentsArray URI method is a fundamental component of the tiled vector store class within the LangChain community's vector stores. It functions by retrieving the uniform resource identifier URI of the TileDB array that houses document embeddings. This URI is then utilized in conjunction with the getDocuments method, which is designed for efficiently retrieving documents linked to specific embeddings. For instance, a search engine using tiled vector store might call getDocumentsArray URI to get the URI of the array storing document embeddings. This URI is then passed to the getDocuments method, allowing the retrieval of documents associated with the search query's embedding. Description of the architecture supporting the variable. The getDocumentsArray URI method is intrinsically linked to the tiled vector store class, which is built upon the robust TileDB data management framework. TileDB offers a specialized data management system specifically tailored for efficient storage and retrieval of vector embeddings. Its core advantage lies in its capacity to index and retrieve large data sets with remarkable speed, making it an ideal choice for vector search applications. For example, a large-scale e-commerce website might utilize tiled vector store to store and retrieve product descriptions or customer reviews. The getDocumentsArray URI method would be instrumental in efficiently accessing this information based on vector search queries. Explanation of the variable's role in the system. The getDocumentsArray URI method plays a crucial role in the tiled vector store system by providing a direct access point to the TileDB array storing document embeddings. This URI acts as a bridge, connecting the getDocuments method to the actual storage of embedding data. The getDocuments method relies on this URI to fetch the relevant documents based on the provided embeddings. Consider a scenario where a user searches for a specific topic on a document search platform. The platform might utilize tiled vector store to find relevant documents. The getDocumentsArray URI method would retrieve the URI of the array storing the document embeddings, enabling the getDocuments method to efficiently retrieve documents matching the user's search query. Advantages of using the variable. Advantage 1. The primary advantage of using getDocumentsArray URI lies in its efficiency. It allows for the swift and precise retrieval of documents associated with specific embeddings. For example, a news aggregator using tiled vector store could leverage getDocumentsArray URI to efficiently retrieve news articles related to a particular keyword search. Advantage 2. By harnessing the power of the TileDB framework, getDocumentsArray URI benefits from TileDB's inherent capabilities for managing and retrieving large data sets with exceptional efficiency. This makes it suitable for applications dealing with substantial amounts of data. For instance, a social media platform might utilize tiled vector store to store and retrieve user posts or comments. The getDocumentsArray URI method would ensure efficient access to this extensive dataset. Challenges associated with using the variable. Challenge 1. A potential challenge lies in the requirement for a degree of familiarity with the TileDB data management framework. While TileDB is a powerful tool, its usage might require some learning curve for developers unfamiliar with its functionalities. However, the benefits of efficient data storage and retrieval offered by TileDB often outweigh this initial learning phase. Challenge 2. Optimal performance can be sensitive to the configuration of the system. Achieving peak performance may necessitate careful tuning of parameters related to data storage, indexing, and retrieval within the TileDB framework. However, the flexibility and control offered by TileDB allow for customization to achieve the desired performance levels. Summarization of langchainexperimental agents. Agent toolkits. Corbits base. Create Corbits agent. NaN creates an Corbits agent, which is a type of tool using language agent. An Corbits agent is a powerful tool that leverages the capabilities of external tools to solve problems and complete tasks. It acts like a knowledgeable assistant that can interact with the real world through various APIs or services. For instance, imagine you need to find a restaurant, book a table, and get directions. An Corbits agent could access a restaurant review website, a reservation system, and a mapping service to complete these tasks. Component 1. Corbits agent. An Corbits agent is a specialized type of language agent designed to work with tools. It's like a smart assistant that can leverage the functionality of various external applications to solve problems. For example, if you're trying to write a blog post, an Corbits agent could be programmed to use tools like a text generator, a grammar checker, and a research engine to help you. Component 2. Tool. A tool is a piece of software or an external service that an Corbits agent can interact with. These tools can perform specific functions, providing the agent with access to information and actions beyond its own knowledge base. Examples of tools include weather APIs, search engines, or calendar applications. Think of tools as the agent's hands and eyes, enabling it to interact with the world. The agent uses tools to interact with the world and solve problems. An Corbits agent works by combining its own understanding of language with the capabilities of external tools. It uses a structured approach to break down tasks, choose the right tools, and interpret the results, enabling it to accomplish tasks that would be difficult or impossible without these tools. Imagine it like having a team of specialists at your disposal, each with their own unique skills. Solves problems by interacting with the world using tools. The core role of an Corbits agent is to leverage its knowledge of tools to solve problems. This means it can be used to gather information, automate tasks, or create new things. Think of it as a versatile tool that can help you in various areas, from research to decision-making. Utilizes the power of tools to solve problems. One of the major strengths of Corbits agents is their ability to leverage the power of external tools. This allows them to perform actions that would be impossible without access to these tools. Imagine having a language model that can not only understand your request but also make a reservation at a restaurant, book a flight, or even control your smart home devices. Can be used to build custom agents for specific tasks. Corbits agents offer flexibility by allowing developers to create custom agents tailored for specific tasks. You can design an agent to handle customer service inquiries, summarize news articles, or even create artistic content. The possibilities are endless. The agent's effectiveness relies on the quality and relevance of the tools provided. The quality of the tools provided to an Corbits agent is crucial to its success. If the tools are inaccurate, outdated, or irrelevant to the task, the agent will struggle to produce useful results. Just like a skilled craftsman needs the right tools, an Corbit's agent needs access to high-quality tools to be effective. The agent's ability to handle complex tasks depends on the design and configuration of the tools and the agent's logic. While Corbit's agents offer significant potential, handling complex tasks requires careful design and configuration. The agent's logic must be able to effectively combine the information and actions of multiple tools to complete intricate tasks. Imagine it like building a complex machine where each part needs to work perfectly in harmony. Enhanced metadata extraction capabilities. The function's ability to handle complex metadata structures allows for richer and more detailed metadata associated with documents, leading to improved search and retrieval results. For instance, consider a dataset of customer reviews. This function can extract structured information like product name, rating, review text, and even sentiment analysis from the reviews, enabling more targeted and insightful analysis. Improved searchability. By providing more comprehensive metadata, the function enables users to search for documents based on a wider range of criteria, leading to more precise and relevant results. For example, searching for a scientific paper based on a combination of keywords, publication date, and author name is made more efficient and accurate by having this function extract all relevant metadata from the documents. Challenges. Handling inconsistent metadata formats. The function must be able to handle a variety of metadata formats, as different documents may use different conventions for representing metadata. For instance, one document might use a specific format for representing dates, while another might use a different format. The function needs to be adaptable enough to parse and interpret these different formats correctly to ensure consistent metadata extraction. Extracting metadata from complex document structures. The function must be able to handle complex document structures, such as those containing nested dictionaries or lists. For example, consider a document describing a complex product with multiple features and options. The function needs to be able to navigate these nested structures and extract relevant information, like feature specifications, pricing details, and user reviews, to provide a comprehensive understanding of the product. Harness the power of Spark for processing massive data sets effectively. Requires a pre-configured Spark environment for operation. Familiarity with Spark data frame application programming interfaces, APIs, and syntax is necessary for successful utilization. Action type. A string that identifies the type of action to perform. This specifies what the agent is supposed to do. Examples include tool code for invoking a tool using code, code execution for running code, HTTP request for making an HTTP request, search for searching the web, and summarize for summarizing text. Component 2. Arguments. A dictionary that contains the parameters or inputs needed for the action. These arguments are passed to the action's implementation to provide context or specific instructions. Component 3. Output parser. An object that parses and interprets the output of the action. It is responsible for converting the raw output into a format that is useful for the agent. Architecture. The AutoAction class encapsulates an action that the agent takes. It specifies the action type, its arguments, and the parser for its output. This enables the agent to execute different actions and interpret their results. Role. The AutoGPT class defines a unit of action for the AutoGPT agent. It enables the agent to interact with tools and external resources by specifying the action to take, the arguments to pass, and the output parser to use. For example, it allows the agent to search the web for information, run code, or make API requests. Advantages. Advantage 1. Structured and consistent action representation. Provides a structured and consistent way to represent and execute actions taken by the AutoGPT agent. This makes it easier to understand the actions the agent is taking, as well as to manage and coordinate different actions. Advantage 2. Flexibility in defining actions. Allows for flexibility in defining different types of actions with custom arguments and output parsers. This enables the agent to perform a wide range of tasks, including tasks that require specific parameters or output formats. Challenges. Challenge 1. Compatibility with tools and resources. Ensuring that the action type, arguments, and output parser are compatible with the chosen tool or external resource. For example, if the agent is using an application programming interface API to access a service, the arguments and output parser need to match the API's specifications. Challenge 2. Handling unexpected outputs. Handling unexpected or complex outputs from the tool or external resource, and ensuring the output parser can effectively interpret and parse them. For example, the agent might need to handle errors or unexpected data formats from the tool or resource. AutoGPT. A YAML representation of the AutoGPT class, detailing its purpose, components, architecture, role, advantages, and challenges. This class serves as a structured way to represent and define actions that the AutoGPT agent takes during its operation. It acts as a blueprint for the agent's actions, providing a clear and organized framework for its decision-making process. Component 1. The specific action that the AutoGPT agent will execute. This can be anything from searching the Internet for information to interacting with an application programming interface API to complete a task. For example, an action might be search for information on the topic of machine learning or make a request to the Google Maps API to find directions between 2 points. Component 2. Any data or inputs required for the action to be performed successfully. These arguments can include parameters, keywords, specific values, or any other data necessary for the action to function correctly. For instance, if the action is search for information on the topic of machine learning, the arguments could include machine learning, deep learning, and artificial intelligence. Component 3. The tool or mechanism used to carry out the action. Tools can be diverse and range from internet search engines like Google or Bing to specific application programming interfaces APIs for interacting with different services. This component specifies how the AutoGPT agent will execute the action. For example, the tool might be Google Search for the action search for information on the topic of machine learning. Component 4. The reasoning behind the action. This component explains why the AutoGPT agent chose to perform this specific action, considering its overall goals and the current state of the task at hand. It outlines the logic and motivations driving the action, providing a transparent understanding of the agent's decision-making process. For example, the reason could be to gather relevant information about machine learning to better understand the topic and achieve the overall goal. AutoGPT serves as a core building block in the AutoGPT system, representing the individual steps the agent takes to achieve its objectives. Each action is defined by its type, required input, the tool used to execute it, and the rationale behind taking the action. This structure allows the agent to break down complex tasks into manageable, well-defined steps, leading to a more efficient and transparent decision-making process. AutoGPT is a key element in AutoGPT's goal-oriented approach. It enables the agent to meticulously plan and execute its actions, reflecting a sophisticated understanding of its objectives and the means to achieve them. By clearly defining each action, AutoGPT can effectively manage and coordinate its efforts to achieve its target outcomes. By explicitly representing each action taken, AutoGPT ensures clarity and transparency in the agent's behavior. This allows for easy understanding and analysis of the agent's decision-making process, promoting trust and confidence in its actions. AutoGPT facilitates a structured approach to reasoning by providing a framework for breaking down complex tasks into smaller, manageable actions. This allows the agent to approach problems systematically, increasing the efficiency and effectiveness of its problem-solving process. While AutoGPT provides a structured framework for action representation, it might not always be flexible enough to handle extremely complex actions with intricate dependencies and interactions. This limitation could require additional mechanisms for representing more sophisticated actions, potentially impacting the agent's ability to effectively handle highly complex tasks. Maintaining consistency in the representation of actions can be challenging, particularly when dealing with a variety of tools and actions. Inconsistent action representations can lead to ambiguity and confusion in the agent's decision-making process, potentially impacting its performance and accuracy. Summarization of LangChain Experimental Autonomous Agents AutoGPT Output Parser Base AutoGPT Output Parser NAN Base class for output parsers used in AutoGPT. This class is the foundation for processing information from various tools that AutoGPT interacts with. It ensures that all output parsers follow a uniform approach, making the agent's interactions with tools more consistent. Component 1 parses the output from a tool and extracts relevant information. This component is responsible for deciphering the output from a tool, be it text, data, or other formats. It then identifies and isolates the crucial information that the AutoGPT agent needs to continue its task. For example, if the tool is a web search engine, this component might extract relevant URLs or key phrases from the search results. Component 2 uses the extracted information to update the agent's memory and state. This component takes the processed information from the previous component and updates the agent's knowledge base. It helps the agent learn from its interactions with tools, building its understanding of the task and the world around it. This process is crucial for the agent's ability to adapt and improve over time. Imagine a scenario where AutoGPT is tasked with finding information about a specific topic. This component would store the extracted information from various sources in the agent's memory, making it available for later reference and decision-making. Implements a common interface for all output parsers. This ensures that regardless of the specific tool being used, the agent can interact with it through a standardized method. It allows for easier integration of new tools and facilitates the development of different parsing strategies without compromising the core functionality of the agent. This approach promotes flexibility and extensibility within the AutoGPT framework. Enables AutoGPT to effectively interpret and process tool responses. This role is critical to AutoGPT's ability to learn and adapt, making it a powerful tool for diverse tasks. By standardizing the parsing process, this component ensures that AutoGPT can understand and utilize the information provided by various tools, regardless of their output format. Imagine a scenario where AutoGPT uses multiple tools, like a web search engine, a database, and a natural language processing model. This component ensures that AutoGPT can seamlessly integrate and interpret the output from each of these tools, enabling it to complete its task effectively. Provides a consistent structure for handling diverse tool outputs. This aspect enhances the agent's ability to work with a wide range of tools without requiring significant changes in its core logic. It promotes code reusability and makes it easier to add new tools to the agent's repertoire. Consider a scenario where AutoGPT is used for various tasks, such as writing a blog post, booking a flight, or conducting market research. This component ensures that the agent can efficiently process outputs from diverse tools, like content generators, travel booking platforms, and market research tools, without needing specialized parsing logic for each one. Enhances the agent's ability to learn and adapt. By consistently storing processed information in the agent's memory, this component contributes to the agent's learning process. The agent can analyze this information, identify patterns, and improve its decision-making abilities over time. Imagine a scenario where AutoGPT is tasked with writing a series of blog posts. With each task, this component will process the output from different tools, like content generators, research tools, and editing tools. As the agent progresses, it can learn from this information, improve its writing style, and even identify new tools or techniques that could improve its performance. Handling complex or unstructured output formats. The ability to parse outputs from tools that produce unstructured data, such as text with mixed formatting, multimedia elements, or irregular data structures, presents a significant challenge. For instance, if AutoGPT needs to extract information from a website with a complex layout or a document with multiple nested tables, the parsing component needs to be robust enough to handle these challenges. Maintaining compatibility with different tools. The constant evolution of tools and the introduction of new tools with unique output formats can pose a challenge for the agent's ability to maintain compatibility. This component must be flexible enough to adapt to these changes without requiring significant rework or compromising the agent's core functionality. Imagine a scenario where a new tool with a unique output format is introduced. The parsing component needs to adapt quickly to handle this new format without interrupting the agent's workflow. Langchainexperimental autonomous agents AutoGPT output parser AutoGPT action. Description of the class. AutoGPT action is a class that represents an action for the AutoGPT agent to take. It defines the action the agent should take, the arguments needed, and the tool used. It's a class that represents a possible action for an AutoGPT agent. Components of the class. Description of Component 1. Action. The action itself, like search the web for information or generate code. Description of Component 2. Arguments. The input parameters needed for the action, like keywords for web search or the programming language for code generation. Description of Component 3. Tool. The specific tool to be used for the action, like a web search engine or a code generator application programming interface API. Advantages of the class. Description of Advantage 1. Standardizes how actions are represented. This provides a consistent structure for actions across different parts of the AutoGPT system. Description of Advantage 2. Ensures clear communication between components. By defining actions in a standard way, different parts of the system can easily understand and exchange information about actions. Challenges of the class. Description of Challenge 1. Handling complex actions requiring multiple steps. For example, a complex action might involve multiple web searches, data processing, and code generation. AutoGPT needs to handle this complexity. Description of Challenge 2. Ensuring proper argument validation and type checking. To avoid errors, AutoGPT needs to validate the inputs and ensure they are of the correct type. Summary of LangChain Experimental Agents. Agent Toolkits. Corebits Base. Create Corebits Agent. Nan. Create an agent that can use a list of tools to complete a task. This agent can be used to automate tasks that would otherwise require human intervention. It can use various tools to perform specific actions, like retrieving information from a database, accessing an application programming interface API, or performing calculations. For example, an agent can be programmed to use a weather API to retrieve the current weather conditions, then use a messaging API to send a message to a user with the information. Component 1. An agent that can use a list of tools to complete a task. This agent can be used to automate tasks that would otherwise require human intervention. It can use various tools to perform specific actions, like retrieving information from a database, accessing an application programming interface API, or performing calculations. For example, an agent can be programmed to use a weather API to retrieve the current weather conditions, then use a messaging API to send a message to a user with the information. Component 2. A toolkit that provides a set of tools that can be used by the agent. The toolkit could include various tools like a weather API, a messaging API, or a database connection. The agent can then use these tools to complete its tasks. The agent is a stateful object that maintains a list of tools and a memory of its previous actions. It can access and use tools based on its current task, and its memory helps it understand the context of the task and previous actions. It can also use its memory to learn and improve its performance. The agent is responsible for deciding which tools to use and in what order to use them. The agent analyzes the task and decides which tools are required to complete it. It can also track the progress of the task and adapt its strategy accordingly. Can be used to automate tasks that would otherwise require human intervention. For example, an agent can be programmed to manage social media accounts, like scheduling posts or responding to comments. Can be used to solve complex problems that require multiple steps. For example, an agent can be programmed to book a flight, find a hotel, and rent a car for a vacation, all by using different APIs and tools. The agent may need to be trained on a large dataset of examples in order to perform well. This training involves providing the agent with a large amount of data and examples of how to use tools to complete tasks. The agent can learn from this data and improve its ability to perform tasks. The agent may be difficult to debug and maintain. The agent's behavior can be complex and difficult to understand, and it may be challenging to identify and fix problems with the agent. Prompt generator in LangChain experimental autonomous agents AutoGPT. Definition: a component of AutoGPT, it's responsible for producing prompts that guide the language model's actions. It is crucial for directing the language model and shaping its responses. Components. Component 1. Predefined structures for prompts tailored to specific tasks. This is useful in automating the prompt generation for various tasks. Component 2. Techniques for crafting effective and targeted prompts. This component includes elements like using specific keywords and structuring the prompt for optimal results. Architecture. The prompt generator dynamically interacts with other AutoGPT components such as memory and tool usage modules to create prompts that are contextually relevant and meet the task's requirements. Role. The prompt generator significantly influences the language model's actions by providing clear and concise instructions. It acts as a translator between the user's objectives and the language model's capabilities. Advantages. Streamlines the process of prompt creation, saving time and effort. For instance, a predefined template can quickly generate prompts for tasks like summarizing a text or translating a sentence. Enhances the accuracy and relevance of the language model's outputs. Well-crafted prompts lead to better understanding of the task and more refined results. Challenges. Creating prompts that are both comprehensive and understandable for the language model. For example, the prompt must be detailed enough to guide the language model correctly but also must be simple enough to be interpreted without ambiguity. Ensuring that the prompts accurately reflect the current context and task goals. This involves analyzing the task at hand and understanding its nuances to create a prompt that captures the relevant information. Summary of LangChain experimental autonomous agents AutoGPT output parser AutoGPT action. NaN. A class that defines actions for AutoGPT. It inherits from the LangChain agent action class and provides a structured way to represent actions taken by the agent. For example, if AutoGPT decides to search the web for information, the AutoGPT action class would store details like the search query used, the web search tool employed, and the results obtained. This structured representation makes it easier to track the agent's actions and analyze its behavior. Component 1. Action. Name the name of the action taken by the agent. For instance, it could be web search, code execution, or file writing. Component 2. Tool code. The code snippet used to execute the tool. For example, if the tool is a web search engine, the tool code might be a Python function that sends a search request to the engine. Component 3. Tool name. The name of the tool used for the action. For example, if the tool is a web search engine, the tool name could be Google Search or Bing Search. Component 4. Arguments. The arguments passed to the tool during execution. For example, if the tool is a web search engine, the arguments could include the search query, the number of results to return, and the language to use for the search. Component 5. Observation: the observation obtained from executing the action. This observation can be any data or information obtained as a result of the action, such as the results of a web search or the output of a code execution. The AutoAction class is designed to encapsulate the actions taken by the agent, including tool usage, arguments, and observations. It provides a structured way to represent and manage actions, facilitating efficient execution and analysis. By encapsulating each action in this class, it becomes easier to track the agent's progress, understand its decision-making process, and analyze its overall performance. This structured representation also allows for efficient debugging and troubleshooting in case of issues. This class plays a central role in orchestrating and managing the actions performed by AutoGPT. It standardizes action representation, making it easier to track and interpret agent behavior. By providing a consistent format for representing actions, the AutoAction class simplifies the task of understanding and analyzing the agent's behavior. This standardization also makes it easier to integrate with other tools and systems that may need to access or analyze the agent's actions. Provides a standardized format for representing actions. This standardization ensures that all actions are represented in a consistent manner, regardless of the specific tool used or the type of action being performed. Facilitates efficient execution and analysis of agent actions. The structured representation of actions allows for efficient processing and analysis, enabling better understanding of the agent's behavior and performance. Enhances clarity and transparency in agent operations. The structured representation of actions enhances transparency by making it easier to track and understand the actions taken by the agent, promoting trust and confidence in its behavior. Ensuring consistent and accurate action representation. Maintaining consistency in action representation across different tools and functionalities can be challenging, especially when dealing with complex actions or diverse tool APIs. Maintaining compatibility with different tool application programming interfaces and functionalities. The class needs to be flexible enough to accommodate a wide range of tools and functionalities while ensuring compatibility with their specific APIs and data formats. Summarization of langchainexperimental.autonomous-agents.auto.output-parser.auto-output-parser. NaN parses output from an AutoGPT agent. This parser acts as a bridge between the unstructured output generated by an AutoGPT agent and a more human-readable and structured format. It takes the raw output of the agent, typically a string of text, and extracts meaningful information from it. This information is then organized into a consistent and predefined structure, making it easier to analyze and interpret the agent's actions and results. Component 1. Parser that provides a structured format for the agent's output. This component is responsible for transforming the unstructured output of an AutoGPT agent into a structured format. It breaks down the agent's output into logical units, typically by identifying key information points such as actions taken, results obtained, and any encountered challenges. This structure makes the output more easily interpretable and analyzable. Component 2. Contains information about the agent's actions. This component acts as a repository for the key actions performed by the AutoGPT agent during its execution. It captures details about the tasks the agent completed, the specific tools and application programming interfaces APIs it used, and any decisions made during the process. This information is critical for understanding the agent's progress, identifying potential areas for improvement, and evaluating the overall effectiveness of the agent's operation. Uses a predefined structure to organize the output. This parser employs a predefined structure to organize the output of the AutoGPT agent. This structure is designed to ensure consistency and readability, making it easy to compare and analyze the outputs across different tasks and execution runs. The structure typically includes sections for actions, results, challenges, and any other relevant information, allowing for a standardized way of understanding the agent's behavior and progress. Facilitates the analysis and understanding of agent actions. The primary role of this parser is to simplify the analysis and understanding of the actions performed by an AutoGPT agent. By providing a structured format for the agent's output, it eliminates the need to manually sift through unstructured text and identify key information. This structured output enables users to quickly grasp the agent's actions, their outcomes, and any encountered challenges, allowing for a deeper understanding of the agent's behavior and its overall performance. Improves clarity and organization of agent output. This parser contributes significantly to improving the clarity and organization of the agent's output. It transforms the often unstructured and unorganized output of the AutoGPT agent into a well-defined format, making it easier for humans to understand and interpret. The structured output makes it easier to identify key information, track the agent's progress, and analyze its decision-making process, ultimately leading to a better understanding of the agent's overall behavior. Enhances the ability to track and analyze agent performance. The structured output generated by this parser significantly enhances the ability to track and analyze the performance of an AutoGPT agent. By providing a consistent format for the agent's output, it facilitates the collection and analysis of data related to the agent's actions, results, and challenges encountered. This data can then be used to assess the agent's effectiveness, identify areas for improvement, and ultimately optimize its performance for future tasks. Maintaining consistency in output structure across different tasks. One of the key challenges is ensuring consistency in the output structure across different tasks. AutoGPT agents are designed to be flexible and adaptable, capable of handling a wide range of tasks. This flexibility can lead to variations in the agent's output, making it difficult to maintain a consistent structure for the parser. To address this challenge, the parser needs to be adaptable enough to handle diverse output formats while maintaining a consistent core structure for ease of analysis. Adapting to evolving agent behaviors and outputs. Another challenge lies in adapting to evolving agent behaviors and outputs. As AutoGPT agents continue to develop and improve, their behavior and output may evolve, potentially requiring changes to the parser's structure. To remain effective, the parser needs to be flexible and adaptable, capable of evolving alongside the agent to ensure consistent and accurate parsing of the agent's output. This may involve regular updates to the parser's structure and algorithms to accommodate new agent capabilities and output formats. langchainexperimental.autonomousagents.babyagi.babyagi.babyagi. An elaboration of babyagi with details. A simple, self-improving artificial intelligence agent designed to break down complex tasks into smaller, manageable steps. It executes these steps through a chain of interactions with large language models (LLMs) and external tools, learning from the outcomes to improve its efficiency and performance. Component 1. Task prioritization determines the order in which tasks are executed, prioritizing those deemed most important based on factors like urgency, impact, and predefined criteria. Task execution executes tasks by leveraging a sequence of calls to LLMs like GPT-3 and various tools like APIs, databases, or web search. Observation records the results of each task execution, noting successes, failures, and any relevant insights gained during the process. This data serves as a basis for future learning and refinement. Feedback loop utilizes the gathered observations to continuously improve its task prioritization and execution strategies. By analyzing past outcomes, Baby AGI identifies patterns and trends, enabling it to adapt and make more informed decisions in the future. Leverages the LangChain library to facilitate seamless interactions between its diverse components. LangChain acts as the central orchestrator, managing the flow of information and operations within Baby AGI, ensuring smooth and coordinated execution of tasks. Serves as a simple, self-improving agent capable of automating tasks based on user-defined goals. Given a set of objectives, Baby AGI breaks down the work into smaller steps, executes these steps autonomously, and learns from the results to improve its performance over time. It can handle a variety of tasks, including research, data analysis, content generation, and more. Simple and easy to understand, its straightforward design allows users to readily grasp its functionality and how it operates, promoting transparency and ease of use. Highly customizable, its modular architecture enables easy adaptation to different tasks and environments. Users can tailor Baby AGI to their specific needs by adding, modifying, or removing components, tools, and parameters. Can be used for a wide range of tasks. Baby AGI's ability to break down complex tasks and interact with various tools and APIs makes it suitable for diverse applications, from automating tedious tasks to exploring new ideas and generating creative content. Can struggle with complex tasks that require deep reasoning or long-term planning. While Baby AGI excels at breaking down complex tasks, it might struggle with tasks demanding in-depth logical reasoning or extended planning horizons. May be prone to errors and biases due to the limitations of LLMs. LLMs are powerful but can be susceptible to errors, biases, and inconsistencies. This can lead to inaccurate results, particularly when handling tasks requiring meticulous accuracy and nuanced understanding. Requires careful tuning and monitoring to ensure optimal performance. Like any AI system, Baby AGI necessitates careful configuration and ongoing monitoring to guarantee optimal performance. This involves defining appropriate task prioritization strategies, selecting suitable tools, and regularly reviewing outcomes to identify and address potential issues. Autogpt prompt. A detailed description of langchainexperimental.autonomousagents.autogpt.prompt. Autogpt its components, architecture, role, advantages, and challenges. A class that defines the prompt used for AutoGPT. This class is a crucial part of the AutoGPT framework, as it dictates how the user interacts with the AI. The prompt serves as a bridge between the user's instructions and the AI's understanding, ensuring a smooth and effective workflow. Component 1. Autogpt prompt. Prompt template. This is a template used to generate prompts for interacting with AutoGPT. It acts as a blueprint for creating prompts, allowing for consistent formatting and structure. This template can be customized based on specific needs, making it flexible for diverse tasks. Component 2. AutoPrompt.default template. This is a default template used to generate prompts for interacting with AutoGPT. It serves as a pre-built template that provides a basic structure for prompts, suitable for common use cases. This default template can be used as a starting point and can be customized as needed. Component 3. AutoPrompt.default format instructions. These are guidelines for formatting prompts in a way that is easily understood by AutoGPT. They provide specific instructions on how to structure and organize prompts, ensuring that the AI can correctly interpret the user's instructions. This helps to avoid ambiguity and confusion in the communication between the user and the AI. This class defines the prompt that is used by AutoGPT to interact with the user. The architecture of this class is designed to ensure a clear and consistent interface for user interaction with the AI. It provides a structured approach to prompt generation, allowing users to easily communicate their needs and receive meaningful responses. It defines the template and format instructions for the prompt that is used by AutoGPT. The role of this class is crucial in enabling effective communication between the user and the AI. By providing a predefined structure and format for prompts, it ensures that the AI can understand and interpret user input accurately. Provides a consistent format for interacting with AutoGPT. By defining a specific structure for prompts, this class ensures that all interactions with AutoGPT follow a consistent format. This consistency facilitates easier understanding for the AI and makes user interaction more intuitive and predictable. This consistency also enhances the efficiency of the communication process. Allows for customization of the prompt to fit specific use cases. The flexibility to customize the prompt template allows users to tailor the interactions with AutoGPT to their specific needs. This customization can be particularly useful for complex tasks or scenarios requiring specialized instructions. This flexibility empowers users to utilize AutoGPT effectively for diverse use cases. Ensuring the prompt is clear and concise enough for AutoGPT to understand. One of the main challenges in prompt design is ensuring that the prompts are clear, concise, and unambiguous. This is crucial to avoid misunderstandings and ensure that AutoGPT correctly interprets the user's instructions. Making the prompt flexible enough to accommodate a variety of tasks. Another challenge is designing a prompt that is flexible enough to accommodate a wide range of tasks. This requires careful consideration of the different types of tasks that the AI might encounter and ensuring that the prompt is adaptable to those various situations. Response generation chain for Hugging GPT within LangChain's autonomous agents is a chain used for generating responses using a Hugging GPT model. NAN. Definition. The response generation chain is a chain that utilizes a Hugging GPT model to generate responses. It can be used within LangChain's autonomous agents for advanced response generation. For example, it could be used to generate summaries of factual topics, creative text formats, or code snippets. Components. Component 1. The LLM chain is used to process the input and generate a response. This response is then passed to the Hugging GPT model for further processing and generation of the final response. Component 2. The Hugging GPT model is a powerful tool that can be used for a variety of tasks, such as text generation, translation, and summarization. It uses a variety of techniques to generate responses, including a transformer-based neural network. This model is particularly well suited for generating responses that are both accurate and creative. Architecture. The response generation chain utilizes an LLM chain to process the input and generate a response. The response is then passed to the Hugging GPT model for further processing and generation of the final response. The Hugging GPT model enhances the response by leveraging its advanced capabilities in natural language processing. Role. The response generation chain is responsible for generating responses based on the provided input and using the Hugging GPT model for refining the response. It acts as an intermediary between the user's input and the Hugging GPT model, ensuring that the final response is comprehensive and relevant to the input. Advantages. Advantage 1. The response generation chain leverages the capabilities of the Hugging GPT model for advanced response generation. Hugging's capabilities in natural language processing, including text generation, translation, and summarization, allow for high-quality responses that are tailored to the specific input. Advantage 2. The response generation chain provides a streamlined approach for using the Hugging GPT model within autonomous agents. This simplifies the integration of the Hugging GPT model into existing agents, allowing for efficient response generation without requiring complex configurations. Challenges. Challenge 1. The response generation chain requires careful configuration of the Hugging GPT model to ensure appropriate response generation. The model's parameters and settings need to be carefully chosen to ensure that the generated responses are relevant and accurate. For example, if the Hugging GPT model is used to generate creative text formats, the parameters need to be configured to generate text that is grammatically correct and makes sense. Challenge 2. The response generation chain may encounter challenges in handling complex or ambiguous inputs. For example, if the user input is vague or unclear, the Hugging GPT model may generate a response that is irrelevant or incomplete. To address this challenge, the response generation chain can be designed to include mechanisms for clarifying ambiguous inputs or providing feedback to the user if the input is unclear. Components. Definition. A chain for creating tasks from a user prompt. It breaks down a prompt into a series of smaller tasks that can be completed by the agent. For example, if the user prompt is write a blog post about the benefits of using a language model, the task creation chain might break it down into tasks like research the benefits of using a language model, write an introduction for the blog post, write a body paragraph about each benefit, and write a conclusion for the blog post. Components. LLM. Large language model LLM used to generate tasks. An LLM is a type of artificial intelligence AI that can understand and generate human-like text. LLMs are trained on massive data sets of text and code, and they can be used to perform a wide range of tasks, such as writing different kinds of creative text formats, translating languages, writing different kinds of creative content, and answering your questions in an informative way. Task Tracker. A tool that keeps track of tasks that are completed. The task tracker is used to ensure that the agent does not repeat tasks that have already been completed. Architecture. The chain takes a user prompt as input and uses an LLM to break it down into a series of smaller tasks. The chain then returns a list of tasks that can be completed by the agent. For example, if the user prompt is write a blog post about the benefits of using a language model, the task creation chain might return a list of tasks like research the benefits of using a language model, write an introduction for the blog post, write a body paragraph about each benefit, and write a conclusion for the blog post. Role: the task creation chain is responsible for breaking down a user prompt into a series of smaller tasks that can be completed by the agent. This allows the agent to focus on completing one task at a time, rather than trying to complete the entire prompt at once. By breaking down a large task into smaller, more manageable tasks, the task creation chain helps to improve task management and enables efficient task completion. Advantages: improves task management by breaking down large tasks into smaller, more manageable tasks. This makes it easier for the agent to track its progress and avoid getting overwhelmed. Enables efficient task completion by allowing the agent to focus on one task at a time. This helps the agent to complete tasks more quickly and accurately. Challenges: ensuring that the generated tasks are relevant to the user prompt. This can be a challenge because LLMs are not perfect and can sometimes generate tasks that are not relevant to the user's intent. Handling complex user prompts that require multiple steps to complete. This can be a challenge because the task creation chain needs to be able to break down complex prompts into a series of smaller tasks that can be completed in a logical order. langchainexperimental. Autonomous agents. Hugging. Task executor. Task summarization. NAN. A task executor that leverages Hugging GPT to execute instructions using various large language models (LLMs). This executor acts as a bridge between user instructions and the capabilities of different LLMs, enabling complex tasks to be broken down and completed effectively. Component 1. A LangChain component responsible for representing the task to be executed. This component defines the task structure, input parameters, and expected output, providing a clear definition for the Hugging GPT framework to work with. Component 2. A LangChain component that provides access to a vast repository of pre-trained LLMs hosted on the Hugging Face Hub. This component allows the task executor to dynamically select and utilize the most suitable LLM for each specific task based on its requirements. Leverages Hugging GPT, a framework that combines LLMs for task execution and allows for flexible integration of various models. Hugging GPT acts as an orchestrator, coordinating the interaction between different LLMs, breaking down complex tasks into smaller subtasks, and leveraging the unique strengths of each LLM to achieve the desired outcome. Enables the execution of tasks through Hugging GPT, which provides a powerful mechanism to interact with various LLMs and execute complex instructions. The task executor acts as a bridge between user requests and the diverse capabilities of LLMs. It allows users to express their intentions in natural language, which is then translated into actionable instructions for Hugging GPT. Leverages the strengths of multiple LLMs through Hugging GPT for enhanced task execution. By combining the capabilities of different LLMs, Hugging GPT can address tasks that are beyond the scope of any single model. For instance, a task involving both natural language understanding and code generation can be effectively completed by utilizing a language-focused LLM for the initial understanding phase and a code-generating LLM for the code creation phase. Provides a flexible framework for task execution, supporting various LLMs and integrations. The modular nature of Hugging GPT allows for easy integration of new LLMs as they become available, enhancing the framework's capabilities over time. This flexibility ensures that the task executor remains adaptable to evolving language model technologies and diverse task requirements. Requires careful configuration and selection of appropriate LLMs for specific tasks. The choice of LLM can significantly impact the effectiveness of task execution. Understanding the strengths and weaknesses of different LLMs and selecting the most suitable ones for each task is crucial for optimal performance. May face limitations depending on the capabilities and availability of supported LLMs. While Hugging GPT provides access to a wide range of LLMs, the capabilities of each model vary. Certain tasks might require specialized LLMs that are not yet available or integrated into the framework. Additionally, the availability of specific LLMs might be influenced by factors such as licensing restrictions or computational resources. langchainexperimental.autonomousagents.hugging.taskexecutor.task summary. NaN. This task class serves as a bridge between the LangChain framework and the Hugging GPT application programming interface API. It allows users to seamlessly integrate Hugging's advanced natural language processing capabilities into their LangChain workflows, simplifying the process of interacting with and leveraging Hugging's functionality. Component 1. This component encapsulates the core structure of the task. It defines the essential elements and methods that govern the task's execution, including input parameters, processing logic, and output generation. Component 2. This component handles the communication and interaction with the Hugging GPT API. It facilitates the transmission of task instructions and parameters to Hugging GPT, retrieves the generated responses, and translates them into a format suitable for LangChain's workflow. The task class leverages the robust capabilities of the LangChain framework for orchestrating tasks involving Hugging GPT. LangChain provides a powerful and flexible environment for defining, managing, and executing tasks, enabling efficient and streamlined interaction with Hugging GPT within a comprehensive workflow context. This task class acts as an intermediary between the user and Hugging GPT, simplifying the process of utilizing Hugging's functionalities for a wide range of natural language processing tasks. It enables users to easily communicate their requests to Hugging GPT, delegate tasks, and receive the generated responses within the familiar LangChain framework, fostering seamless integration of Hugging's capabilities into diverse applications. Advantage 1. By providing a standardized interface for interacting with Hugging GPT, the task class simplifies the process of utilizing Hugging's features, eliminating the need for users to delve into the complexities of the underlying API or manage intricate communication protocols. Advantage 2. This task class leverages LangChain's powerful task orchestration capabilities, enabling efficient and streamlined execution of complex tasks involving Hugging GPT. This allows users to easily manage multiple steps within a workflow, coordinate the execution of various tasks, and handle dependencies between different components, facilitating a more organized and controlled approach to working with Hugging GPT. Challenge 1. Maintaining consistent and accurate task execution across different Hugging GPT models can be challenging due to variations in model architecture, training data, and parameter configurations. It requires careful consideration and potentially adjustments to the task class to ensure compatibility with diverse Hugging GPT models and maintain reliable performance. Challenge 2. Handling potential errors or inconsistencies in Hugging GPT's responses presents a significant challenge. Hugging GPT models, like any other language models, are susceptible to inaccuracies, biases, and limitations. The task class must incorporate robust error handling mechanisms to identify and manage potential issues with the generated responses, ensuring reliable and accurate results for downstream tasks. A real-world example could be a user wants to translate a document from English to French using Hugging GPT through the task class. The task class sends the document to the Hugging GPT API, receives the translation, and then processes the translated text before passing it back to the user. The task class needs to be able to handle situations where the translation is not accurate or where Hugging GPT encounters an error during processing. For example, the task class could implement a mechanism to identify and highlight potential inaccuracies in the translation or to retry the translation process if an error occurs. langchainexperimental.autonomousagents.babyagi.babyagi.babyagi. An overview. An experimental autonomous agent that utilizes LangChain to achieve goals by decomposing them into smaller tasks, employing tools such as the Internet to accomplish these tasks, and subsequently refining its strategy based on the outcomes. Component 1. LangChain, a framework for constructing applications utilizing language models. LLM, a large language model with the capability of comprehending and generating text that resembles human communication. Tool, a function that can be employed to complete a task, such as conducting internet searches, composing code, or summarizing text. BabyAGI leverages a straightforward yet effective architecture for autonomous execution. It commences with a user-provided goal and iteratively breaks it down into smaller tasks. Each task is executed using available tools, and the results are utilized to enhance the agent's understanding of the goal. The process continues until the goal is attained or a predefined stopping criterion is met. BabyAGI acts as a self-directed agent with the objective of accomplishing a given goal by dissecting it into manageable tasks, executing these tasks using available tools, and iteratively learning from the outcomes. It proves particularly beneficial for tasks that necessitate multiple steps and external information. Automatic task execution. BabyAGI automates task completion by breaking down goals into smaller, actionable steps. For example, if a goal is book a flight, BabyAGI can break it down into tasks such as search for flights, compare prices, and make a reservation. Iterative learning. The agent learns from the results of completed tasks, constantly refining its understanding of the goal and adjusting its plan accordingly. For example, if BabyAGI finds that its initial search for flights did not yield satisfactory results, it can learn from this experience and refine its search criteria in the next iteration. Tool integration. It enables seamless integration with various external tools, allowing for access to a wide range of capabilities. For example, BabyAGI could be integrated with tools such as a travel search engine, a calendar application, and a payment processor to automate the entire process of booking a flight. Tool selection. Choosing the right tool for each task is critical for effective execution. For example, if BabyAGI needs to find information about a specific topic, it needs to select the appropriate search engine or knowledge base. Task prioritization: prioritizing tasks in a way that maximizes progress towards the overall goal is essential. For example, if baby AGI needs to book a flight and also make a hotel reservation, it needs to decide which task to prioritize based on the deadline for each task and the overall importance of each task to the goal. Goal ambiguity: handling ambiguous or incomplete goals requires robust mechanisms for clarification and task refinement. For example, if a user asks baby AGI to find a good restaurant, the agent needs to clarify what good means in this context and then refine its search based on the user's preferences. Robustness: ensuring that the agent can handle unexpected outcomes and errors is vital for reliable execution. For example, if baby AGI is trying to book a flight and encounters an error message, it needs to be able to handle the error and try again or find an alternative solution. Bias and misinformation: mitigating potential biases and inaccuracies in the information used by the agent is important for ethical and reliable operation. For example, if baby AGI is using a search engine to find information, it needs to be aware of potential biases in the search results and take steps to mitigate these biases. Safety and control: developing safeguards to prevent the agent from taking actions that are harmful or violate ethical principles is crucial. For example, baby AGI should not be able to access sensitive information or make decisions that could have a negative impact on the user or society. Langchain-experimental autonomous agents. Hugging GPT summary. NAN. A large language model LLM that acts as a control center for other LLMs, each specializing in a different task. This system effectively streamlines the execution of complex tasks by delegating specific subtasks to specialized LLMs. For example, a task requiring code generation, translation, and summarization can be efficiently handled by employing separate LLMs for each subtask. The control LLM serves as the orchestrator, coordinating the activities of these specialized LLMs. Component 1. Control LLM. This component serves as the central intelligence of Hugging GPT, acting as the coordinator and decision maker. It receives the user's input, analyzes the task, and determines the most appropriate task-specific LLMs to handle the subtasks. The control LLM then provides these LLMs with relevant instructions and manages the communication and coordination between them. Component 2. Task-specific LLMs. These are specialized LLMs trained for specific tasks, such as code generation, image captioning, translation, or summarization. They work in collaboration with the control LLM to fulfill the overall task requirements. This specialization allows for efficient execution and high-quality results in their respective areas. The system employs a hierarchical architecture, with the control LLM acting as a coordinator for various task-specific LLMs. This hierarchical structure enables a clear division of responsibilities and allows for efficient delegation of tasks. The control LLM receives the user's request, analyzes the task, and assigns specific subtasks to the appropriate LLMs. This architecture allows for streamlined execution and optimized performance, as each LLM focuses on its area of expertise. The control LLM orchestrates the execution of tasks by identifying the appropriate task-specific LLM and providing it with relevant instructions. This component serves as the brain of the system, making strategic decisions based on the task requirements. It analyzes the user's request, identifies the necessary subtasks, and selects the most suitable LLMs for each subtask. It then provides these LLMs with clear instructions and manages their communication and coordination to ensure efficient and effective task completion. Efficiency reduces the workload on individual LLMs, allowing them to focus on their specialized areas. This specialization improves the performance of each LLM, enabling them to produce higher quality outputs in their respective domains. By delegating tasks to specialized LLMs, the system avoids overburdening any individual LLM with multiple responsibilities. For example, a single LLM responsible for both code generation and summarization might not perform as well as two specialized LLMs, one focused on code generation and the other on summarization. Flexibility enables the system to adapt to various tasks by utilizing different combinations of LLMs. This flexibility allows Hugging GPT to handle a wide range of tasks by selecting the most appropriate set of specialized LLMs. For example, a task requiring both translation and summarization would be handled by selecting the appropriate translation and summarization LLMs. This dynamic selection of LLMs ensures that the system can adapt to various user requests and fulfill diverse task requirements. Coordination overhead. Managing communication and dependencies between multiple LLMs can be challenging. As the system involves multiple LLMs working together, coordinating their actions and managing dependencies between them can be complex. This coordination involves ensuring that each LLM receives the necessary instructions and that their outputs are integrated seamlessly. Efficient communication and dependency management are crucial for ensuring smooth operation and successful task completion. Task decomposition. Effectively breaking down complex tasks into manageable subtasks for individual LLMs can be difficult. Breaking down complex tasks into smaller, manageable subtasks for individual LLMs requires careful consideration and analysis. This process involves identifying the necessary subtasks, ensuring they are well defined, and determining the most suitable LLM for each subtask. Effective task decomposition is crucial for efficient execution and optimal performance, as it ensures that each LLM is assigned a task aligned with its expertise and capabilities. langchainexperimental. Autonomous agents. Hugging. Task planner. Planning output parser. Description of the class. The Planning Output Parser class is an integral part of the Hugging GPT framework, designed to efficiently parse the output generated by the Hugging GPT task planner and translate it into a format readily usable by the agent. Components of the class. Description of the first component. The primary responsibility of the Planning Output Parser class is to parse the output produced by the task planner. It meticulously extracts crucial information, such as the steps involved in the task and the associated code required for execution. Description of the second component. Moreover, the class adeptly handles any errors that might arise during the parsing process, ensuring a smooth and reliable workflow. Architecture of the class. The Planning Output Parser seamlessly integrates within the architecture of the Hugging GPT agent framework, working in close collaboration with the task planner to guarantee the agent's successful completion of assigned tasks. Role of the class. The Planning Output Parser plays a pivotal role in interpreting the output generated by the Hugging GPT task planner. It acts as a bridge between the planner and the agent, enabling effective communication and execution. Advantages of the class. Description of the first advantage. The planning output parser provides a structured format for the output produced by the task planner, enhancing clarity and organization. This standardized format facilitates efficient processing and utilization of the information by the agent. Description of the second advantage. The parser's ability to handle potential errors encountered during parsing is a critical advantage. It ensures resilience and prevents disruptions in the workflow by gracefully addressing unexpected issues, enhancing the overall robustness of the system. Challenges faced by the class. Description of the first challenge. One of the primary challenges faced by the planning output parser is ensuring its ability to handle diverse output formats generated by the task planner. The task planner may employ different methods or structures to represent its output, requiring the parser to adapt flexibly to accommodate these variations. Description of the second challenge. Another challenge arises from the potential presence of errors in the output produced by the task planner. The parser must be equipped to handle such errors gracefully, identifying and mitigating their impact to maintain the integrity of the workflow. For example, if the task planner outputs invalid code or incomplete steps, the parser should be able to identify and report these issues, enabling the agent to take appropriate corrective actions. Summary of LangChain Experimental Autonomous Agents AutoGPT Output Parser AutoGPT Action. NaN. AutoGPT Action is a class that represents an action that an AutoGPT can take. It encapsulates the details of a specific task that the AutoGPT is asked to perform, including the name of the action, the function to execute it, the arguments to pass to the function, and the parser responsible for interpreting the output of the action. This class provides a standardized structure for actions within the AutoGPT system. Component 1. The action name is a descriptive identifier for the action being performed. It is used to label and track the action throughout its life cycle. For example, an action name could be search web or generate code. Component 2. The action func is a Python function that embodies the actual logic of the action. It receives the specified arguments and performs the desired task. For instance, the search web action might use a web search API like Google Search to retrieve information. Component 3. The action args are a set of parameters passed to the action func to control its execution. They provide specific instructions for the action. For example, in a generate code action, the action args could specify the desired programming language, the code snippet to generate, or the intended purpose of the code. Component 4. The output parser is a component responsible for interpreting the output of the action func. It transforms the raw output into a format that is suitable for the AutoGPT system to understand and use. The output parser can standardize formats, extract key information, and potentially perform further processing on the output before it is passed to the AutoGPT. The AutoGPT Action output parser is designed to ensure consistent and standardized output formats across various actions. The parser typically receives the raw output from the action func and then applies predefined rules and procedures to transform it into a structured format. This architecture facilitates efficient processing and interpretation of action results by the AutoGPT system. The output parser's role is to bridge the gap between the raw output of the action func and the needs of the AutoGPT. It acts as a translator, converting the diverse outputs from different action functions into a uniform representation that is readily understood and utilized by the AutoGPT system. This standardization ensures that the AutoGPT can effectively process and analyze the results of actions regardless of the specific action's implementation details. Standardizes output format. The output parser ensures that all action outputs adhere to a predefined format, regardless of the action func's internal implementation. This consistency simplifies subsequent processing and analysis by the AutoGPT system. For example, the parser might ensure that all search results are presented in a consistent format, regardless of the specific search engine or API used to retrieve them. Simplifies action execution. The output parser can handle the complexities of parsing raw output, allowing the action func to focus solely on executing the desired task. This separation of concerns improves the readability and maintainability of the code by simplifying the action func's responsibilities. For instance, the output parser could take care of parsing raw HTML code from a web page, allowing the search web action to simply retrieve the HTML and pass it to the parser without dealing with the complexities of HTML parsing. Handling complex outputs. The parser needs to be flexible enough to handle a wide range of output formats from different action functions. It might encounter outputs with varying levels of complexity, including nested structures, multiple data types, or dynamic elements. The parser should be capable of parsing and extracting relevant information from these complex outputs to provide the AutoGPT system with the required data. For example, a generate code action might produce code with various language constructs, nested functions, and variable declarations. The parser should be able to extract the essential information from the generated code, such as the code's language, its purpose, and key variables, to allow the AutoGPT to understand and utilize the generated code. Maintaining compatibility with different action functions. The output parser must be adaptable to changes in the output formats produced by different action functions. As new actions are added to the system, the parser needs to be updated to handle the new output formats effectively. This requires a robust and extensible architecture that can accommodate evolving action implementations. For example, if a new action is implemented to interact with a specific application programming interface API, the parser must be updated to understand and interpret the output format of that API. Description of the plan summary in YAML format. NaN. A base class for task planners that utilize Hugging GPT to plan tasks. Hugging GPT is a framework that leverages a large language model LLM to plan and execute tasks in a chain-of-thought fashion. The Base Planner class provides a foundation for building custom task planners that can effectively utilize the capabilities of Hugging GPT. This class acts as a blueprint for creating task planners that can break down complex tasks into smaller, manageable steps, which can be then delegated to different components or tools for execution. Component 1. Base Planner. This component acts as a core structure for the task planner. It provides the framework and logic to organize tasks, manage dependencies, and coordinate the execution of different steps in the planning process. Component 2. Hugging GPT. This component is the heart of the task planner. It utilizes a large language model LLM to understand the user's intentions, decompose the task into smaller steps, and generate a plan of action. Hugging's ability to reason and plan in a chain-of-thought manner allows for robust and flexible task management. The Base Planner class is built upon the Hugging GPT framework, which leverages a large language model LLM to plan and execute tasks in a chain-of-thought fashion. The Base Planner class provides a blueprint for integrating the Hugging GPT framework into custom task planners. Hugging's ability to reason and plan, combined with the Base Planner's structured approach, enables the creation of powerful and adaptable task management systems. The Base Planner class serves as the foundation for building custom task planners that utilize Hugging's capabilities. It provides a standardized way to integrate Hugging's capabilities into different applications. The Base Planner class can be extended and modified to create specialized task planners that address specific needs or domains. This class provides a solid base for building custom task management systems that leverage the power of large language models for planning and execution. Advantage 1. Flexibility and customization. The Base Planner class provides a flexible architecture that allows for tailoring the task planner to specific use cases. This flexibility enables developers to customize the planner to address unique requirements, such as integrating different tools or APIs, implementing specialized planning strategies, or accommodating specific domain knowledge. Advantage 2. Efficient task planning. Hugging's ability to reason and plan in a chain-of-thought manner significantly improves the efficiency of task planning. By breaking down complex tasks into smaller steps and reasoning about the best course of action, Hugging GPT helps reduce the time and effort required for task planning, leading to quicker task completion and improved productivity. Challenge 1. Complex task planning. Planning and executing highly complex tasks can pose a significant challenge. The Base Planner class, while providing a framework for integrating Hugging GPT, needs to be able to handle complex dependencies, intricate relationships between tasks, and potentially unforeseen events that might impact the overall planning process. Challenge 2. Handling uncertainty and errors. Dealing with uncertainty and potential errors during task execution is a crucial aspect of any task planner. The Base Planner class needs to be equipped with mechanisms to handle situations where unexpected events occur or when certain steps in the plan fail. This includes mechanisms for error detection, recovery, and replanning, ensuring that the task planner remains resilient and adaptable even in the face of unforeseen circumstances. langchainexperimental.autonomousagents.auto.output parser. A description of the AutoGPT output parser, explaining its role, functionality, and key aspects. A class responsible for parsing the output of the AutoGPT agent into a structured format. It converts raw output from the agent into a dictionary containing key-value pairs. This parser acts as a bridge between the unstructured text output of the AutoGPT agent and the structured data that is easier for humans and applications to understand and utilize. For instance, if the agent has been tasked with finding the best restaurant in a city, the parser can convert its response into a dictionary with keys like restaurant name, location, cuisine, and rating. This structured output is more readily accessible and useful compared to the original raw text. Component 1. Parse output. This method takes the raw output from the AutoGPT agent and extracts relevant information. This method acts as the core of the parser, responsible for identifying and extracting key pieces of information from the raw text output of the AutoGPT agent. For example, if the agent is providing summaries of news articles, this method might identify the headline, main points, author, and publication date as key pieces of information. Component 2. Format output. This method formats the extracted output into a dictionary, containing key-value pairs that represent the agent's response. After the parse output method has extracted relevant information, this method takes that information and organizes it into a dictionary structure. Each key in the dictionary represents a distinct aspect of the agent's response, and the corresponding value holds the extracted information. For example, if the agent is analyzing data and returning statistics, this method might format the output as a dictionary with keys like average, maximum, minimum, and standard deviation, each containing the respective statistical values. The auto-output parser is designed to work in conjunction with the AutoGPT agent, parsing its output into a usable format. The parser acts as a crucial component of the AutoGPT workflow, ensuring that the agent's outputs are transformed into a format that can be easily understood and utilized. It's designed to be highly flexible, capable of handling a wide variety of output formats generated by the AutoGPT agent. Facilitates the interpretation and organization of AutoGPT's responses, allowing for easy access to important information from the agent's output. The AutoGPT output parser provides a structured and organized way to access the information provided by the AutoGPT agent. Imagine the agent is asked to research a specific topic and returns a large block of text. The parser would analyze this text and extract relevant information such as key points, sources, and supporting evidence. This organized data makes it much easier for users to understand the agent's response and draw conclusions from it. Provides a structured way to access AutoGPT's output. By converting the raw output of the AutoGPT agent into a structured format, like a dictionary, the parser makes it easier to access and utilize the information contained in the agent's response. Consider a scenario where the agent is tasked with finding the top 5 restaurants in a city. The parser might convert the output into a dictionary with each entry representing a restaurant and containing information such as the restaurant's name, address, cuisine, and average rating. This structured output is much easier to work with than the original raw text. Simplifies the process of extracting meaningful data from the agent's responses. The parser handles the complex task of extracting meaningful data from the agent's responses. For example, if the agent is summarizing a news article, the parser can extract the main points, supporting evidence, author, and publication date, presenting this information in a clear and concise format. Handling complex and diverse output formats from AutoGPT. The AutoGPT agent is capable of producing a wide variety of output formats, from simple text responses to complex data structures. The parser faces the challenge of handling this diversity, ensuring that it can accurately identify and extract relevant information regardless of the format of the agent's response. The agent might provide text, tables, lists, code, or even combinations of these formats. The parser needs to be able to adapt to these different formats and extract meaningful information from each. Ensuring accuracy in extracting and interpreting information from the agent's responses. The parser needs to accurately identify and interpret information from the agent's responses. This can be challenging because the agent's responses might be ambiguous or contain inconsistencies. The parser needs to employ advanced techniques to ensure the accuracy of its output. One way to address this is by using natural language processing techniques to analyze the context of the agent's responses. This allows the parser to identify subtle nuances and relationships within the text, improving the accuracy of its extraction process. Summarization of LangChain experimental autonomous agents AutoGPT output parser pre-processed JSON input. Definition. This component acts as a pre-processing step for JSON output generated by large language models LLMs like AutoGPT. It prepares the JSON output for further processing and analysis. Components. Component 1. LangChain's JSON output parser is a component responsible for converting the unstructured output from LLMs into a structured JSON format. It uses various techniques like tokenization, part-of-speech tagging, and dependency parsing to identify and extract relevant information from the LLM's text response. Component 2. AutoGPT's output parser, built upon LangChain's JSON output parser, further enhances the parsing process by incorporating domain-specific knowledge and context. This allows AutoGPT to understand the nuances of its own output and interpret it more accurately. Architecture. AutoGPT's output parser leverages LangChain's JSON output parser as its foundation. LangChain's parser provides the initial structure for converting LLM output into JSON. AutoGPT builds upon this structure by adding its own specialized parsing rules and algorithms tailored for its specific tasks and objectives. Role. The role of this component is to ensure that the output from the LLM, which could be in a variety of formats and styles, is consistently transformed into a structured JSON format. This standardization of output format is crucial for efficient processing and analysis by downstream applications. Advantages. Consistent output format enables seamless integration of LLM outputs into different workflows and applications. It simplifies data processing, analysis, and further use of LLM responses. Improved readability makes it easier for humans to understand and interpret the output from LLMs. This is particularly beneficial for debugging, troubleshooting, and understanding the reasoning behind LLM responses. Challenges. Handling complex JSON structures, especially those containing nested objects and arrays, can be challenging. The parser needs to be robust enough to handle diverse and complex JSON structures without errors or inconsistencies. Ensuring compatibility with different LLMs is another crucial challenge. LLMs may generate output in different formats and styles. The parser needs to be flexible enough to adapt to these variations and maintain consistency across different LLM outputs. Summary of LangChain experimental autonomous agents AutoGPT output parser AutoGPT output parser. NaN. The AutoGPT output parser is a class employed by AutoGPT to interpret the output generated by a large language model LLM. Its primary function is to extract valuable insights from the LLM's response, such as tasks that need to be completed, thoughts or ideas generated, and the reasoning behind the LLM's response. The parser employs a combination of regular expressions and language models to comprehend the context and structure of the LLM's output effectively. For instance, if an LLM is asked to write a blog post about a particular topic, the AutoGPT output parser might extract the key topics, potential headings, and a summary of the main points from the LLM's generated text. This parsed information can then be used by the AutoGPT agent to take appropriate actions, such as refining the blog post, searching for relevant information, or generating further content. Component 1. The auto-output parser class leverages a combination of regular expressions and language models to process the LLM's response. Regular expressions are used to identify specific patterns in the text, such as keywords, phrases, or formatting, while language models are used to interpret the meaning of the text and extract the relevant information. For example, the parser might use a regular expression to identify all the tasks mentioned in the LLM's response, and then use a language model to understand the context of those tasks and determine the appropriate action to take. Component 2. It utilizes a specialized function named parse thoughts to detect and extract thoughts from the LLM's response. This function uses natural language processing (NLP) techniques to analyze the LLM's output and identify sections that contain thoughts or opinions. For example, if the LLM is asked to generate ideas for a new product, the parse thoughts function might extract sentences like a new product could be a smart home assistant or the product could be designed to help people with their daily tasks. These extracted thoughts can then be used by the AutoGPT agent to generate further ideas, refine the product concept, or perform other actions. The auto-output parser exists as a class within the AutoGPT framework. It plays a crucial role in connecting the LLM's output with the internal logic of the agent. It acts as a translator, transforming the LLM's response into structured data that the agent can readily understand and utilize for its subsequent actions. This structured data can then be used by the agent to make decisions, take actions, and ultimately achieve its goals. Imagine a scenario where AutoGPT is tasked with researching a specific topic. After the LLM provides a list of relevant sources, the auto-output parser transforms this list into a structured format, including URLs, titles, and brief summaries. The agent can then use this structured information to efficiently access and analyze the sources, contributing to its overall research process. The auto-output parser plays a critical role in AutoGPT by enabling the seamless integration of outputs from LLMs into the agent's decision-making process. It serves as a mediator, converting unstructured LLM responses into actionable instructions for the agent. This conversion allows the agent to understand and respond to the LLM's output effectively, leading to more efficient and goal-oriented actions. For instance, if the agent is tasked with writing a product description, the LLM might generate a lengthy and unstructured text. The auto-output parser would then extract relevant information, such as product features, benefits, and target audience, and present it to the agent in a structured format. This structured information allows the agent to refine the product description, generate marketing materials, or perform other actions related to the product. Enhanced output understanding. The auto-output parser effectively extracts meaningful information from the LLM's output, enabling efficient decision-making. By transforming the LLM's often unstructured responses into structured data, the parser facilitates a more comprehensive understanding of the LLM's output. This, in turn, enables the AutoGPT agent to make more informed decisions, leading to more effective actions and ultimately achieving its goals. For example, if the agent is asked to summarize a lengthy research paper, the parser can extract key findings, conclusions, and supporting evidence from the LLM's output. This allows the agent to effectively summarize the paper and present its findings in a concise and coherent manner. Improved agent efficiency. The structured output from the parser streamlines the agent's workflow, enabling it to process information more quickly and efficiently. By providing the agent with structured data, the parser eliminates the need for the agent to manually parse and interpret the LLM's output, significantly improving its efficiency. For instance, if the agent is tasked with scheduling meetings, the parser can extract meeting times, attendees, and locations from the LLM's output and automatically create calendar events. This streamlined workflow allows the agent to efficiently manage its schedule and focus on other tasks. Handling ambiguous responses. The parser may face challenges when interpreting ambiguous or unclear LLM outputs. LLMs, despite their advanced capabilities, can sometimes produce responses that are difficult to interpret. For instance, the LLM might provide a response that is incomplete, contradictory, or irrelevant to the given task. In these cases, the parser might struggle to extract meaningful information or provide accurate guidance to the agent. Adapting to diverse LLM outputs. The parser needs to be adaptable enough to handle the diverse styles and formats of responses from various LLMs. LLMs are developed by different organizations and may employ different techniques and approaches for generating text. This can result in responses with varying styles, formats, and levels of complexity. The parser must be able to adapt to these variations and extract relevant information from a wide range of LLM outputs. This challenge is particularly important considering the ongoing development of new and more sophisticated LLMs, which will likely introduce even more diverse output styles. langchainexperimental. Autonomous agents. Baby agi. Task execution. Task execution chain. Definition: Task execution chain is a LangChain component enabling task execution through a given tool. It is employed by Baby AGI for task execution, accepting a task, a tool, and an optional execution chain as input. The execution chain can be a chain that assists in formatting the task for the tool or processing the output from the tool. For instance, if the task is to obtain the weather forecast from a weather application programming interface API using the task execution chain, the tool could be a weather API. The execution chain could format the task request to the Weather API and parse the output from the Weather API into a human-readable format. Components. Component 1. Task execution chain is a LangChain component that allows the execution of tasks using a given tool. Component 2. This component is used by Baby AGI to execute the tasks. Component 3. The component takes a task, a tool, and an optional execution chain as input. Component 4. The execution chain can be a chain that helps to format the task for the tool or to process the output from the tool. Architecture. The task execution chain is a component that allows the execution of tasks using a given tool. The component is used by Baby AGI to execute the tasks. Role. The task execution chain plays an important role in Baby AGI by allowing the execution of tasks using a given tool. Advantages. Advantage 1. The task execution chain is a flexible component that can be used with any tool. Advantage 2. The component can be used with an optional execution chain to help format the task for the tool or to process the output from the tool. Challenges. Challenge 1. The task execution chain is a relatively simple component, and may not be able to handle complex tasks. Challenge 2. The component may not be able to handle cases where the tool output is not in the expected format. LangChainExperimental Autonomous Agents Hugging GPT Task Planner Task Planning Chain. A summary as a YAML dictionary. The fully qualified Python class name that implements the task planning chain. This class is located within the langchainexperimental.autonomousagents.hugging.taskplanner module. It combines different language model LLM chains to generate a plan for a given task. Component 1. A chain that uses a large language model LLM to generate text. This LLM could be any of the many powerful language models available through Hugging Face's Transformers library. The chain takes a prompt, which is a piece of text that instructs the LLM on what to do, and returns a generated text output. Component 2. A chain that takes a task description and generates a plan to complete it. The plan typically consists of a sequence of steps, each designed to achieve a specific part of the overall task. Component 3. A chain that integrates tools into the planning process. This chain can access external tools, such as APIs, databases, and other applications, and use them to gather information or execute actions. Hugging GPT, a framework for using large language models to complete tasks, uses the task planning chain as its central planning mechanism. This chain leverages specialized language models from Hugging Face to generate a plan for a given task. The plan is a sequence of steps that use different tools to complete the task effectively. The task planning chain acts as the core element for planning within Hugging GPT. It provides a mechanism for breaking down complex tasks into smaller, manageable steps that can be executed using a combination of tools. The task planning chain utilizes Hugging's advanced language models, allowing for sophisticated and comprehensive plan generation. These language models can understand the task's nuances and complexities, resulting in well-defined plans. The chain seamlessly integrates with various tools, expanding its capabilities to handle a diverse range of tasks. This integration enables the chain to access and utilize various APIs, databases, and other applications to complete the task effectively. The generation of accurate and effective plans requires a thorough understanding of the task. The task planning chain needs to accurately interpret the task description and understand its underlying requirements. The execution of the generated plan can face challenges due to tool limitations or unexpected situations. The task planning chain might rely on external tools that could have limitations or might encounter unforeseen circumstances during execution, causing errors in the plan. LangChainExperimental Autonomous Agents Auto-Output Parser Pre-Process JSON Input. Definition. This function is responsible for pre-processing the JSON input that is received by the AutoGPT agent. It ensures that the input is in a consistent and usable format for the agent to process. For example, it converts the raw JSON string into a Python dictionary, handles different data types within the JSON and converts them into formats suitable for the agent's operations, and catches any exceptions that may occur during the processing of the input. Components. Component 1. JSON parsing converts the raw JSON string into a Python dictionary. This component uses libraries like JSON.loads to parse the input JSON string. Component 2. Data type conversion handles different data types within the JSON and converts them into formats suitable for the agent's operations. This might involve converting strings to integers, floats, or booleans. Component 3. Error handling catches any exceptions that may occur during the processing of the input. This could include handling syntax errors, invalid data types, or other unexpected issues in the JSON input. Architecture. The pre-processed JSON input function acts as a gateway between the external world and the AutoGPT agent. It receives raw JSON data, processes it, and then passes it on to the agent for further actions. It enables communication between the AutoGPT agent and external services or data sources. Role. Ensure that the data received by the AutoGPT agent is in a consistent format that is readily usable for the agent's tasks. By ensuring consistent data format, it simplifies the agent's internal logic and avoids errors. Advantages. Standardized input ensures that the agent consistently receives data in a specific format, simplifying its internal logic. For example, if the agent is designed to work with data in a specific dictionary format, this component ensures that it receives data in that format, regardless of the source. Error prevention catches potential errors during data processing, reducing the risk of unexpected behavior in the agent. For example, if the JSON input contains invalid data types or syntax errors, this component can catch these errors and prevent them from causing unexpected behavior in the agent. Challenges. Handling complex data structures. Complex nested JSON objects may require specific handling and data transformation. For example, if the JSON input contains nested lists or dictionaries, it might need to be flattened or restructured to make it suitable for the agent's tasks. Performance considerations. Pre-processing large JSON files can have performance implications. This is especially true if the processing involves complex data transformations or if the JSON input is very large. Techniques like optimized parsing algorithms and efficient data transformation can be used to mitigate these performance challenges. Langchain experimental chat models. NAN. Chat models are designed for conversational interactions. They are a type of artificial intelligence model that can understand and generate human-like text in response to prompts or questions. These models are trained on vast amounts of text data, allowing them to learn patterns and nuances of human language. Chat models are used in a wide range of applications, including chatbots, virtual assistants, and content generation. Component 1. Chat models are the core of conversational AI. They serve as the foundation for building interactive and engaging experiences with users. These models act as the brain behind conversational systems, enabling them to understand user input, process information, and formulate relevant responses. Component 2. Chat models can understand and generate human-like text. They are trained to comprehend the nuances of human language, including syntax, semantics, and context. This capability allows them to interpret user queries and generate responses that are coherent, grammatically correct, and contextually appropriate. These models are built upon transformer-based architectures. Transformer architectures are a type of neural network that excel at processing sequential data, like text. They leverage attention mechanisms to analyze relationships between words in a sentence, enabling them to understand the context and meaning of the input. They enable building conversational agents capable of engaging in meaningful interactions. Chat models are the key component for creating interactive conversational experiences. They power chatbots, virtual assistants, and other AI systems designed to interact with humans in a natural and engaging way. By understanding user intent and providing relevant responses, these models facilitate seamless communication and information exchange. Advantage 1. Can engage in open-ended conversations. Chat models excel at handling open-ended conversations, where the flow of the dialogue is not predetermined. They can maintain context throughout the conversation, allowing for dynamic and spontaneous interactions. For instance, a chatbot powered by a chat model can adapt to user-driven topics, delve into various subjects, and provide responses that align with the conversation's direction. Advantage 2. Can generate creative and informative responses. Chat models are trained on vast data sets of text and code, enabling them to generate a wide range of creative and informative content. From writing stories and poems to composing music and summarizing complex information, these models can be used to produce diverse forms of content. They can be utilized for brainstorming, creating original content, and providing concise summaries of factual information. Challenge 1. Can be prone to biases and generate inappropriate content. Chat models are trained on massive data sets of text, which can include biased or inappropriate content. This can lead to the models reflecting these biases in their output, generating offensive or insensitive responses. The training data needs careful selection and filtering to mitigate bias. Challenge 2. Maintaining consistency in long conversations can be difficult. Sustaining consistency in long conversations is a challenge for chat models. As the conversation progresses, the model needs to remember the previous turns and maintain a coherent dialogue flow. This requires sophisticated memory management and context-aware responses to prevent inconsistencies and ensure a natural conversational experience. Langchainexperimental chat models. Elaborated features. Experimental chat models within the LangChain framework, designed to provide a versatile and user-friendly interface for interacting with various large language models (LLMs). Component 1. Chat models equipped with prompt templates, facilitating the creation of specific instructions for the models, and fuse hot learning capabilities, enabling them to learn and adapt from a limited number of examples. This allows for fine-tuning the model's behavior and enhancing its performance for specific tasks. For example, a chat model designed for summarizing news articles can be trained on a few sample articles and their corresponding summaries, allowing it to effectively generate concise summaries for new articles. Component 2. Support for multiple language models, enabling the utilization of various LLMs within a unified framework. This flexibility allows users to choose the most suitable model for their needs, whether it's a smaller, more efficient model for casual conversations or a more powerful model for complex tasks like code generation or scientific writing. The ability to switch between different models provides adaptability and allows for experimenting with various LLM capabilities. Provides a consistent application programming interface API for interacting with diverse chat models. This consistent interface simplifies the integration process for developers, enabling them to utilize different models without needing to adapt their code for each specific model. The unified architecture promotes code reusability and ease of implementation, fostering a streamlined workflow. For example, a developer can create a chatbot application using LangChain's experimental chat models and easily switch between different models to explore their performance or cater to specific user preferences without significant code changes. Enable seamless integration with various LLMs for chat-based interactions. This allows for a unified approach to creating conversational applications, utilizing the strengths of different LLMs without needing to manage complex integrations individually. The seamless integration fosters a user-friendly experience, allowing developers to focus on crafting engaging conversational flows rather than managing intricate technical details. Simplifies access to chat models, enabling developers to utilize LLMs without the need for complex setup or configurations. This ease of access fosters a more rapid development cycle, allowing developers to quickly incorporate chat functionality into their projects. Offers a unified way to work with different models, providing a single framework for managing and interacting with various LLMs. This fosters a more cohesive approach to conversational AI development, enabling developers to explore and utilize different model strengths without needing to learn separate frameworks or APIs. Limited functionality compared to standard chat models, as they are still under development and may not possess all the capabilities of more mature models. This may limit their applicability for complex tasks or highly specific use cases. Still under active development, indicating a constant evolution of functionality and improvements in performance. This can be a challenge for developers who need stable and consistent functionality in their applications, as features may change or be deprecated during the development process. langchainexperimental.chatmodels.llm wrapper Nan. A wrapper around a chat model that allows you to use it with the chat interface. This means that you can use the chat wrapper to interact with different chat models in a consistent way, without having to worry about the specific details of each model. Component 1. Chat model. This represents the actual underlying chat model that the chat wrapper will use to generate responses. It could be any chat model that implements the generate response method. Callbacks. These are optional functions that you can use to observe or modify the behavior of the chat wrapper. For example, you could use a callback to log the messages that are being exchanged between the chat wrapper and the chat model, or to modify the prompt that is sent to the chat model. Verbose. This determines whether the chat wrapper will print information about its actions to the console. This is helpful for debugging purposes. Component 2. Chat model. This is a private attribute of the chat wrapper that stores a reference to the underlying chat model. It is used internally by the chat wrapper to interact with the chat model. Callbacks. This is a private attribute of the chat wrapper that stores a list of callbacks that will be executed during the interaction with the chat model. Verbose. This is a private attribute of the chat wrapper that determines whether the chat wrapper should be verbose during execution. It inherits from the base chat class, which provides a basic interface for interacting with chat models. The chat wrapper implements the call method, which is responsible for handling user requests and returning responses. When you call the chat wrapper with a user prompt, it passes the prompt to the underlying chat model, generates a response, and then returns the response to the user. It simplifies the process of using chat models with the chat interface by providing a consistent and easy-to-use way to interact with different chat models. This makes it easier for you to write code that can work with a variety of chat models without having to rewrite your code for each model. Provides a consistent interface for interacting with different chat models. This means that you can use the same code to interact with different chat models, without having to change your code. For example, you could use the chat wrapper to interact with both the OpenAI API and the Hugging Face Transformers library. Allows you to use the chat interface with any chat model that supports the Generate Response method. This means that you can use the chat wrapper to interact with a wide variety of chat models, including both publicly available models and custom models that you have trained yourself. For example, you could use the chat wrapper to interact with a model that you have trained on a specific domain of knowledge. The wrapper may need to be updated if the underlying chat model changes. If the underlying chat model changes its API, the chat wrapper may need to be updated to work with the new API. This is because the chat wrapper relies on the underlying chat model's API to function correctly. The wrapper relies on the underlying chat model to be able to generate responses. If the underlying chat model is not able to generate responses, then the chat wrapper will not be able to generate responses either. For example, if the underlying chat model is offline or has an error, the chat wrapper will not be able to generate responses. Challenges. Potential for compatibility issues with future versions of the Mixtral large language model or LangChain. This highlights the need for ongoing maintenance and updates to ensure continued compatibility between the wrapper and the underlying technologies. Handling errors and exceptions effectively. This requires robust error handling mechanisms within the wrapper to ensure stability and reliability when working with the Mixtral model. langchainexperimental.chatmodels.llm wrapper. This YAML document provides an in-depth description of LangChain experimental chat models, exploring their definition, components, architecture, role, advantages, and challenges. It aims to give a comprehensive overview of these models within the context of LangChain, a framework for building applications powered by large language models. These chat models are still under development within the LangChain framework, offering access to the latest advancements in conversational artificial intelligence AI capabilities. They are designed to seamlessly integrate with other components within LangChain, facilitating the creation of sophisticated AI applications. Component 1. These models are the fundamental elements of conversational AI, empowering applications to comprehend and produce text that resembles human communication. They are trained on vast data sets of text and code, enabling them to engage in natural-sounding dialogue, answer questions, summarize information, and generate creative content. A real-world example is a chatbot for customer service, where a chat model can understand customer inquiries and provide relevant responses, simulating a human interaction. Component 2. Designed with user-friendliness in mind, these models are easily integrated with other components within the LangChain ecosystem. This streamlined integration simplifies the development process for building complex AI applications. For instance, a developer could readily combine a LangChain experimental chat model with other components like retrieval modules to create a chatbot that retrieves relevant information from a knowledge base to answer user queries. The foundation of LangChain experimental chat models is a blend of cutting-edge AI models, specialized libraries, and the robust LangChain framework. This integration facilitates efficient communication and seamless integration with other components within the LangChain ecosystem. A common example is the use of transformer-based language models, such as GPT-3 or Lambda, combined with LangChain's modular architecture for building conversational AI applications. These models play a crucial role in equipping LangChain applications with conversational AI capabilities. They enable applications to engage in meaningful and dynamic interactions with users, making the experience more natural and engaging. Imagine a virtual assistant powered by a LangChain experimental chat model, capable of understanding user requests, providing information, and completing tasks, all through natural language interactions. These models grant access to cutting-edge conversational AI capabilities, enabling the development of highly engaging and interactive applications. Developers can create innovative AI experiences that are both informative and entertaining, engaging users in more meaningful ways. Think of a gaming experience that incorporates a LangChain experimental chat model to create dynamic and responsive characters that adapt to player actions. Seamless integration with other LangChain components simplifies the development process, enabling rapid prototyping of complex AI solutions. This streamlined development process allows developers to quickly iterate on their designs and test new functionalities, accelerating the development of sophisticated AI applications. For example, a developer could combine a chat model with a knowledge base to create a chatbot that retrieves answers from the knowledge base to user queries, demonstrating the power of LangChain's modularity. Experimental chat models are still under development, and rapid updates or changes may occur, requiring frequent adjustments in application code. Developers need to be adaptable and embrace the dynamic nature of these models, adjusting their code as updates are released. This requires close monitoring of updates and active maintenance to ensure application compatibility. These models might exhibit less stability or reliability than established chat models, potentially leading to unexpected behavior or performance issues. This could necessitate careful error handling and testing in application code to mitigate potential issues and ensure a consistent user experience. Developers may need to employ strategies for handling errors and gracefully degrading functionality in scenarios where the model's performance is unpredictable. LangChain experimental.chatmodels.llmwrapper.orca. A detailed explanation of the LangChain experimental chat models LLM wrapper Orca module, including its definition, components, architecture, role, advantages, and challenges. LangChain's Orca wrapper enables interaction with the Orca model via the chat model's application programming interface, allowing for easier integration within LangChain applications. This wrapper simplifies the process of using the Orca model within LangChain applications. It provides a streamlined interface for interacting with the Orca model, reducing the complexity of direct API calls and allowing developers to focus on building their applications. Component 1. LangChain is an open-source framework for building and deploying language models. It provides a wide range of tools and utilities for working with language models, including pre-processing text, generating responses, and building complex conversational agents. LangChain simplifies the development process by providing a consistent interface for interacting with different language models. Component 2. The Orca model is a large language model developed by Microsoft. It is known for its ability to perform various tasks, including text generation, translation, summarization, and question answering. Orca is a powerful tool that can be integrated into various applications to enhance their capabilities. The Orca wrapper leverages LangChain's chat model's application programming interface to interact with the Orca LLM. This architecture enables seamless communication between the Orca model and LangChain applications. It leverages LangChain's capabilities for managing interactions with language models, providing a robust and efficient way to utilize the Orca model within LangChain applications. Enables seamless integration of Orca within LangChain applications. The Orca wrapper acts as a bridge between the Orca model and LangChain applications, allowing developers to easily incorporate the powerful capabilities of Orca into their projects. It provides a streamlined interface for accessing and utilizing the Orca model, simplifying the integration process and reducing the need for complex code implementations. Simplified integration. The wrapper simplifies the integration of the Orca model into LangChain applications, reducing the complexity of direct API calls and allowing for a more straightforward implementation. Leverages LangChain's functionality. The Orca wrapper benefits from the extensive functionality provided by LangChain, including text pre-processing, response generation, and conversational agent building. It leverages these capabilities to enhance the overall integration and functionality of the Orca model within LangChain applications. Potential for model limitations. As with any language model, the Orca model may have limitations in certain areas, such as factual accuracy, bias, and potential for generating inappropriate content. These limitations should be considered when using the model and appropriate safeguards should be implemented. Dependence on Orca API availability. The Orca wrapper relies on the availability of the Orca application programming interface. Potential changes or outages to the API could impact the functionality of the wrapper and its integration with LangChain applications. langchainexperimental. Comprehend moderation. Amazon comprehend moderation. Amazon comprehend moderation chain. A comprehensive description of the Amazon comprehend moderation chain, encompassing its definition, components, architecture, role, advantages, and challenges. A chain that utilizes Amazon comprehend for text moderation, leveraging the power of Amazon Comprehend's application programming interfaces APIs for analyzing and classifying content. For instance, it can be used to identify potentially harmful language in online forums or social media platforms. Component 1. Amazon Comprehend Moderation Chain utilizes the Amazon Comprehend service, which is a natural language processing NLP service that provides text analysis capabilities for identifying various aspects of text, such as sentiment, entities, and key phrases. It can analyze text to understand its overall sentiment: positive, negative, neutral, identify named entities, people, organizations, locations, and extract key phrases. Component 2. The chain employs a specific function, classify text, for executing text moderation. This function leverages the power of Amazon Comprehend's NLP capabilities to classify text content into various moderation categories, such as safe, unsafe, or hate speech. The chain is structured as follows. It employs Amazon Comprehend's classify text function to process text and obtain moderation labels. It takes input text and passes it to the classify text function. The function analyzes the text and assigns moderation labels based on the identified content. The chain then outputs the moderation labels along with the original text. The chain serves the purpose of moderating text content by analyzing it and identifying potentially inappropriate or harmful language. It plays a vital role in safeguarding online communities by filtering out harmful content and promoting a safer online environment. Advantage 1. Utilizing Amazon Comprehend's robust text analysis capabilities. Amazon Comprehend's comprehensive NLP capabilities offer accurate and efficient text analysis, enabling the chain to effectively identify and classify potentially harmful content. This ensures the chain's effectiveness in maintaining a safe and respectful online environment. Advantage 2. The chain is designed to be scalable and efficient for moderating large volumes of text. It can handle a large number of text inputs simultaneously, making it ideal for platforms with a high volume of user-generated content. This scalability and efficiency ensures that moderation is performed promptly and effectively, preventing the spread of harmful content. Challenge 1. The chain requires an active Amazon Comprehend account with appropriate permissions to function correctly. This means that users need to have an existing Amazon Comprehend account with the necessary permissions to access and utilize the service. Accessing and using the service requires careful configuration and management to ensure optimal performance. Challenge 2. The moderation results provided by Amazon Comprehend are not always perfect and may require fine-tuning or further analysis. The chain's effectiveness is dependent on the accuracy of Amazon Comprehend's analysis. There may be instances where the analysis does not accurately identify harmful content, requiring manual review or further analysis. This emphasizes the importance of continuous improvement and refinement of the moderation process to achieve optimal results. langchainexperimental. Comprehend moderation. Base moderation. Base moderation. A detailed description of the given YAML file, expanding each scalar value with its context. A base class for moderation tools. This class provides a foundational structure for building tools that filter and moderate content based on predefined rules and policies. It serves as a blueprint for creating various moderation systems, enabling the customization of specific filtering and moderation logic according to individual requirements. Component 1. Get content from doc. Extracts content from a document. This method processes the input document and retrieves the relevant content to be moderated. For example, it might extract text from a PDF file, extract the body of a web page, or parse a structured document to identify the specific content that needs moderation. Get moderation results retrieves moderation results. This method interacts with the chosen moderation service, e.g., an API or a local model, to obtain the results of the moderation process. It takes the extracted content and sends it to the moderation service, then receives the moderation results, which typically include flags, scores, and potentially explanations for the moderation decision. Get response formats the moderation response. This method processes the raw moderation results received from the service and transforms them into a user-friendly and understandable output. It might involve summarizing the moderation decision, highlighting flagged content, and providing additional contextual information, making it easier for users to understand and interpret the moderation results. Component 2. Moderate moderates the content. This method is the central function of the moderation tool, orchestrating the entire moderation process. It combines the functions of get content from doc, get moderation results, and get response to perform content moderation in a sequential manner. It first extracts content from the input, then sends the content to the moderation service, and finally formats the moderation response for presentation to the user. Provides a base structure for moderation tools. The base moderation class establishes a common framework for developing moderation tools. This structure defines the core components, methods, and interactions that are essential for any moderation system. It ensures consistency in design and functionality across different moderation tools, making it easier to understand, maintain, and extend. Defines core functionalities and methods for moderation. The base moderation class defines the core functionality of a moderation system. It outlines the essential steps and methods involved in content moderation, such as extracting content, sending it to a moderation service, receiving moderation results, and presenting the results to the user. This class acts as a foundation, ensuring that all moderation tools adhere to a common set of core functionalities. Offers a standardized interface for moderation tasks. The base moderation class provides a unified interface for interacting with moderation tools. This standardized interface makes it easier to switch between different moderation tools without requiring extensive code changes. It also allows for the development of reusable moderation modules, enhancing code efficiency and maintainability. Enables easy extension and customization for specific moderation needs. The base moderation class supports customization and extension, allowing developers to tailor the moderation process to specific requirements. This flexibility allows for the creation of specialized moderation tools designed to handle different types of content, moderation rules, and service integrations. Requires implementation of specific moderation logic within subclasses. The base moderation class provides a generic framework, but it requires developers to implement the specific moderation logic within subclasses. This implementation can be complex, involving decision-making regarding moderation rules, service integrations, and output formatting. Handling diverse content formats and moderation rules can be complex. The base moderation class needs to handle diverse content formats and moderation rules. This complexity arises from the need to support various input formats, interpret different types of moderation policies, and integrate with different moderation services, which can have varying requirements and functionalities. langchainexperimental.chatmodels.llm-wrapper.llama2chat. This YAML file describes a Python class named llama2chat that provides a wrapper for Llama 2 chat models. The class is part of the LangChain library and simplifies the process of interacting with Llama 2 models. Detailed definition of the variable goes here. This class provides a wrapper for the Llama 2 chat models. It simplifies the process of interacting with the model by providing a consistent interface for generating responses and managing sessions. Components. Component 1. A wrapper class for the Llama 2 chat models. The llama2chat class acts as a wrapper for the Llama 2 chat models. It provides a way to interact with the model's application programming interface API without directly using the underlying libraries like transformers. Component 2. Provides methods for interacting with the model, including generating responses and managing sessions. The class offers methods for interacting with the Llama 2 model, such as generating responses to prompts and managing chat sessions. For example, a user could input a prompt using the run method of the llama2chat object, and the method would interact with the Llama 2 model through its API to generate a response. Description of the architecture supporting the variable. This class utilizes the transformers library to load and interact with the Llama 2 model. It implements the chat model interface from the LangChain library, which defines the standard way for interacting with chat models within the LangChain framework. uses the Transformers library for loading and interacting with the Llama 2 model. The LLaMA2CHAT class leverages the Transformers library, which is a popular library for working with various Transformer models, including Llama 2. It allows the class to access the Llama 2 model's API and perform operations like generating responses. Implements the chat model interface from the LangChain library. The LLaMA2CHAT class implements the chat model interface from the LangChain library. This ensures that the class conforms to the standard way of interacting with chat models within LangChain. By adhering to this interface, the LLaMA2CHAT class can be seamlessly integrated with other components within the LangChain ecosystem, such as prompt templates and chains. Explanation of the variable S role in the system. The LLaMA2CHAT class simplifies the process of using Llama 2 chat models in the LangChain framework. It provides a consistent interface for interacting with different Llama 2 models, making it easier for developers to build conversational applications without having to directly deal with the complexities of the Llama 2 API. Provides a convenient way to use Llama 2 chat models within the LangChain framework. The class serves as a bridge between LangChain's tools and the Llama 2 models, simplifying the process of using these powerful models. For example, the class can be used within a LangChain chain to generate responses for a conversational chatbot, ensuring a smooth workflow. Simplifies the process of interacting with the model, allowing users to focus on building conversational applications. The LLaMA2CHAT class provides a user-friendly interface for interacting with the Llama 2 model, abstracting away the complexities of the model's API. This allows developers to focus on building the conversational logic and user experience of their applications without being bogged down by technical details. Allows for easy integration with other LangChain components. The LLaMA2CHAT class is designed to work seamlessly with other components within the LangChain framework, such as prompt templates and chains. This makes it easy to incorporate Llama 2 chat models into a variety of applications. For instance, a developer could combine the LLaMA2CHAT class with a LangChain chain to create a chatbot that retrieves information from a database and then uses the Llama 2 model to generate a human-like response. Provides a consistent interface for interacting with various Llama 2 models. The LLaMA2CHAT class provides a consistent interface for interacting with different versions and configurations of the Llama 2 model. This means that developers can easily switch between different models without having to rewrite their code, making it easier to experiment with various models and find the best fit for their application. Requires the installation of the Transformers library. The LLaMA2CHAT class depends on the Transformers library to function, which requires installation. While the Transformers library is a common and widely used library, it may need to be installed explicitly in environments where it is not already present. May have limitations depending on the specific Llama 2 model used. The LLaMA2CHAT class may have limitations depending on the specific Llama 2 model used. For example, some models might have restrictions on the length of inputs or outputs, or they may not be optimized for certain tasks. Therefore, developers should choose the appropriate Llama 2 model for their application and consider the limitations of the selected model. langchainexperimental. Comprehend moderation. Base moderation config. Moderation prompt safety config. NaN. The moderation prompt safety config is a configuration object used for defining the parameters for moderation of prompts. It has attributes to customize the behavior of prompt moderation, including the allowed content, banned phrases, and the level of strictness for moderation. This configuration allows for fine-grained control over prompt moderation, ensuring that generated content is appropriate for the intended audience. Component 1. A list of content types that are permitted in the prompt. For example, allowed content can include news, stories, or code. This restricts the type of content that can be generated. Component 2. A list of phrases or words that are not allowed in the prompt. This could include offensive language, discriminatory terms, or specific names. Component 3. The level of strictness for prompt moderation. This can range from low to high, influencing the sensitivity of the moderation process. A higher level of strictness might flag more content as inappropriate, while a lower level might allow for more flexibility. Component 4. The maximum number of tokens allowed in the prompt. This can be used to limit the length of prompts and control the computational resources required for processing. Component 5. The minimum number of tokens allowed in the prompt. This can be used to ensure that prompts are not too short or incomplete. Component 6. The maximum length of the prompt in characters. This can be used to limit the length of prompts and control the computational resources required for processing. Component 7. The minimum length of the prompt in characters. This can be used to ensure that prompts are not too short or incomplete. Moderation Prompt Safety Config is a configuration class designed to provide fine-grained control over prompt moderation. It leverages the power of Amazon Comprehend to perform content moderation and enforce specific content restrictions. Amazon Comprehend is a natural language processing NLP service that uses machine learning to analyze text and understand its meaning. Moderation Prompt Safety Config plays a critical role in ensuring the safety and appropriateness of prompts used in language models and applications. It provides a means to define and enforce content guidelines, protecting users from inappropriate content and ensuring a safe and enjoyable user experience. For example, in a chatbot application, the Moderation Prompt Safety Config can ensure that the chatbot does not generate responses containing offensive language or hateful content. Advantage 1. Increased control over content generation, ensuring that the generated text meets specific requirements and avoids inappropriate content. This is essential for applications where the generated content is public-facing or used in sensitive contexts. Advantage 2. Improved user experience by providing a safe and controlled environment for generating and interacting with language models. Users can feel confident that the content they encounter is appropriate and free from harmful content. Challenge 1. Striking the right balance between content moderation and creative freedom. Too strict moderation can stifle creativity, while overly permissive moderation can lead to inappropriate content generation. For example, a content moderation system that is too strict might block legitimate creative expressions, while a system that is too permissive might allow harmful or offensive content to be generated. Challenge 2. Keeping up with the evolving nature of content and language. New forms of inappropriate content and language can emerge, requiring regular updates to moderation rules. The emergence of new slang, online communities, and forms of communication requires constant adaptation to ensure that moderation systems are effective. For example, a moderation system might need to be updated to recognize and block new types of offensive content that emerge on social media platforms. langchainexperimental. Comprehend moderation. Base moderation callbacks. Base moderation callback handler. A description of the base moderation callback handler class and its components. A base class for moderation callbacks. This class serves as the foundation for building custom moderation logic within applications. It provides a standardized framework for developers to interact with the moderation process and customize its behavior. Component 1. A class that inherits from this class will be called at different stages of the moderation process. For example, a moderation callback could be invoked when a user submits content for review or when a moderation system flags potentially inappropriate content. Component 2. This class provides a structure for developers to implement their own moderation callbacks. Developers can extend the functionality of the base moderation callback handler by creating custom callback classes that handle specific moderation tasks or events. The base moderation callback handler class serves as a foundation for custom moderation callbacks. It provides a basic structure for defining the core functions and methods that a moderation callback needs to implement. This allows developers to build on this foundation and create custom callbacks tailored to their specific needs. It provides a standardized structure for interacting with the moderation process and customizing behavior. The base moderation callback handler class defines a common interface for moderation callbacks, ensuring that different custom callbacks can interact seamlessly with the moderation system. Provides a structured approach to implementing moderation callbacks. This structured approach simplifies the process of developing custom moderation logic by providing a clear framework to work within. Enables developers to extend moderation functionality. By inheriting from the base moderation callback handler, developers can create custom callbacks that handle specific moderation needs, such as filtering content based on specific criteria or integrating with external moderation services. Implementing custom moderation logic can be complex. This involves understanding the intricacies of moderation algorithms, identifying appropriate moderation criteria, and designing custom logic to handle different scenarios. Ensuring compatibility with existing moderation systems may require careful consideration. Custom moderation callbacks need to be designed to integrate seamlessly with the existing moderation system to avoid conflicts or inconsistencies. langchainexperimental. Comprehend moderation. Base moderation config. Moderation toxicity config summary. A description of the moderation toxicity config class, its purpose, components, and overall role within the context of Amazon comprehends moderation capabilities. Components. Component 1. Amazon Comprehend is a service for natural language processing, offering a suite of tools for analyzing text data. It provides capabilities for understanding the meaning and structure of text, identifying entities, and performing sentiment analysis. One of its key features is content moderation, which helps identify and flag potentially harmful or offensive content. Component 2. Moderation toxicity config is a class that provides a configuration for Amazon Comprehend moderation, allowing users to customize the moderation process and define specific parameters for identifying potentially toxic or offensive content. This configuration class allows for fine-grained control over the moderation process, enabling developers to tailor the detection thresholds and rules to their specific needs and use cases. For example, developers can adjust the sensitivity level to match their platform's content policies, prioritizing the detection of severe forms of toxicity while allowing for some less severe forms to pass through. This configuration utilizes Amazon Comprehend's moderation capabilities, allowing for the detection of potentially offensive or inappropriate content in text. It leverages Amazon Comprehend's pre-trained machine learning models to analyze text and identify potential issues. The Moderation Toxicity Config class allows users to customize the moderation process by configuring parameters such as the sensitivity level, the specific types of toxicity to detect, and the actions to take when potentially toxic content is detected. Moderation Toxicity Config plays a vital role in filtering out inappropriate content, ensuring a safer and more positive user experience. This class acts as a gatekeeper, analyzing incoming text and flagging potentially harmful content, allowing developers to take appropriate actions, such as blocking the content, providing warnings to users, or taking other measures to protect the platform and its users from inappropriate content. By leveraging Amazon Comprehend's advanced natural language processing capabilities, Moderation Toxicity Config contributes to a more responsible and safe online environment. Improves content moderation accuracy, allowing for a more precise identification of potentially harmful content. This results in a reduced number of false positives, ensuring that appropriate content is not flagged unnecessarily. Streamlines the process of identifying potentially offensive content, providing a standardized and efficient way to analyze text and identify potential issues. This simplifies the moderation process, allowing developers to focus on other aspects of their application. May not catch all forms of toxicity, as the detection of toxicity is a complex task, and there are various ways in which toxicity can be expressed. Even with advanced machine learning models, there is always the possibility that some forms of toxicity may not be recognized. Requires careful fine-tuning for optimal performance. Achieving accurate and efficient moderation requires careful consideration of the specific context and the type of content being moderated. This involves understanding the nuances of language, culture, and the intended audience. Developers need to adjust the configuration parameters, such as the sensitivity level, to ensure that the moderation process effectively identifies the specific types of toxicity that are relevant to their application. langchainexperimental.comprehend moderation.base moderation exceptions.moderation pi error. NaN. The moderation pi error exception is raised when potentially personally identifiable information PII is detected in the input text. This exception is designed to help developers proactively identify and mitigate risks associated with exposing sensitive information. For instance, if a user inputs text containing a social security number or credit card details, the moderation pi error exception would be raised, alerting the developer to the presence of potentially sensitive information. This allows the developer to implement appropriate safeguards, such as redacting the PII or preventing its further processing, to protect user privacy and comply with data protection regulations. Component 1. Moderation pi error inherits from the base exception class, providing a standardized way to handle errors. This inheritance structure allows the moderation pi error exception to be caught and handled similarly to other standard exceptions in Python. This consistent error handling approach makes it easier for developers to integrate the moderation pi error exception into their existing error management strategies. Component 2. The exception includes a PII details attribute, which stores details about the detected PII, such as the type and location. This attribute provides valuable information to developers, enabling them to understand the nature of the detected PII and its context within the input text. For example, the PII details attribute could indicate that a social security number was detected in the third sentence of the input text. This granular information empowers developers to make informed decisions about how to handle the detected PII, potentially allowing for more precise and targeted mitigation strategies. The moderation PII error exception is integrated into the LangChain moderation framework, enabling developers to detect and handle PII issues within their applications. LangChain is a popular framework for building and deploying language models, and the moderation PII error exception is a crucial component of its moderation capabilities. This integration allows developers to leverage the power of LangChain's moderation features while simultaneously ensuring responsible handling of potentially sensitive information. The primary role of moderation PII error is to signal the presence of potentially sensitive information in the input text, allowing developers to take appropriate actions. By raising the moderation PII error exception, the LangChain moderation framework effectively acts as a sentinel, alerting developers to the potential risks associated with PII exposure. This proactive approach empowers developers to implement appropriate mitigation measures, such as anonymizing the data or preventing its further processing, to protect user privacy. Improves data privacy by raising awareness of potential PII exposure. By proactively identifying and signaling the presence of PII, the moderation PII error exception promotes a data privacy-conscious development workflow. This helps developers to be mindful of the potential impact of their applications on user privacy and to implement safeguards to protect sensitive information. Facilitates proactive risk mitigation by providing details about the detected PII. The PII details attribute within the moderation PII error exception provides valuable information about the type and location of the detected PII. This detailed information allows developers to understand the nature of the risk and implement appropriate mitigation strategies. For example, if the detected PII is a social security number, the developer might implement a strategy to redact the social security number or prevent the input text from being processed further. Determining the accuracy of PII detection might require further refinement of the underlying detection mechanisms. Identifying PII within text can be a complex task, as the definition of PII can vary depending on context and regulations. The underlying detection mechanisms used by the LangChain moderation framework might require further refinement to improve their accuracy and reduce the incidence of false positives. Handling PII detection scenarios in a diverse range of applications may necessitate tailored solutions. Different applications have different requirements and sensitivities around handling PII. For example, an application processing medical records might have stricter requirements for PII protection compared to an application processing social media posts. The moderation PII error exception provides a foundation for handling PII detection scenarios, but tailored solutions may be necessary to address the specific needs of different applications. langchainexperimental chat models. A description of LangChain's experimental chat models. LangChain's experimental chat models are a collection of specialized chat models designed for various purposes, including conversational artificial intelligence AI, summarization, and code generation. These models are still under development and may not be as stable as production-ready models. Component 1. Chat models are a collection of pre-trained models which are used to generate human-like text. Component 2. Experimental features are those features which are still under development and may not be stable. These models leverage the powerful capabilities of large language models LLMs like GPT-3 and integrate them with LangChain's framework. They are built on top of the LangChain core, which provides a modular and extensible infrastructure for developing and deploying conversational artificial intelligence AI applications. LangChain's experimental chat models provide developers with a flexible and adaptable toolset for exploring the potential of LLMs in various domains. These models serve as a platform for experimentation, allowing researchers and developers to test new ideas and approaches in natural language processing. Advantage 1. Specialized functionality allows the models to be tailored for specific tasks and can be used to perform specific functions like question answering, text summarization, and code generation. Advantage 2. Flexibility and adaptability means that they can be easily integrated into different applications and can be customized to meet the specific needs of different users. For example, a chat model can be customized to provide information about a specific topic or to generate text in a particular style. Challenge 1. Stability and reliability can be a concern as these models are still under development and may not be as stable as production-ready models. Challenge 2. Limited production readiness means that these models may not be suitable for use in production environments. langchainexperimental.chatmodels.llm-wrapper.vicuna. A detailed description of the Vicuna LLM wrapper's features and functionalities. This wrapper is designed to simplify the integration of the Vicuna large language model LLM into applications built using the LangChain framework. By providing a consistent interface and streamlined interactions, it allows developers to seamlessly incorporate Vicuna's advanced language generation and comprehension capabilities into their LangChain projects. Component 1. LangChain is a powerful framework that simplifies the development and deployment of complex language-based applications. It provides a comprehensive suite of tools and components for interacting with and orchestrating various large language models LLMs. LangChain facilitates building applications that leverage the capabilities of LLMs, such as natural language understanding, text generation, and information retrieval, by providing a standardized interface and a collection of building blocks for interacting with LLMs. For instance, LangChain can be used to create chatbots, document summarizers, question answering systems, and other applications that require advanced language processing capabilities. Component 2. Vicuna is a large language model renowned for its impressive conversational abilities. It has been trained on a vast dataset of text and code, enabling it to engage in natural-sounding dialogues and generate human-like text. Vicuna's conversational capabilities are particularly well-suited for tasks like chatbot development, where it can provide engaging and informative interactions with users. Furthermore, its understanding of code allows it to assist in programming-related tasks, such as code generation and documentation. This wrapper leverages the strengths of LangChain to provide a consistent and user-friendly interface for utilizing Vicuna within LangChain applications. It acts as a bridge between Vicuna and the LangChain framework, allowing developers to interact with Vicuna's capabilities through the familiar LangChain API. This architecture ensures that developers can leverage Vicuna's powerful language processing capabilities while benefiting from the robust tools and functionalities provided by LangChain. This wrapper serves as a bridge between the Vicuna LLM and the LangChain framework, enabling seamless integration of Vicuna's capabilities into LangChain projects. It acts as an intermediary, allowing developers to interact with Vicuna through the familiar LangChain API. This bridge simplifies the process of incorporating Vicuna into LangChain applications and allows developers to leverage Vicuna's advanced language processing capabilities without having to directly interact with its underlying infrastructure. Simplifies integration. This wrapper simplifies the process of incorporating Vicuna into LangChain workflows. Developers can use Vicuna's capabilities within their LangChain applications without having to write extensive custom integration code. This streamlining enables developers to quickly integrate Vicuna into their projects and begin utilizing its powerful language processing capabilities. Consistent interface. This wrapper provides a unified approach for interacting with Vicuna within LangChain, promoting code reusability and maintainability. The wrapper provides a consistent API for interacting with Vicuna, regardless of the specific task or application. This consistency simplifies the development process, allowing developers to reuse code across different parts of their application and maintain a consistent coding style. Limited control. This wrapper may lack fine-grained control over Vicuna's internal parameters. While the wrapper provides access to Vicuna's core functionalities, it may not expose all of Vicuna's internal parameters or settings. This limitation could restrict the ability to fine-tune Vicuna's behavior for specific applications. Dependency. This wrapper requires the installation of both LangChain and Vicuna. To utilize this wrapper, developers need to ensure that both LangChain and Vicuna are installed in their development environment. This dependency could potentially increase the setup time and complexity of projects that utilize this wrapper. However, the benefits of using this wrapper, such as streamlined integration and a consistent interface, may outweigh this potential challenge. LangChain experimental comprehend moderation base moderation exceptions moderation PI error. Definition. This exception is raised when a moderation check detects personally identifiable information PII in the input text. For example, if a text contains a social security number, credit card number, or email address, the moderation check will raise this exception. Components. Component 1. Moderation PII error is a subclass of base moderation exception. This means it inherits properties and methods from the base moderation exception class, allowing for consistent error handling and management across different types of moderation exceptions. Component 2. It inherits from base moderation exception. This ensures that moderation PII error shares common functionalities and behaviors with other moderation exceptions in LangChain, promoting code reusability and maintainability. Architecture. This exception is part of the LangChain moderation framework. LangChain is a powerful library that offers a modular framework for building and deploying language models. The moderation framework within LangChain provides a set of tools and exceptions to ensure responsible and ethical use of language models, especially when dealing with sensitive information like PII. Role. Moderation PII error indicates that the input text contains PII and should be handled accordingly. This exception is essential for preventing the accidental exposure or misuse of sensitive information during interactions with language models. For instance, if an application using LangChain receives input containing PII, the application should be able to handle this exception appropriately, such as redacting the PII or alerting the user. Advantages. helps identify and mitigate potential privacy risks. By raising this exception, LangChain provides a mechanism to detect and address potential privacy violations early on, promoting responsible data handling practices. Enables developers to implement appropriate handling for PII-containing content. By providing a clear signal of the presence of PII, moderation PII error allows developers to integrate custom logic for handling such content, ensuring compliance with privacy regulations and ethical guidelines. For example, developers can use this exception to trigger redaction of PII, anonymization techniques, or user notification mechanisms. Challenges: ensuring accurate PII detection. Accurately identifying PII in text is a challenging task, as PII can manifest in various forms and contexts. The complexity of natural language and the evolving nature of data privacy regulations make it difficult to create a foolproof PII detection mechanism. Providing meaningful context for identified PII. When PII is detected, it is crucial to provide sufficient context to understand the reason for the detection and the nature of the identified PII. This context is crucial for developers to make informed decisions on how to handle the PII. langchainexperimental.chatmodels.llm wrapper.llama 2 chat summary. Nan. The langchainexperimental.chatmodels.llm wrapper.llama 2 chat is a wrapper class designed to simplify the integration of the Llama 2 chat model within the LangChain framework. It leverages the Hugging Face Transformers library, a powerful tool for interacting with various language models, including the Llama 2. Component 1. The Hugging Face Transformers library is a comprehensive toolkit for working with various language models, including Llama 2. It provides a streamlined way to load, pre-process, and interact with models, making it a vital component of the LLaMA2 wrapper. Component 2. The Llama 2 chat model is a large language model developed by Meta. It's designed for conversational interactions, capable of generating coherent and contextually relevant responses to prompts and questions. The LLaMA2 wrapper enables seamless interaction with this powerful model within the LangChain ecosystem. The LLaMA2 wrapper relies on the Hugging Face Transformers library for its core functionality. It utilizes this library to load the Llama 2 model and handle its interactions with the LangChain framework. This architectural approach streamlines the process of integrating the Llama 2 chat model within LangChain, enabling users to leverage its conversational capabilities with minimal effort. The primary role of the LLaMA2 wrapper is to provide a convenient interface for using the Llama 2 chat model within LangChain. This wrapper simplifies the integration process, making it easier to incorporate the Llama 2 model's capabilities into various LangChain applications. By abstracting away the complexities of direct interaction with the model, the wrapper allows users to focus on building their applications rather than managing the intricacies of model integration. The wrapper offers a streamlined integration experience with LangChain. This allows users to easily incorporate the Llama 2 chat model into existing or new LangChain projects without needing to delve into the intricacies of direct model interaction. The wrapper simplifies interaction with the Llama 2 chat model. It provides a user-friendly interface that allows users to communicate with the model in a natural and straightforward manner, simplifying the process of utilizing its powerful language capabilities. One potential challenge is compatibility issues that might arise due to specific versions of the Hugging Face Transformers library. This could lead to compatibility issues between the wrapper and other components within a LangChain application, requiring careful version management. The wrapper's functionality relies on external libraries, specifically the Hugging Face Transformers library, for model loading and execution. This dependency might introduce challenges related to library availability, installation, and potential compatibility conflicts within different environments. While the LLAMA2CHAT wrapper aims to provide a standardized interface, it might require developers to be mindful of potential dependencies on specific versions of the Llama 2 chat model. Different versions of the model might have varying capabilities, and changes in the model's behavior could require adjustments in the wrapper or the surrounding application logic. For instance, a new version of the Llama 2 chat model might introduce new features or change the format of its outputs, requiring updates to the wrapper or the application code to ensure compatibility. Limited customization options for the underlying model. The LLAMA2CHAT wrapper provides a streamlined interface for interacting with Llama 2 chat models, but it might offer limited customization options for the underlying model. Developers may not have complete control over specific model parameters or configurations, potentially limiting their ability to fine-tune the model's behavior to meet specific application requirements. For example, developers might not be able to adjust the model's temperature parameter, which controls the randomness of its output, or they might not have access to certain model settings that could influence its performance. langchainexperimental.comprehend moderation. Base moderation exceptions. Moderation toxicity error summary. NaN. This exception is raised when the Amazon Comprehend Moderation Application Programming Interface API returns a toxicity score that exceeds the predefined threshold. The toxicity score is a numerical value that reflects the likelihood of a given text containing harmful or offensive content. The threshold is a user-configurable parameter that determines the level of toxicity that is considered unacceptable. Component 1. This component represents the exception class itself, which is responsible for handling the scenario where the Amazon Comprehend Moderation API detects potentially harmful or offensive content in the input text. It provides a mechanism to signal to the calling code that moderation has flagged the content as toxic and should be handled accordingly. Component 2. This component refers to the Amazon Comprehend Moderation API, which is a service provided by Amazon Web Services (AWS). It uses machine learning models to analyze text content and assess the likelihood of it containing harmful or offensive language. The API returns a toxicity score along with other moderation-related information. The architecture of the moderation toxicity error exception revolves around the interaction with the Amazon Comprehend Moderation API. When the API returns a toxicity score above the specified threshold, the exception is triggered. This exception serves as a signal to the application that the content is flagged as potentially toxic and appropriate actions should be taken. The moderation toxicity error exception plays a crucial role in content moderation by providing a mechanism to handle situations where the Amazon Comprehend Moderation API identifies potentially harmful or offensive content. This exception allows the application to take appropriate actions, such as displaying a warning, removing the content, or applying other moderation policies. The moderation toxicity error exception provides a mechanism for developers to handle potentially toxic content detected by the Amazon Comprehend Moderation API. By raising this exception, the application can implement specific actions, such as alerting users, filtering content, or taking other appropriate steps to ensure a safe and respectful online environment. This exception enhances content moderation capabilities by providing a structured way to handle situations where the Amazon Comprehend Moderation API flags content as potentially toxic. This allows developers to integrate the API's moderation features more effectively into their applications, creating a safer and more controlled user experience. One of the key challenges is configuring the toxicity threshold effectively. Setting the threshold too low might result in false positives, where harmless content is incorrectly flagged as toxic. Conversely, setting the threshold too high might miss potentially harmful content, compromising the safety of the platform. Another challenge is tailoring the exception to specific use cases. Different applications may have different tolerance levels for toxicity, and the moderation policies may vary based on the context. It is important to carefully configure the exception and its associated actions to align with the specific needs of the application. For instance, a social media platform might have a stricter threshold for toxicity compared to a forum for discussions on sensitive topics. langchainexperimental.comprehendmoderation.promptsafety.comprehend prompt safety. Definition: a class that utilizes Amazon Comprehend to identify potentially inappropriate content within prompts before those prompts are transmitted to the large language model (LLM). This class acts as a safety measure to prevent the LLM from receiving input that might lead to harmful or undesirable outputs. Components. Component 1. Amazon Comprehend, a natural language processing service provided by Amazon Web Services (AWS). It offers a range of capabilities for analyzing text, including sentiment analysis, entity recognition, and language detection. In this context, Comprehend's ability to detect potentially inappropriate content is leveraged for prompt safety. Component 2. LangChain is an open-source framework that facilitates the development of applications incorporating large language models. It provides a comprehensive set of tools for interacting with LLMs, including prompt engineering, data retrieval, and chain building. Comprehend Prompt Safety integrates with LangChain to enhance the safety of LLM applications by filtering prompts before they are sent to the LLM. Architecture. The architectural design of Comprehend Prompt Safety relies on Amazon Comprehend's Application Programming Interface API to analyze prompts for potential inappropriate content. This involves submitting the prompt text to the Comprehend API, which then processes the text and returns a determination about its appropriateness. Role. This class serves as a protective mechanism to prevent potentially harmful or inappropriate content from being passed to the large language model. By analyzing prompts for inappropriate content before they reach the LLM, Comprehend Prompt Safety aims to mitigate the risk of the LLM generating harmful or undesirable outputs. Advantages. Comprehend Prompt Safety offers the benefit of helping to prevent large language models from generating outputs that are harmful or inappropriate. This is achieved by filtering prompts for potentially offensive or undesirable content before they are sent to the LLM. For instance, if a prompt contains hate speech or offensive language, the safety mechanism can prevent the LLM from generating text that reflects or amplifies such content. This class provides a mechanism to enhance the safety of applications that utilize large language models. By implementing Comprehend Prompt Safety, developers can introduce a layer of protection to mitigate the risk of their applications producing harmful or inappropriate outputs. This is particularly important when dealing with applications that interact directly with users, where the generation of offensive or harmful content could have negative consequences. Challenges. One of the challenges associated with Comprehend prompt safety is the potential for it to miss certain types of inappropriate content. While Amazon Comprehend is a powerful tool for text analysis, it might not be able to identify all forms of inappropriate content, especially if they are subtle or context-dependent. This limitation highlights the ongoing need for comprehensive and robust safety mechanisms in LLM applications. The integration of Comprehend prompt safety into the LLM request pipeline can introduce latency, as it requires an additional step to analyze the prompt before sending it to the LLM. This latency might be noticeable in applications that prioritize speed or real-time responses. It is crucial to balance the need for safety with the performance requirements of the application when deciding whether to implement Comprehend prompt safety. langchainexperimental. Comprehend moderation. Base moderation exceptions. Moderation toxicity error details. NaN. Moderation toxicity error signifies issues in the text, triggering a block. Components. Name error type. This is an error triggered when the text content is deemed toxic by the moderation system. Name trigger. This error is triggered when the content contains harmful or inappropriate language, including but not limited to hate speech, harassment, or threats. For example, if a user posts a comment containing racial slurs or violent threats, the moderation system may flag it as toxic. Name impact. If this error is triggered, the text will be blocked from being displayed or shared. This error inherits from base moderation exception, part of LangChain. Role. The error signals when a text fails moderation due to detected toxicity. Advantages. Enforces safe content. By flagging toxic content, this error helps ensure a safe and welcoming environment for all users. Helps prevent harmful text. This error helps protect users from being exposed to harmful or offensive content, such as hate speech, harassment, or threats. Challenges. Potential for false positives. The moderation system may sometimes incorrectly flag content as toxic, leading to the censorship of legitimate expression. For instance, a sarcastic comment or a discussion about sensitive topics might be misidentified as toxic. May hinder legitimate expression. Blocking content based on toxicity detection can potentially stifle legitimate expression. For example, a satire or parody piece could be flagged as toxic even if its intent is not to harm. Needs accurate toxicity detection. The effectiveness of this error depends on the accuracy of the toxicity detection system. If the system is not accurate, it may lead to false positives and negatively impact user experience. Could cause content censorship. The moderation system may block content that is not actually toxic, potentially leading to censorship. This could hinder freedom of expression and limit access to important information. Requires a robust moderation system. Implementing a robust moderation system that accurately identifies toxic content without hindering legitimate expression is crucial. This requires ongoing development and improvement of the system's algorithms and parameters. May impact user experience. If users experience frequent false positives, they may become frustrated with the moderation system and limit their participation in online communities. Needs to be reviewed and improved. The moderation system should be regularly reviewed and improved to minimize false positives and ensure that it effectively identifies and blocks toxic content. Requires careful parameter tuning. The moderation system's parameters need to be carefully tuned to balance the need for a safe environment with the need to protect free expression. langchainexperimental.pull.base.cpal chain. A description of CPAL chain and its components, architecture, role, advantages, and challenges. A chain that uses a combination of a language model and a code execution engine to solve problems. For example, a user might ask CPAL chain to write a Python script that scrapes data from a website and then analyzes the data. The language model would generate the Python code, and the code execution engine would run the code and return the results to the language model. The language model would then interpret the results and provide the user with a summary of the data. Component 1. The language model is used to generate the code and to interpret the results of the code execution. For example, if the user asks CPAL chain to write a Python script to scrape data from a website, the language model would generate the Python code. After the code is executed, the language model would interpret the results, which might be a list of data points. Component 2. The code execution engine is used to run the generated code and return the results to the language model. For example, if the language model generated a Python script to scrape data from a website, the code execution engine would run the script and return the scraped data to the language model. CPAL chain uses a two-step process to solve problems: code generation and code execution. First, the language model generates code based on the user's request. Second, the code execution engine runs the generated code and returns the results to the language model. The language model then interprets the results and provides the user with a response. CPAL chain can be used to solve problems that require both natural language understanding and code execution. For example, CPAL chain could be used to automate tasks such as writing code, analyzing data, and generating reports. Can solve complex problems that require both natural language understanding and code execution. For example, CPAL chain could be used to build a chatbot that can understand natural language and perform actions based on the user's requests. Can be used to automate tasks that are currently performed manually. For example, CPAL chain could be used to automate the process of writing code, analyzing data, and generating reports. The language model must be able to generate code that is both correct and efficient. For example, the language model should be able to generate code that is free of errors and that runs efficiently. The code execution engine must be able to handle a variety of programming languages and environments. For example, the code execution engine should be able to run code written in Python, JavaScript, and other popular programming languages. langchainexperimental.comprehendmoderation.py.comprehend PII. This YAML file describes the langchainexperimental.comprehendmoderation.py.comprehend PII class, which leverages Amazon Comprehend for PII detection. The class definition, components, architecture, role, advantages, and challenges are outlined. A class to use Amazon Comprehend for PII detection. A class that utilizes Amazon Comprehend to detect and mask personally identifiable information PII in text. This class is designed to automatically identify and mask PII within text data. It utilizes Amazon Comprehend's powerful natural language processing capabilities to analyze text and identify potential sensitive information. This process ensures data privacy and compliance by preventing the accidental disclosure of sensitive information. Component 1. A natural language processing service that analyzes text for insights and understanding. Amazon Comprehend is a CLUD-based service offered by Amazon Web Services AWS. It provides various natural language processing (NLP) functionalities, including sentiment analysis, topic modeling, and entity recognition. For PII detection, Comprehend utilizes its entity recognition capabilities to identify and classify different types of PII, such as names, addresses, and social security numbers, within text data. Component 2. A framework for building and deploying language models, facilitating the integration of Comprehend for PII detection. LangChain is an open-source framework that simplifies the development and deployment of language models. It offers a modular and flexible approach to integrating different NLP models, including Amazon Comprehend, into applications. For PII detection, LangChain acts as a bridge between the Comprehend API and the application, enabling easy access and utilization of Comprehend's capabilities. The architecture leverages LangChain to interact with Amazon Comprehend, enabling the identification of PII within text data. The architecture of the Comprehend PII class follows a layered approach. LangChain serves as the core framework for orchestrating the entire process. It connects to the Amazon Comprehend Application Programming Interface API using its pre-built integration modules. This connection allows the class to send text data to Comprehend for analysis. Comprehend then analyzes the text and returns a list of identified PII entities. These entities are then processed by the class to either mask or remove them from the original text, effectively protecting sensitive information. This class serves as a tool for protecting sensitive information by detecting and masking PII within text, ensuring data privacy and compliance. The Comprehend PII class plays a critical role in data privacy and compliance. It acts as a safeguard against the accidental disclosure of sensitive information by automatically detecting and masking PII within text data. For example, in a customer support chatbot application, the class can identify and mask customer names, addresses, or financial details from the conversation transcripts, ensuring that this sensitive information is not exposed to unauthorized individuals. This proactive approach helps organizations comply with data privacy regulations and maintain the confidentiality of sensitive information. Automates the process of identifying PII, reducing manual effort and potential errors. One of the key advantages of the Comprehend PII class is its ability to automate the process of identifying PII. This automation eliminates the need for manual review, which can be time-consuming and prone to errors. By automatically identifying and masking PII, the class ensures consistency and accuracy in data privacy practices, reducing the risk of human error and oversight. Helps safeguard sensitive data by masking PII, mitigating risks of data breaches and privacy violations. The Comprehend PII class directly contributes to improving data security by masking PII within text data. This masking process effectively removes or replaces sensitive information, making it difficult for unauthorized individuals to access or misuse it. By mitigating the risks of data breaches and privacy violations, the class helps organizations comply with data privacy regulations and build trust with their customers and stakeholders. Requires proper configuration and access to Amazon Comprehend application programming interface, including credentials and account setup. Setting up and configuring the Comprehend PII class requires access to the Amazon Comprehend Application Programming Interface API and proper account setup. This involves obtaining API credentials, configuring the necessary permissions, and setting up the connection between the class and the Comprehend API. This initial setup process may involve some technical expertise and require careful attention to security protocols to ensure proper access and authentication. The detection process might require optimization for handling large volumes of text data efficiently. When dealing with massive amounts of text data, the PII detection process can become computationally intensive. Optimizing the detection process for efficiency is crucial to ensure timely results without impacting the performance of other applications. This optimization may involve techniques like parallelization, data partitioning, and efficient algorithm selection to handle large data sets efficiently. Langchain-experimental CPAL base intervention chain. Description of a chain to intervene during the execution of a chain. A chain designed to intervene during the execution of another chain, used in conjunction with CPAL chain of prompt and language. It provides a mechanism to dynamically adjust the behavior of the primary chain based on conditions and feedback. Component 1. CPAL chain. This refers to a chain of prompts and language models that performs a specific task. For example, this could be a chain for generating summaries of articles or answering questions. Component 2. Intervention function. A function that can be called during the execution of the CPAL chain. The intervention function can analyze the current state of the execution, make decisions based on predefined logic, and modify the execution flow or the output of the CPAL chain. For instance, the intervention function could decide to skip certain steps in the CPAL chain or introduce new steps based on the current context. The CPAL base intervention chain combines a CPAL chain with an intervention function. The CPAL chain runs the main task, while the intervention function acts as a control mechanism that can be triggered at different points during the execution. The intervention function's role is to analyze the execution progress, potentially make modifications to the task or the execution process, and provide feedback to the CPAL chain to adapt its behavior dynamically. The CPAL base intervention chain enables dynamic control over the execution of a chain. It can be utilized for various purposes, such as conditional execution. The intervention function can determine whether certain parts of the CPAL chain should be executed based on specific conditions. Imagine a scenario where a question answering chain should only proceed to a specific step if the user's question is related to a particular topic. The intervention function can check the question and decide whether to continue or skip certain parts of the chain. Dynamic modification. The intervention function can modify the execution of the CPAL chain based on feedback. For instance, an intervention function might analyze the output of a step in the CPAL chain and, based on its analysis, adjust the next step in the chain to improve the outcome. This dynamic modification could involve providing more context to the next step, selecting different language models, or even rerunning previous steps with modified prompts. Error handling: the intervention function can detect and recover from errors during the execution of the CPAL chain. If an error occurs, the intervention function can analyze the error, potentially attempt to correct it, or even skip the step that caused the error and continue the execution of the chain. Flexibility: the intervention function provides a powerful mechanism to dynamically control the execution of a chain. This flexibility enables the chain to adapt to various situations and user requests, making it more versatile and adaptable to real-world scenarios. Imagine a chain for summarizing articles. The intervention function could dynamically determine the desired level of detail in the summary based on user preferences or even the length of the original article. Extensibility: the intervention chain is highly extensible, as you can implement custom intervention logic to address specific needs or challenges. The intervention function is not limited to predefined functions but allows you to tailor the intervention process to the specific requirements of your application. Imagine a chain for generating creative writing. You might implement an intervention function to ensure the generated text adheres to specific stylistic guidelines or themes. Complexity: implementing the intervention function can be complex, as it requires careful consideration of the intervention logic, the communication between the intervention function and the CPAL chain, and the potential impact of the intervention on the execution process. The design and implementation of the intervention function should be well thought out to ensure it functions as intended without introducing unintended consequences. Performance: frequent intervention calls can impact the overall performance of the chain. The intervention function might introduce overhead due to the analysis and decision-making processes involved. This is especially relevant in applications where the intervention function is called frequently during the execution of the chain. It's important to consider the performance impact and optimize the intervention function to minimize overhead and maintain a reasonable execution speed. langchainexperimental. Comprehend moderation. PII. Comprehend PII. A langchain component for detecting PII. A langchain component that leverages Amazon Comprehend to identify and mask personally identifiable information PII within text. Component 1. A CLUD-based natural language processing NLP service offered by Amazon Web Services AWS that provides a range of functionalities for understanding and analyzing text, including entity recognition. Amazon Comprehend is used in this context to identify and categorize different types of PII within text, such as names, addresses, and social security numbers. Component 2. A powerful framework that enables building and connecting different components to create sophisticated language-based applications. It serves as the foundation for this PII detection component, providing the necessary infrastructure for integrating Amazon Comprehend with other language-based workflows. This component utilizes Amazon Comprehend's PII Entity Recognition Application Programming Interface API to detect sensitive information within text. The API allows for the identification and classification of different PII types, providing a comprehensive approach to data privacy protection. Facilitates responsible use of text by identifying and masking PII. This is achieved through automated analysis of text data, enabling proactive detection and mitigation of potential privacy breaches. The process of identifying PII within text is automated. This eliminates the need for manual review, saving time and effort while improving the consistency and accuracy of PII detection. Ensures enhanced data privacy. By identifying and masking PII, this component helps protect sensitive information from unauthorized access and use. Requires AWS credentials to access and utilize the Amazon Comprehend service for PII detection. This requirement necessitates the configuration of AWS credentials for proper functionality of the component. The PII types identified by Amazon Comprehend are limited to those supported by the service. This means that certain types of PII may not be detected, potentially requiring additional mechanisms or customization. For optimal accuracy, fine-tuning may be required. The component's performance can be impacted by factors such as the quality and nature of the text data being analyzed. In certain cases, adjustments to the configuration or training data might be necessary to achieve the desired level of accuracy in PII detection. langchainexperimental.pull.models.causal model summary. NaN. Causal model is a subclass of langchain model, specifically designed for working with causal language models. This class serves as a foundation for integrating and interacting with causal language models within the langchain framework. Component 1. Causal language models (CLMS) are a type of language model that predict the next token in a sequence, utilizing the context of the preceding tokens. These models function by analyzing the preceding sequence of words or tokens in a text and predicting the most likely subsequent token based on the learned patterns and relationships. Component 2. CLMS often rely on transformer architectures, known for their ability to learn long-range dependencies in text. Transformer architectures employ attention mechanisms to weigh the importance of different words in a sequence, enabling the model to capture long-range contextual relationships between words. Causal model leverages the capabilities of CLMS for tasks such as text generation, translation, summarization, and question answering. By harnessing the predictive power of CLMS, causal model facilitates a wide range of language-based tasks within the langchain framework. For instance, text generation involves utilizing the CLM to predict the next token in a sequence, forming a coherent text. Translation tasks leverage the CLMS ability to understand different languages and generate corresponding translations. Summarization relies on the CLMS capability to extract key information from a text and concisely present it. Finally, question answering utilizes the CLMS knowledge to understand and answer user questions. Causal model acts as an interface for interacting with causal language models within the langchain framework. As an intermediary, causal model allows developers to easily integrate and interact with various causal language models, simplifying the process of utilizing their capabilities within the langchain ecosystem. It provides a consistent and standardized way to access and leverage CLMS, regardless of the specific underlying model. Advantage 1. Causal language models excel at generating fluent and coherent text. By analyzing the context and patterns in the input text, CLMS can generate grammatically correct and semantically consistent text, making them valuable for tasks like writing articles, creating stories, and crafting realistic dialogue. Advantage 2. They can adapt to various tasks through fine-tuning or prompt engineering. The adaptability of CLMS allows them to be tailored for specific tasks by adjusting their parameters or training them on relevant data sets. Fine-tuning involves modifying the model's weights based on new data related to the target task, while prompt engineering focuses on crafting effective prompts that guide the model's behavior. Challenge 1. CLMS can sometimes exhibit biases or generate inaccurate information. As these models are trained on massive data sets, they may inherit biases present in the data, resulting in biased outputs. Furthermore, CLMS can sometimes generate factually incorrect information due to their probabilistic nature and limitations in understanding complex real-world contexts. Challenge 2. Managing the computational resources needed for training and inference can be a challenge. Training CLMS often requires significant computational power and time, especially for large-scale models. Inference, the process of using a trained model to generate outputs, can also be computationally demanding, requiring specialized hardware and infrastructure. Handling long-term dependencies. Causal language models are trained on sequences of data, and they need to be able to handle long-term dependencies in the data. This means that they need to be able to remember information from earlier in the sequence, even if it is many steps away. This is a challenging task, and it can lead to problems with the model's performance if it is not done correctly. Maintaining consistency. Causal language models need to be able to maintain consistency in the text that they generate. This means that they need to avoid generating contradictory or illogical statements. It is difficult to ensure consistency, as causal models are trained on massive amounts of data, and they may encounter inconsistencies in the data. Generating diverse and interesting text. Causal language models need to be able to generate text that is both diverse and interesting. This means that they need to avoid generating repetitive or predictable text. The challenge is to generate novel and creative text while maintaining coherence and consistency. Preventing the model from generating biased or offensive text. Causal language models are trained on large amounts of text data, and they can learn to generate text that reflects the biases and prejudices that are present in that data. This can lead to the model generating text that is offensive or harmful. The challenge is to train models that are fair and unbiased. This can be done by carefully curating the training data and by using techniques to mitigate bias. langchainexperimental. Pull.base. Narrative chain. A detailed description of the narrative chain component, a chain that helps to write a story based on user prompts, breaking down its definition, components, architecture, role, advantages, and challenges. A chain that leverages the power of a large language model (LLM) to create a narrative based on a prompt provided by the user. It uses a chain of thought reasoning process to generate a story. Component 1. Narrative chain consists of several components. 1. Prompt template. This template dictates the structure of the prompt sent to the LLM. This ensures that the prompt is formatted in a way that is easily understood by the LLM, making the interaction more efficient and reliable. 2. LLM, the core engine that generates the story based on the provided prompt. It is a powerful tool that can analyze and understand natural language, generate creative content, and produce human-like text. 3. Post-processor. This component cleans up the output from the LLM, removing any inconsistencies or formatting issues. This ensures that the final story is presented in a clear and coherent manner, removing potential issues with formatting, grammar, and style. Narrative chain operates in a sequential manner. The user prompt is first passed through the prompt template to format it appropriately for the LLM. Then, the LLM receives the prompt and generates a narrative based on it. The output is then processed by the post-processor to ensure consistency and readability. Narrative chain plays a crucial role in simplifying the task of story writing. It allows users to generate narratives without needing to know the intricacies of prompt engineering or LLM mechanics. By providing a clear interface and a structured process, it makes it easier for users to create stories with varying lengths, genres, and styles. For instance, a user can provide a basic prompt like "write a story about a brave knight and a magical dragon," and Narrative Chain will leverage its components to generate a complete story based on that prompt. Ease of use simplifies the process of story generation, allowing users to focus on creativity without needing to understand the technical aspects of LLMs. Flexibility allows for generating narratives across various genres and styles, from fantasy to science fiction, historical fiction, and more. It can be used to generate stories that are short or long, simple or complex. Enhanced creativity can generate unique and unexpected story elements, providing users with fresh ideas and inspiring them to think differently about their narratives. Quality control: the output can sometimes be inconsistent or lack coherence due to the inherent complexities of language generation and the potential for LLMs to make mistakes. Limited context: the LLM's memory limitations might affect the story's continuity, especially for longer narratives, as it may not remember all the details of the story as it unfolds. Creativity bottlenecks: the LLM's ability to generate truly original ideas is limited by the data it has been trained on. While it can create new combinations and variations of existing ideas, generating truly novel concepts remains a challenge. langchainexperimental. Pull.models. Entity setting model summary. This is a description of the entity setting model class in the context of conversational persona language (CPAL) models. A class that represents the settings for a particular entity in a conversational persona language (CPAL) model. For example, it might define the settings for an entity like Apple or New York City. The settings could include various attributes and properties such as the entity type, its relationships with other entities, and relevant information about its characteristics and functionalities. Component 1. The name of the entity being defined. For example, this might be the name Apple for the entity representing the technology company, or New York City for the entity representing the city. Component 2. A dictionary of attributes for the entity. This dictionary contains key-value pairs that specify the various properties of the entity. These properties could include information like the entity type, e.g., company, city, its location, its founding date, its website, its main products, its primary industry, or any other relevant details about the entity. This class serves as a container for entity settings, providing a structured way to define and manage the attributes and properties of entities within a CPAL model. This structure ensures consistency and facilitates the organization of information about various entities used by the CPAL model. The entity setting model class plays a crucial role in defining and organizing the entities used in CPAL models, enabling the model to understand and interact with the world in a more sophisticated and nuanced manner. By providing detailed information about each entity, the model gains a deeper understanding of the world and can engage in more meaningful and informative conversations. Provides a structured way to define and manage entity settings. This structure ensures consistency and facilitates the organization of information about various entities used by the CPAL model. For example, by storing all information about the entity Apple in a consistent structure, it's easier to retrieve and use this information for various purposes within the model. Enhances the model's understanding of the world by providing specific knowledge about entities. This knowledge can be used to generate more relevant and accurate responses in conversations. For example, a CPAL model with detailed entity settings for Apple could provide more relevant information about the company in a conversation about technology. Ensuring the completeness and accuracy of entity settings. This is a crucial challenge as the accuracy and completeness of the entity settings directly impact the quality of the model's responses. For example, if the entity settings for New York City lack the information about its population or its primary industries, the model might not be able to answer questions about these aspects of the city accurately. Maintaining consistency between entity settings and the actual world. As the world changes, it's essential to update the entity settings accordingly to ensure their accuracy. For example, if a company like Apple releases a new product or acquires another company, the entity settings need to be updated to reflect these changes. This ensures that the CPAL model has access to the most up-to-date information about the entities it interacts with. Langchain-experimental pull models. Query model. Definition. A query model represents a query for a large language model (LLM). It encapsulates the query text, parameters, and other relevant information for the LLM to process. For instance, a query model for a question-answering task would include the actual question as the query text and parameters like the maximum length of the response. Components. Component 1. The actual text of the query. This is the core input for the LLM, providing the specific question or instruction to be processed. For example, what is the capital of France? Component 2. A dictionary of parameters that can be used to customize the LLM's behavior. These parameters can control aspects like the response length, the creativity level of the LLM's output, or even the specific language model to be used. Architecture. The query model architecture facilitates the structured representation of queries, enabling efficient communication with LLMs and enhancing the management of query-related information. This structured approach makes it easier to understand and process complex queries, especially in scenarios involving multiple LLM interactions. Role. The query model acts as a standardized interface for interacting with LLMs, simplifying the query process and ensuring consistent data exchange between query components and the LLM. This standardization helps streamline the development and deployment of LLM-based applications by providing a consistent and predictable way to interact with these powerful models. Advantages. Provides a structured approach to managing and processing queries, improving clarity and efficiency in LLM interactions. For example, it allows for easier tracking of query history, modification of parameters, and analysis of query performance. Allows for defining specific query parameters to tailor LLM behavior. This flexibility enables developers to fine-tune the LLM's response based on the specific requirements of the application. For example, one might set a parameter to control the length of the generated response, or to specify a preferred language for the output. Challenges. Can be complex to implement and maintain, especially for intricate query structures. This complexity arises from the need to manage the structure of the query, its parameters, and the interaction with the LLM. Ensuring consistency and clarity in parameter handling can be challenging. It is crucial to document and manage parameters effectively to avoid errors and to ensure that the LLM behaves as expected. Langchain experimental pull models intervention model. Definition. The intervention model class within langchain experimental pull models is designed to encapsulate a model that can intervene in a conversation, providing suggestions, or taking action based on the context. Components. Component 1. Intervention model. This is a function that takes the context as input and returns a suggested intervention. For example, in a customer service chatbot, the intervention model could analyze the conversation and suggest providing a discount if the customer expresses frustration. Component 2. Apply intervention. This is a function that takes the intervention and the current state as input and applies the intervention. For instance, in the same customer service chatbot scenario, the apply intervention function could implement the discount by adjusting the chatbot's response to include the discount offer. Architecture. The intervention model leverages the intervention model to suggest interventions and then employs the apply intervention function to execute those interventions, modifying the conversational flow. Role. The intervention model acts as a mediator within the conversation, dynamically adjusting the dialogue based on the context and the intervention model's suggestions. In essence, it plays the role of an intelligent moderator, ensuring the conversation stays on track and achieves desired outcomes. Advantages. Enables proactive intervention, guiding the conversation towards desired outcomes by anticipating potential issues and providing suggestions. The intervention model can steer the conversation toward predefined goals, such as resolving customer complaints or promoting specific products. Allows for personalized and context-aware adjustments in the conversational flow. The intervention model can analyze the conversation's context and tailor its interventions to individual users, enhancing the conversational experience and increasing user satisfaction. Challenges. Designing an effective intervention model requires careful consideration of the conversational context and the desired intervention goals. This involves defining the appropriate intervention triggers, crafting effective intervention strategies, and ensuring the intervention model aligns with the overall conversational objectives. Ensuring that the apply intervention function seamlessly integrates the intervention into the conversation can be complex. The intervention needs to be delivered naturally and in a way that does not disrupt the flow of the conversation. This requires careful integration of the intervention into the chatbot's dialogue structure and response generation process. Langchain experimental pull. Definition. Langchain experimental CPAL chain parallel is a method to run chains in parallel and then combine the results. This enables faster execution time and improved efficiency. Think of it as dividing a large task into smaller chunks and processing each chunk on a separate processor simultaneously. Imagine you are analyzing a huge text document. Instead of processing the whole document on a single processor, you can divide it into smaller sections and process each section on different processors, leading to faster analysis. Components. Component 1. Langchain chains. Chains are a fundamental concept in langchain. A langchain chain is a sequence of components, like models, prompts, and tools, that work together to achieve a specific goal. Chains are flexible and allow you to create complex workflows, like summarization or question answering. Component 2. CPAL, a method to run chains in parallel. CPAL stands for chain parallel. It's a technique that allows you to execute multiple LangChain chains concurrently. Imagine you have several separate tasks, each requiring a different LangChain chain to complete. CPAL allows you to run these chains simultaneously, making the overall execution time faster. Architecture. CPAL works by splitting the input into multiple parts, running each part on a separate chain, and then combining the results. The individual chains are run in parallel, which can significantly speed up the overall execution time. For example, imagine you are building a chatbot that needs to analyze a large dataset and generate a response. You can use CPAL to divide the dataset into smaller chunks, process each chunk on a separate chain, and then combine the results to generate a comprehensive response. Role. CPAL allows us to leverage the power of parallel processing to speed up the execution of LangChain chains, especially when dealing with large inputs or complex chains. Consider a scenario where you are trying to translate a large document. By using CPAL, you can break the document down into smaller sections, translate each section on a separate chain in parallel, and then stitch them back together. This will significantly reduce the overall translation time compared to translating the entire document on a single chain. Advantages. Faster execution time. CPAL allows you to leverage the power of multi-core processors and achieve significant performance gains. When dealing with complex tasks like generating summaries or answering questions from large datasets, CPAL can dramatically reduce the time required to complete these tasks. Improved efficiency. CPAL helps you make better use of your available processing resources. It allows you to process multiple tasks concurrently, improving the overall efficiency of your application. Imagine you are building a search engine that needs to index a large corpus of documents. You can use CPAL to process each document on a separate chain, allowing you to index the corpus much faster. Challenges. Requires careful consideration of how to split the input and combine the results. While CPAL offers significant advantages, it does require careful consideration of how to split the input and combine the results. The way you split the input and combine the results can impact the accuracy and performance of your application. For instance, when processing a large dataset, you need to make sure the data is split in a way that ensures each chain receives relevant information for processing. You also need to develop a robust strategy for combining the results from different chains. May not be suitable for all types of chains. Not all LangChain chains are suitable for parallel execution. Some chains might require specific dependencies or sequential execution, making them incompatible with CPAL. For example, if a chain requires the output of a previous step, running it in parallel might lead to incorrect results. langchainexperimental. Pull.models. Narrative model. A description of the narrative model and its components, along with its advantages and challenges. A model that can generate narratives, a multi-step process involving prompt engineering and retrieval of relevant information. A narrative model can be used to generate creative stories, summaries of factual topics, or even scripts for plays or movies. This is accomplished by leveraging the power of large language models (LLMs) and combining them with information retrieval techniques. Component 1. Narrative Generator. A model that generates narratives, often utilizing large language models (LLMs). This component is responsible for taking the retrieved information and shaping it into a coherent narrative. It utilizes the LLM's ability to generate text, understand context, and follow instructions to produce engaging and creative stories. For example, a narrative generator could be used to create a fictional story based on historical events or to generate a summary of a complex scientific paper in a more accessible format. Component 2. Information Retriever, a component that retrieves relevant information from external sources or a knowledge base. This component plays a crucial role in providing the narrative generator with the necessary information to create a compelling narrative. This can involve retrieving information from online databases, searching through academic articles, or querying a knowledge graph. For instance, an information retriever could be used to find relevant historical facts for a historical fiction story or to gather information on a specific scientific topic for a summary. The model typically uses a chain of components, often including a prompt engineering component, an information retriever, and a narrative generator. This chain allows for a modular and flexible approach to narrative generation. The prompt engineering component sets the stage for the narrative by providing initial instructions and guiding the overall direction. The information retriever then gathers the necessary facts and details from external sources. Finally, the narrative generator weaves these elements together into a cohesive and engaging story. It plays a crucial role in generating engaging and coherent narratives by combining information from diverse sources. Narrative models have the potential to revolutionize the way we create stories and consume information. They can help us understand complex topics in a more accessible way, inspire new ideas, and even create entirely new forms of entertainment. Enhanced creativity can generate novel and imaginative narratives by leveraging LLM's creativity. Narrative models can be used to create original stories, scripts, poems, and other creative content. They can generate unique characters, settings, and plot lines, offering a new perspective on familiar themes or exploring entirely new concepts. For instance, a narrative model could be used to create a science fiction story set in a world where humans have evolved to have wings or to write a poem about the emotions of an AI. Contextual understanding, capable of understanding context and incorporating relevant information from diverse sources. This allows the narrative model to create narratives that are grounded in reality and consistent with the information it has been provided. For example, a narrative model could be used to write a historical fiction novel that accurately reflects the social, political, and economic conditions of the time period being depicted. Factual accuracy can struggle with maintaining factual accuracy, particularly when relying on incomplete or biased information. Narrative models are trained on vast amounts of data, which can include inaccuracies or biases. This means that there is a risk of generating narratives that contain factual errors or promote harmful stereotypes. For instance, a narrative model might generate a story about a historical event that contains inaccuracies or misrepresents the motivations of the individuals involved. Bias and fairness can reflect biases present in training data, potentially leading to unfair or misleading narratives. The data that narrative models are trained on can reflect the biases of the individuals who created it. This can lead to the generation of narratives that perpetuate harmful stereotypes or promote discriminatory views. For example, a narrative model might generate a story that reinforces sexist or racist tropes. langchainexperimental. Pull.models. Narrative model. A detailed description of langchain experimental pull models. Narrative model. A narrative model is a foundational component in LangChain's conversational pattern-aware language (CPAL) framework. It's responsible for generating a narrative, weaving together a sequence of events, and managing conversational context. This model provides a structured way to create engaging and dynamic interactions by orchestrating the flow of conversation. Component 1. A narrative model utilizes a collection of narrative events to construct the narrative. Each narrative event represents a distinct step in the conversational flow, capturing crucial information like user inputs, system responses, and internal state changes. Imagine building a chatbot for booking a flight. A narrative event could represent the user entering their desired destination, the system providing a list of available flights, or the user selecting a specific flight. Component 2. These narrative events are structured objects encapsulating key aspects of a conversational interaction like user inputs, responses, and internal state transitions. This structured format allows the narrative model to effectively manage the conversational state, track the progression of events, and generate coherent narratives. For instance, a narrative event could store the user's input, the system's response, and the updated booking state after the user selects a flight. The narrative model's architecture follows a state-based design. It maintains a state representing the current narrative context, including the events that have occurred and the current state of the conversation. This state is updated dynamically as new events are added. This state-based approach ensures that the narrative is consistent and that the model retains crucial contextual information throughout the conversation. For example, after the user selects a flight, the state of the narrative would update to include the selected flight details, ensuring subsequent responses are relevant and consistent with the user's choices. The narrative model plays a central role in maintaining conversational coherence and flow. It orchestrates the progression of events, manages context, and ultimately facilitates the generation of narratives that feel natural and engaging. By managing the flow of events and maintaining context, the narrative model ensures that the conversation stays on track and that responses are relevant and appropriate. For example, the narrative model could ensure that a chatbot does not ask for the user's destination again if it has already been provided. Advantage 1. Narrative models simplify the construction of interactive narratives by abstracting away the complexities of managing conversational state and event sequences. Developers can focus on creating engaging content and interactions without needing to delve into the intricate details of managing conversational state and event flow. Imagine building a chatbot for a museum tour. The developer can focus on creating interesting and informative responses for different exhibits, while the narrative model handles the underlying logistics of managing the conversation flow and tracking the user's progress through the museum. Advantage 2. They empower developers to focus on creating engaging content and interactions, leaving the underlying narrative mechanics to the framework. By handling the intricacies of state management and event flow, narrative models allow developers to concentrate on the core aspects of their conversational application, such as crafting engaging dialogue, incorporating relevant information, and providing a satisfying user experience. For instance, in a chatbot for an e-commerce website, developers can focus on crafting product descriptions and promotions, while the narrative model handles the conversation flow, ensuring the user's experience is seamless and intuitive. Challenge 1. Ensuring accurate and consistent state management is crucial for maintaining coherence in the narrative. The model must accurately track the conversation's progress and maintain a consistent representation of the narrative context. Mistakes in state management can lead to inconsistencies and disjointed responses, negatively impacting the user's experience. For example, a chatbot might ask the user for their city again if it has not correctly stored the city information from a previous interaction. Challenge 2. Handling complex event dependencies and branching logic within the narrative can present challenges in design and implementation. When dealing with multiple event dependencies and complex branching paths in a conversation, it's crucial to ensure the narrative model correctly navigates these scenarios and provides the appropriate responses. Imagine a chatbot for a customer service application. The chatbot needs to handle various scenarios like resolving billing issues, providing product information, or escalating issues to a human agent. Efficiently managing these complex event dependencies is critical for creating a robust and user-friendly conversational experience. Langchain Experimental Pull Models System Setting Model. Definition: System setting model is a langchain model that is designed to manage system-wide settings. It is intended to be used within the context of a larger application, providing a central location for managing user preferences, security configurations, and other settings that may be relevant across various components. For example, in a web application, the system setting model could store the application's database connection details, the default language, and other settings that affect the application's behavior. Components. Component 1. Configuration storage: a mechanism, such as a database, file system, or other storage method, to persist the settings. This could be a simple key-value store, like Redis, or a more complex database with schema support, such as PostgreSQL, to ensure the persistence of settings. Component 2. Settings schema: a definition of the available settings, including their data types, default values, and any constraints. For instance, a setting might be a string, integer, or boolean, with a specific range or format. Component 3. Setting retrieval: an application programming interface API, or similar interface, to retrieve settings based on their identifiers' names, keys. This allows different parts of the application to access the settings without needing to know the underlying storage mechanism. Component 4. Setting update functionality: to update existing settings or create new ones, potentially with validation and authorization mechanisms. This ensures that changes to the settings are controlled and that invalid or unauthorized updates are prevented. Architecture. The system setting model architecture is highly flexible and can be implemented in various ways depending on the application's specific needs. Common architectural patterns include centralized settings service: a dedicated service responsible for managing all settings, providing a consistent interface for access and updates. For example, a separate service could handle all requests to read or write settings, ensuring consistency and centralized control. Distributed settings may be spread across different components, with potential for replication and consistency mechanisms. In this scenario, settings might be stored in multiple locations, with mechanisms to ensure that all copies are kept in sync. Role. The system setting model plays a crucial role in enabling applications to be configurable and adaptable to different environments and user needs. It promotes code reusability and maintainability by centralizing settings management. By providing a central point for managing settings, the system setting model helps to ensure consistency and reduces the risk of errors caused by conflicting or outdated settings. Advantages. Centralized configuration eliminates the need to manage settings across multiple parts of the application, simplifying code and reducing the risk of inconsistencies. This simplifies development and maintenance by centralizing settings management. Configurability allows applications to be easily adapted to different environments and user preferences. This means that the application can be configured to meet the specific needs of different users or environments. Maintainability streamlines the process of modifying and updating settings, ensuring consistency across the application. By centralizing settings management, changes can be made in a single location, ensuring that all parts of the application are using the latest settings. Challenges. Security. Ensuring the integrity and confidentiality of settings is crucial, especially in sensitive applications. Measures like encryption, access control, and auditing are essential to protect sensitive data. Scalability. Handling a large number of settings and users efficiently requires a robust and scalable architecture. Considerations include data storage, concurrency, and distribution. This means that the architecture needs to be designed to handle high volumes of requests and to scale up as the application grows. Consistency. Maintaining consistency across distributed settings is important, especially in real-time applications. Mechanisms like replication and consensus algorithms may be required to ensure that all copies of the settings are consistent, even if they are distributed across multiple servers. langchainexperimental. Pull.base. Causal chain. A YAML document detailing the causal chain, a LangChain chain designed for causal reasoning, with its components, architecture, role, advantages, and challenges. A chain that uses a causal language model to reason about cause and effect. It takes a prompt that describes a scenario and a question about the scenario, and it uses the language model to generate a response that explains the cause and effect relationship between the scenario and the question. For instance, given a scenario like a student did not study for a test, and a question why did the student fail the test, the causal chain would utilize a causal language model to infer and explain the relationship between the scenario and the question, potentially generating a response like the student did not study for the test, which is a likely cause for their failure. Component 1. The causal language model LLM used by the causal chain. This LLM is responsible for processing the provided scenario and question and generating the causal explanation. It should be a model capable of understanding and reasoning about cause and effect relationships. Examples of suitable LLMs could include models like GPT-3 or PaLM, which are known for their advanced language understanding and generation capabilities. Component 2. The prompt that is used to guide the causal language model in generating the response. The prompt should provide the scenario and the question that the chain needs to answer. It should be crafted in a way that clearly articulates the causal relationship that the LLM needs to understand. For instance, the prompt could be structured like scenario: a student did not study for a test. Question: why did the student fail the test? Component 3. The chain type of the causal chain, which is a predefined structure in LangChain that defines the flow of data and the sequence of operations performed by the chain. It outlines the specific steps involved in using the causal language model to process the prompt and generate the response. The chain type helps ensure that the chain works consistently and effectively in handling various inputs and generating coherent outputs. Uses a causal language model to reason about cause and effect. Takes a prompt that describes a scenario and a question, and uses the language model to generate a response that explains the cause and effect relationship between the scenario and the question. This involves the causal chain receiving a prompt containing a scenario and a question, which is then processed by the underlying causal language model. The LLM analyzes the scenario and question to understand the causal relationship involved and generates a response that explains the cause and effect link. For example, if the prompt describes a scenario where a car runs out of gas and the question is why did the car stop working, the causal chain, using the causal LLM, would infer the cause running out of gas and provide an explanation for the effect the car stopped working. This chain provides a framework for causal reasoning, allowing users to ask questions about scenarios and get explanations for the causes and effects involved. The causal chain acts as a facilitator for causal reasoning, enabling users to explore and understand causal relationships within various contexts. It provides a structured approach for inputting scenarios and questions and retrieving explanations generated by the underlying causal language model. This allows for a more efficient and focused analysis of cause and effect, making it valuable for tasks that require understanding the underlying reasons behind events or actions. Advantage 1. Enables the chain to reason about the cause and effect of events and actions, providing insights into the relationships between them. This allows for a deeper understanding of scenarios and potential outcomes. For example, analyzing historical events and understanding their impact on current situations. Advantage 2. Provides detailed explanations for the causal relationships identified, offering insights into why specific events or outcomes occurred. This facilitates a more comprehensive understanding of the scenario and the factors that led to its outcome. For example, understanding the reasons behind a company's success or failure. Advantage 3. Allows for flexibility in defining the prompt format, providing options for different scenario and question structures. This allows users to tailor the prompts to their specific needs and context, enhancing the versatility of the chain. For example, using the chain to analyze different types of scenarios, such as economic trends or political events. Challenge 1. The accuracy and reliability of the causal reasoning depend heavily on the capabilities of the underlying language model. This means that the accuracy and reliability of the causal reasoning output are directly influenced by the language model's understanding of causal relationships and its ability to make accurate inferences. If the language model is not adequately trained or lacks the necessary knowledge, the causal reasoning might be inaccurate or unreliable. Challenge 2. Crafting effective prompts is crucial for achieving accurate and relevant causal reasoning results. The quality of the prompt greatly impacts the understanding and reasoning of the causal language model. If the prompt is poorly constructed or lacks clarity, it can lead to inaccurate or irrelevant results from the causal chain. Therefore, careful prompt engineering is required to ensure that the chain effectively captures the desired causal relationships. Challenge 3. Current causal language models have limitations in understanding and explaining complex causal relationships. This means that the chain may struggle to effectively analyze and explain scenarios involving multiple interconnected causes and effects. The complexity of real-world situations often involves intricate causal networks that are challenging for current language models to fully comprehend and explain. This limitation restricts the chain's capabilities in handling intricate causal relationships and might require further advancements in language model technology to address this challenge. Flexibility in query execution and response generation. The query chain offers flexibility in how queries are processed and how responses are generated. It allows for customization of the query runner, retriever, and LLM components to accommodate different query types and response styles. Unified interface. It provides a standardized interface for interacting with diverse retrieval and LLM components. This uniformity simplifies integration and makes it easier to switch between different retrieval methods or language models without significant code changes. Challenges: configuration complexity. Achieving optimal performance requires careful configuration of the components. Balancing the trade-offs between accuracy, speed, and computational resources is crucial for effective knowledge retrieval and response generation. Resource intensity. Complex queries or large knowledge bases may require significant computational resources, potentially leading to performance bottlenecks or longer response times. Debugging and troubleshooting. Due to the intricate interplay of components, debugging and troubleshooting issues within the query chain can be challenging. Identifying the source of a problem may require analyzing the performance of individual components, the quality of retrieved documents, or the logic of the response generation process. Langchain Experimental Data Anonymizer Summary. NaN. A langchain component designed to anonymize data using various techniques. This component leverages advanced algorithms and methods to transform sensitive data into non-identifiable forms while preserving its utility for analysis and machine learning tasks. Component 1. Data anonymization techniques encompass a range of methods used to protect sensitive information. These techniques include differential privacy, anonymity, and generalization. Differential privacy adds noise to data, making it difficult to identify individuals while preserving overall data trends. Anonymity groups individuals with similar attributes, making it challenging to link specific records to individuals. Generalization replaces specific values with broader categories, obscuring fine-grained details. Component 2. Pre-processing and post-processing capabilities refer to the steps taken before and after anonymization. Pre-processing involves preparing data for anonymization, such as handling missing values and identifying sensitive attributes. Post-processing ensures the anonymized data is suitable for downstream tasks, such as checking for data quality and consistency. Modular design enabling flexible data anonymization workflows. The LangChain Data Anonymizer is designed with a modular architecture, allowing users to select and combine different anonymization techniques to meet specific privacy and utility requirements. This flexibility enables users to tailor the anonymization process to the characteristics of their data and the desired level of privacy protection. Protecting sensitive information while preserving data utility for analysis and model training. Data anonymization plays a crucial role in safeguarding sensitive information while maintaining the value of data for various purposes. By removing personally identifiable information, anonymization enables data sharing, collaboration, and analysis without compromising individual privacy. Enhanced privacy by removing personally identifiable information. Anonymization significantly enhances privacy by eliminating personally identifiable information, such as names, addresses, and social security numbers. This process reduces the risk of unauthorized access, disclosure, or misuse of sensitive data, ensuring individuals' privacy is protected. Facilitates data sharing and collaboration. Data anonymization facilitates data sharing and collaboration by enabling the sharing of valuable data sets without compromising individual privacy. This promotes research, innovation, and knowledge sharing by allowing researchers and organizations to access and analyze data without violating privacy constraints. Maintaining data quality and ensuring anonymization effectiveness. Data anonymization can sometimes affect data quality, making it crucial to balance privacy protection with data utility. Maintaining data quality involves ensuring that anonymization techniques do not introduce biases, distortions, or inaccuracies into the data, preserving its reliability and relevance. Balancing privacy protection with data utility. Finding the right balance between privacy protection and data utility is a key challenge in data anonymization. While anonymization techniques aim to protect privacy, they also need to ensure that the anonymized data remains useful for analysis, machine learning, and other purposes. This delicate balance requires careful selection of anonymization methods and parameter tuning to achieve optimal privacy and utility. langchainexperimental data anonymizer base reversible anonymizer base. A detailed description of the class and its components. This class serves as the foundation for creating anonymizers that can both hide sensitive information and later restore it to its original form. It establishes a standard framework for reversible anonymization, enabling data privacy while ensuring the possibility of recovering the original values. Component 1. Anonymize. This method takes data as input and applies anonymization techniques to transform it into a less identifiable form. It aims to protect sensitive information by replacing or masking original values with substitutes while retaining the ability to reverse the process. Component 2. Denonymize. This method serves as the counterpart to the anonymize method. It takes the anonymized data and applies the necessary transformations to recover the original values. This allows for the retrieval of the original data while maintaining the ability to restore the anonymized state if needed. The core of the reversible anonymizer base class is built around the two core methods, anonymize and denonymize. This design provides a flexible framework for implementing different anonymization techniques and ensures the reversibility of the process. It emphasizes the need for both data protection and the ability to recover the original data when necessary. This class plays a crucial role in data privacy by providing a standard interface for reversible anonymization. It facilitates the anonymization of sensitive information in datasets, enabling data sharing and analysis while minimizing privacy risks. The reversible nature of the anonymization process ensures that original values can be recovered when needed, balancing the need for data privacy with the requirement for data integrity. Supports reversible anonymization. One of the key strengths of this class is its support for reversible anonymization. This means that it allows for the transformation of data into a less identifiable form while retaining the ability to restore the original data. This capability is crucial for scenarios where data privacy is a priority but the original data may need to be recovered later for various purposes. Standardized interface for anonymizers. This class provides a standardized interface for anonymizers, facilitating the development of different anonymization techniques and their integration into a broader data privacy system. This standardized interface ensures consistency and facilitates the application of different anonymization methods based on specific data requirements and privacy constraints. Implement specific anonymization and denonymization logic for different data types. Implementing reversible anonymization for different data types presents a significant challenge. Each data type requires specific anonymization and de-anonymization logic to effectively protect sensitive information while maintaining the ability to recover the original values. This involves careful consideration of the data structure, data distribution, and potential privacy risks associated with each data type. Ensure data integrity and security during anonymization and de-anonymization processes. A fundamental challenge in reversible anonymization is ensuring data integrity and security throughout the anonymization and de-anonymization processes. The anonymization methods employed should not compromise the original data's integrity or introduce vulnerabilities that could lead to data breaches or unauthorized access. Maintaining security is paramount to prevent unauthorized modifications or access to sensitive data, even during the anonymization process. Presidio Reversible Anonymizer. A detailed description of the Presidio Reversible Anonymizer, its components, architecture, role, advantages, and challenges. This is a reversible anonymizer that leverages the capabilities of Presidio, a data anonymization library. Presidio employs various techniques for redacting sensitive information from data. Component 1. Presidio is a powerful data anonymization library that employs a wide range of techniques for redacting sensitive information. For instance, it can use techniques like tokenization, where sensitive information is replaced with unique identifiers, or pseudonymization, where sensitive information is replaced with artificial but similar data. Component 2. LangChain acts as a framework for building applications based on large language models (LLMs). It provides a set of tools and functionalities to interact with and integrate LLMs into applications, facilitating tasks like natural language processing, text generation, and more. The Presidio Reversible Anonymizer relies on Presidio for data anonymization. It integrates Presidio with LangChain to seamlessly incorporate anonymized data into applications powered by large language models (LLMs). The primary objective of this anonymizer is to transform data in a reversible manner, ensuring that the original data can be recovered from its anonymized form. This allows for data privacy and security while maintaining the ability to reconstruct the original data when necessary. Advantage 1. Reversible anonymization enables the recovery of the original data from the anonymized version. This ensures that the original data can be reconstructed if needed, maintaining its usability while providing privacy and security. A real-world example is anonymizing customer data for analysis, but allowing the recovery of original data for customer support or personalized services. Advantage 2. Presidio's robust anonymization capabilities are leveraged by this anonymizer. This means that the anonymizer benefits from Presidio's diverse set of techniques for redacting sensitive information. This ensures the anonymized data is protected and maintains privacy. For instance, Presidio can identify and redact personal information like names, addresses, and financial details from datasets, making it suitable for various privacy-sensitive applications. Challenge 1. The configuration and usage of Presidio can be complex due to its wide range of functionalities and options. Implementing and configuring the anonymizer effectively requires a thorough understanding of Presidio's features and options. Challenge 2. Reversible anonymization poses potential security risks if not implemented correctly. If the anonymization process is not secure or if the key for reversing the anonymization is compromised, it could lead to unauthorized access to sensitive data. It's crucial to prioritize robust security measures and data protection practices when implementing reversible anonymization. langchainexperimental. Data anonymizer. Presidio reversible anonymizer. Description of the Presidio reversible anonymizer in the context of LangChain. Detailed definition of the variable goes here. Components. Component 1 Presidio library. This refers to the open-source Presidio library, a powerful tool designed for data anonymization. It provides a comprehensive set of capabilities for identifying and transforming sensitive data, making it suitable for various data privacy and security applications. Component 2 Reversible anonymization technique. This refers to a specific type of anonymization approach that allows for the recovery of the original data after the anonymization process. This technique involves applying reversible transformations to sensitive data, effectively obscuring it while retaining the ability to restore the original content. Description of the architecture supporting the variable. The architecture of Presidio reversible anonymizer relies on the Presidio library, a robust open-source toolkit for data anonymization. This anonymizer employs reversible anonymization techniques, allowing for the restoration of the original data after the anonymization process. The core principle of this approach involves applying reversible transformations to sensitive data, ensuring that the data can be recovered while maintaining privacy. Explanation of the variable's role in the system. The Presidio reversible anonymizer plays a crucial role in safeguarding sensitive information within LangChain by providing a mechanism for anonymizing data. This anonymizer utilizes the Presidio library to identify and transform sensitive entities present in the data, effectively masking them while preserving the ability to restore the original content. It serves as a critical component for protecting user privacy and compliance with data protection regulations. Preserves data recoverability. This advantage highlights the ability to restore the original data after anonymization. This is a crucial feature for scenarios where the original data may be needed for analysis, auditing, or other purposes while still maintaining a level of privacy. For example, in a healthcare setting, patient data might be anonymized for research purposes, but the ability to recover the original data could be essential for verifying results or linking data across different studies. Enhances privacy. This advantage emphasizes the anonymizer's contribution to enhancing privacy. By masking sensitive data, the anonymizer helps protect personal information from unauthorized access or disclosure. This is particularly important in contexts where sensitive data, such as financial records or personal health information, is being processed or stored. Supports compliance. This advantage underscores the anonymizer's role in supporting compliance with data protection regulations. Many regulations, such as the General Data Protection Regulation (GDPR) and the California Consumer Privacy Act (CCPA), require organizations to implement measures to protect sensitive data. The Presidio reversible anonymizer can help organizations meet these requirements by providing a mechanism for effectively anonymizing sensitive data, thereby reducing the risk of non-compliance. Challenge 1. Computational overhead. This challenge refers to the potential for the anonymization process to consume significant computational resources. The process of identifying, transforming, and then potentially reversing the anonymization of sensitive data can be computationally intensive, especially when dealing with large datasets or complex data structures. This could lead to longer processing times and potentially affect the overall performance of the system. Challenge 2. Potential for leakage. This challenge highlights the risk of sensitive data being unintentionally leaked during the anonymization process. While reversible anonymization techniques aim to maintain the ability to recover the original data, there is a possibility of information leakage if the anonymization process is not properly implemented or if there are vulnerabilities in the underlying algorithms. This could potentially compromise the privacy of the data and expose individuals to risks. Challenge 3. Difficulty in handling complex data formats. This challenge addresses the potential difficulties in handling complex data formats during anonymization. Complex data formats, such as structured databases, multimedia files, or machine learning models, may pose challenges for the anonymizer. The anonymization process may need to be adapted or modified to effectively handle these formats without compromising the integrity or utility of the data. Challenge 4. Limited support for specific data types. This challenge acknowledges the possibility of limited support for specific data types within the anonymization process. Not all data types may be equally amenable to anonymization, and some may require specialized techniques or algorithms. This limitation could restrict the scope of data that can be effectively anonymized using the Presidio reversible anonymizer, potentially requiring additional tools or approaches for certain data types. langchainexperimental.pull.models.query model. A description of the query model in CPAL framework. A model for representing queries in the CPAL framework. This model provides a standardized way to represent different types of queries, including natural language, structured queries, and code snippets. This model is designed to unify various query formats and make it easier for different parts of the system to process queries. It also enables better tracking of queries, analysis, and development of new query handling capabilities. Component 1. The user's input query. This represents what the user wants to know or wants to achieve through the system. For example, a user may want to know the weather or search for a specific article. These requests would be represented as the query. Component 2. Optional context that can be provided to the query. This can include information about the user's previous interactions, the current state of the system, or relevant background information. For example, in a chatbot, the context can include past conversations with the user, allowing the bot to provide more relevant responses. Component 3. Optional metadata that can be associated with the query. This metadata can include information about the user, the timestamp of the query, or other relevant information. This helps in tracking the query and understanding its context. Component 4. The type of query. This can be used to differentiate between different types of queries, such as natural language queries, structured queries, and code snippets. For example, a natural language query could be "What is the weather in London?" A structured query could be "Select from weather where city London," and a code snippet could be "Print hello world." Component 5. The intended action or task that the user wants to perform. This can be used to guide the query processing and response generation. For example, the intent could be to get information, perform an action, or trigger a specific functionality in the system. Component 6. Optional parameters that can be used to further refine the query. These parameters can provide additional information to help the system process the query more accurately. For example, a parameter could be location with a value London, further refining a weather query to be specific to London. Component 7. The result of the query processing. This can be a list of documents, a summary of the information, or a code snippet. This is the output generated after processing the query. For example, a weather query could result in a text with the current temperature and weather conditions in London. The query model is a simple data structure that provides a standardized way to represent queries in the CPAL framework. The model is designed to be flexible and extensible, allowing for different types of queries and metadata to be included. This modular design allows for easier integration and expansion of the system's query handling capabilities. The query model plays a central role in the CPAL framework. It is used to represent the user's input query and provides a standardized way for different components of the framework to interact with the query. This ensures consistency and efficient flow of information between different parts of the system. Standardized representation of queries across different components of the CPAL framework allows for easier interoperability and consistency in query handling. Flexibility and extensibility of the query model allows it to adapt to new types of queries and metadata. Improved interoperability between components of the CPAL framework ensures efficient and consistent query processing. Defining a comprehensive set of query types to cover all possible user intents and requests can be challenging. Handling complex or ambiguous queries, such as queries that involve multiple intents or have unclear meanings, can be difficult for the system to understand and process. langchainexperimental.pull.models.narrative model. A detailed description of the narrative model, including its definition, components, architecture, role, advantages, and challenges. A specialized chain designed for crafting comprehensive narratives based on input data. It leverages a series of prompts to guide the model through the process of story construction, incorporating elements like character development, plot progression, and emotional depth. This model essentially helps in constructing a narrative, taking into account factors like character development, plot progression, and emotional depth. Component 1. Narrative model. Narrative prompt. A prompt template that serves as a guide for the model to generate a compelling narrative. For instance, the prompt could be write a short story about a young woman who discovers a magical artifact. Component 2. Narrative model. Persona prompt. A prompt template designed to create distinct and engaging characters within the narrative. The prompt can be framed as describe the personality traits, motivations, and backstory of the main character. Component 3. Narrative model. Plot prompt. A prompt template focused on developing the overarching storyline, including key events and turning points. An example would be outline the key events of the story, including the protagonist's journey and the challenges they face. Component 4. Narrative model. Emotional prompt. A prompt template used to infuse the narrative with emotional resonance, adding depth and relatability. This prompt could be formulated as describe the emotional arc of the story, highlighting the characters' feelings and how they evolve. The narrative model architecture is based on a sequential execution of prompts, each designed to contribute a specific element to the overall narrative. The prompts are iteratively applied to refine the story, incorporating user-defined parameters like character traits, plot elements, and desired emotional impact. This sequential execution ensures that the narrative develops logically, starting with an initial prompt and iteratively building upon it, incorporating user-defined parameters such as character traits, plot elements, and desired emotional impact. The narrative model plays a crucial role in automating the process of narrative creation. It enables users to generate compelling and well-structured stories by providing a framework for crafting engaging characters, developing intricate plots, and infusing emotional depth into the narrative. This model empowers users to create well-structured narratives by providing a framework that combines engaging characters, intricate plots, and emotional depth. Automated narrative generation. The model automates the narrative creation process, streamlining the writing process and enabling efficient storytelling. Enhanced storytelling capabilities. The model enhances storytelling capabilities by providing tools and techniques to create compelling and engaging narratives. Customization. Through prompt engineering, the model allows for customization by adjusting prompts to shape the narrative in a desired direction. Maintaining narrative coherence across multiple prompts. Ensuring that the narrative flows seamlessly across different prompts can be challenging. Ensuring consistency in character development. Maintaining consistent character traits and motivations across prompts is crucial for believable characters. Balancing plot complexity with readability. Finding the right balance between a compelling plot and a narrative that is easy to follow can be a challenge. langchainexperimental. Data anonymizer. Denonymizer. Matching strategies. Exact matching strategy. A detailed description of the exact matching strategy in the context of LangChain data anonymization. Detailed definition of the variable goes here. Components. Component 1. The exact matching strategy is a denonymizer matching strategy that finds the exact match for the anonymized value in the original data. For example, if a name John Smith was anonymized to A123, this strategy would attempt to find the exact match for A123 in the original data, hoping to recover the original value John Smith. Component 2. It is a simple and effective strategy when you have a high degree of certainty about the mapping between anonymized values and the original values. If the anonymization process is deterministic and there's a clear one-to-one mapping between anonymized and original values, this strategy is likely to be successful. Description of the architecture supporting the variable. The architecture involves matching the anonymized value with the original value in the original data. This can be implemented using data structures like dictionaries or hash maps, where the key is the anonymized value, and the value is the original value. For example, a dictionary could store A123 as a key and John Smith as the corresponding value. When a denonymization request arrives, the strategy looks up the anonymized value in the dictionary to retrieve the original value. Explanation of the variable's role in the system. This strategy aims to find the exact match for the anonymized value in the original data. It's a core component of the denonymization process, allowing the recovery of original values from their anonymized representations. Simple to implement. The exact matching strategy can be implemented with minimal code, making it easy to integrate into various systems. Effective when you have a high degree of certainty about the mapping between anonymized and original values. If the anonymization process was well-defined and reliable, this strategy can achieve high accuracy in recovering the original values. Susceptible to errors if the anonymization process introduces noise or ambiguity. If the anonymization process isn't deterministic or introduces randomness, this strategy may fail to find the correct match. For example, if John Smith was anonymized to A123 and Jane Doe was also anonymized to A123, the strategy would not be able to differentiate between them. May not work well if the original data contains duplicate values. If the original data contains duplicate values, the strategy may return incorrect results. For example, if John Smith appears twice in the original data and is anonymized to A123 both times, the strategy might return an incorrect result. langchainexperimental.data-anonymizer.denonymizer.matching-strategies.exact matching strategy. Definition. This strategy directly compares the anonymized and original text for an exact match. It's the simplest approach but only effective when the anonymization process preserves the exact text content. For example, if the anonymization process merely replaces a person's name with John Doe without any other modification, this strategy would work well. Components. Component 1. The text you want to de-anonymize, usually the anonymized version. For instance, if the original text contained a person's phone number, the anonymized text might be XXXXXXXXXXX. Component 2. The text that has undergone anonymization and needs to be reversed. This could be a piece of text where all email addresses were replaced with userexample.com. Architecture. This matching strategy operates on a simple principle of direct textual comparison. It does not involve any advanced algorithms or complex analysis. The strategy simply compares the anonymized text to the original text character by character. Role. This strategy plays a crucial role in situations where anonymization does not alter the original text's content. It acts as a basic mechanism to restore the original text by directly matching the anonymized version. Imagine a scenario where a document is anonymized by simply masking sensitive information with asterisks. In this case, the exact matching strategy would be very effective in recovering the original text. Advantages. Requires minimal setup and is easy to implement. This strategy is straightforward and doesn't require complex configurations or code. It can be easily integrated into existing systems. Works well when the anonymization process does not alter the text's content. Consider a scenario where sensitive data like credit card numbers are anonymized by simply replacing them with a placeholder. In such cases, this strategy can effectively restore the original text. Challenges. Only effective if anonymization preserves the exact text content. If the anonymization process involves transformations or replacements, this strategy would not be effective. For instance, if the anonymization process replaced all dates with 20231231, this strategy would not be able to restore the original dates. Fails to handle cases where anonymization involves transformations or replacements. Suppose the anonymization process involved replacing names with random strings. This strategy would fail to de-anonymize the text as it relies on exact matches. LangChainExperimental Data Anonymizer De-anonymizer Mapping Format Duplicated Operator Summary. NaN. A function that operates on a list of data points and returns a list of anonymized data points and a mapping to de-anonymize the data. This mapping allows for the reconstruction of the original data from the anonymized data. This function ensures data privacy while maintaining the ability to analyze and manipulate the data. Component 1. LangChainExperimental Data Anonymizer is a component that takes a list of data points as input and returns a list of anonymized data points. The anonymization process is designed to protect sensitive information while preserving the integrity of the data. Component 2. Langchain-experimental denonymizer mapping is a component that creates a mapping between the original data points and the anonymized data points. This mapping is used to denonymize the data, restoring the original data points from the anonymized ones. The function takes a list of data points as input and returns a list of anonymized data points and a mapping to denonymize the data. This architecture enables the function to perform data anonymization and provide a way to restore the original data. The function is used to anonymize data and provide a way to denonymize it later. This functionality allows for the use of sensitive data while ensuring data privacy and compliance with relevant regulations. Preserves data privacy, which is important in situations where sensitive information needs to be protected, such as in healthcare or financial data. Allows for data analysis and manipulation, which is essential for extracting insights from the data and making informed decisions. Ensuring that the anonymization process is reversible, which is important for preserving the integrity of the data and enabling the recovery of original information. Preventing accidental disclosure of sensitive information, which requires robust security measures and access controls to protect the anonymized data. Maintaining data integrity, which is crucial for ensuring that the anonymized data accurately represents the original data and is suitable for analysis and manipulation. Handling duplicate data points, which requires a robust strategy to ensure that duplicate data points are handled consistently and accurately during anonymization and denonymization. Maintaining a consistent mapping between anonymized and original data points, which is essential for ensuring accurate denonymization and the preservation of the relationships between data points. Efficiency and scalability, which are crucial for handling large data sets and ensuring that the anonymization process is performed quickly and efficiently. Security and robustness, which are important for protecting the anonymized data from unauthorized access, manipulation, or deletion. Flexibility and adaptability, which are important for handling different data formats, schemas, and privacy requirements. Handling edge cases and errors, which requires robust error handling mechanisms to ensure that the anonymization process is reliable and produces consistent results. Maintaining usability and ease of use, which are important for making the anonymization process accessible to users with varying levels of technical expertise. Ensuring that the anonymization process is transparent and auditable, which is important for establishing trust and accountability. Providing documentation and support for the function, which is essential for users to understand the functionality of the function and troubleshoot any issues. Addressing ethical concerns related to data anonymization, which includes ensuring that the anonymization process is fair, ethical, and does not violate the privacy of individuals. Staying compliant with relevant data privacy regulations, such as the General Data Protection Regulation (GDPR) or the California Consumer Privacy Act (CCPA). Maintaining backward compatibility and ensuring seamless integration with existing systems, which is important for minimizing disruption and ensuring that the function can be easily adopted. Continuous improvement and enhancement of the function, which includes identifying and addressing any shortcomings and improving the performance, security, and usability of the function. Monitoring and evaluation of the function's performance, which is important for identifying and addressing any issues and ensuring that the function meets its intended purpose. Summary of Langchain Experimental Data Anonymizer Faker Presidio Mapping Get Pseudo-Anonymizer Mapping. Definition. Detailed definition of the function Get Pseudo-Anonymizer Mapping. This function takes a list of data fields, their types, and a set of anonymization techniques as input. It then uses the Faker library to generate realistic but fake data values for each field, based on the specified techniques. The function also leverages the Presidio library to identify and mask sensitive information within the data. For example, it might replace real names with randomly generated ones using Faker, while masking social security numbers with a series of X characters using Presidio. The output is a mapping of original data fields to their anonymized counterparts, which can be used to pseudonymize sensitive information. Components of the function getPseudoAnonymizer mapping. The function getPseudoAnonymizer mapping consists of two main components. Component 1. Function that leverages the capabilities of Faker and Presidio to generate mappings for pseudoanonymization. This component utilizes the Faker library to generate synthetic data based on specified data types and anonymization techniques. It also leverages the Presidio library for identifying and masking sensitive information in the input data. For instance, it might use Faker to replace real names with randomly generated ones while masking email addresses using Presidio. The output is a mapping of original data fields to their anonymized counterparts, suitable for pseudonymizing sensitive information. Component 2. Used to create mappings for pseudoanonymization. This component is responsible for generating mappings for pseudoanonymization. It takes a list of data fields and their types as input and utilizes the Faker library to generate realistic but fake data for each field. Additionally, it uses the Presidio library to identify and mask sensitive information within the data. For example, it might replace phone numbers with randomly generated ones using Faker, while masking credit card numbers using Presidio. The output is a mapping of original data fields to their anonymized counterparts, which can be used to pseudonymize sensitive data. Architecture. Description of the architecture supporting the function getPseudoAnonymizer mapping. The function getPseudoAnonymizer mapping is designed to be flexible and efficient in generating anonymization mappings. It leverages the capabilities of two powerful libraries, Faker and Presidio, to ensure accurate identification and masking of sensitive information. The architecture of the function involves first using Faker to generate realistic yet fake data for each data field based on the specified anonymization techniques. Then, Presidio is used to identify and mask sensitive information within the generated data. This combination of libraries enables the function to generate anonymization mappings that are both realistic and secure, effectively pseudonymizing sensitive information in datasets. Role. Explanation of the function getPseudoAnonymizer mapping's role in the system. The function getPseudoAnonymizer mapping plays a crucial role in the system's anonymization process. It provides a mechanism to generate anonymization mappings that can be used in conjunction with the data anonymizer to anonymize sensitive data. This mapping is essential for effectively protecting sensitive information by replacing it with synthetic data, ensuring data privacy and security. For instance, in a healthcare database, this function could be used to generate mappings for anonymizing patient names, addresses, and medical records. This anonymized data can then be used for research or other purposes without compromising patient confidentiality. Advantages. Provides flexibility in choosing anonymization techniques. The function getPseudoAnonymizer mapping offers flexibility in choosing anonymization techniques, allowing users to tailor the anonymization process to their specific needs. Users can choose from a wide range of anonymization techniques supported by the Faker library, including random data generation, masking, and tokenization. This flexibility enables users to create anonymized data that meets their specific requirements for data privacy and security. Offers an easy way to create anonymization mappings. The function getPseudoAnonymizer mapping provides an easy and efficient way to create anonymization mappings. It automates the process of generating mappings, simplifying the anonymization process and reducing the risk of human error. This user-friendly approach makes it easier for developers and data scientists to implement data anonymization effectively, enhancing data privacy and security. Challenges. It may not be suitable for all anonymization scenarios. While the function getPseudoAnonymizer mapping is a powerful tool for anonymization, it may not be suitable for all anonymization scenarios. For instance, in cases where the data requires very specific anonymization rules or techniques, the function's default settings might not be sufficient. It's important to carefully consider the specific requirements of each anonymization scenario to ensure the function's suitability. The mappings generated may not be robust for all data types. The mappings generated by the function getPseudoAnonymizer mapping might not be robust for all data types. For example, while it can effectively anonymize text data, it might not be as effective in anonymizing complex data structures like JSON or XML. It's important to consider the data types being anonymized and assess the function's effectiveness in handling them. langchainexperimental.data-anonymizer.denonymizer mapping.format duplicated operator. Definition. The format duplicated operator in LangChain experimental data anonymizer denonymizer mapping is a function that handles situations where multiple anonymization techniques are applied to the same data field. It aims to create a comprehensive mapping that reflects the combined effect of these techniques. For example, if a user's name is first anonymized by replacing it with a random string and then further anonymized by replacing it with a hash, the format duplicated operator ensures that the denonymization process correctly reverses both actions, ultimately restoring the original name. Components. Component 1. Format duplicated operator function. Component 2. Denonymizer mapping class. Architecture. This function is part of the denonymizer mapping class, which helps track and manage the anonymization and denonymization processes of data. This class maintains a mapping between anonymized data and its original form, enabling the reversal of the anonymization process. Role. This function is crucial for ensuring accurate denonymization, particularly when multiple anonymization techniques are applied to the same data field. It allows for the creation of a robust and comprehensive mapping that captures the combined effect of these techniques. For instance, if a user's email address is anonymized by replacing the domain with a generic placeholder and then further anonymized by replacing part of the username with a random string, this function ensures that the denonymization process properly handles both transformations, restoring the original email address. Advantages. Ensures comprehensive mapping for denonymization. Handles scenarios with multiple anonymization techniques. Challenges. Complex scenarios with multiple overlapping techniques can be challenging to handle. Maintaining clarity and efficiency in mapping is essential. For example, if a user's address is anonymized by replacing the street name with a random string, then replacing the city with a generic placeholder, and finally replacing the zip code with a hash, ensuring that the denonymization process correctly reverses each step while maintaining an efficient mapping can be a challenge. langchainexperimental. Data anonymizer. Denonymizer matching strategies. N-gram fuzzy matching strategy. NaN. A fuzzy matching strategy based on n-grams for denonymization. It considers multiple n-grams with different sizes to find potential matches. N-grams are contiguous sequences of n items from a given sample of text or speech. For example, the trigrams 3 grams of the word hello are hel, l, and lo. Component 1. N-gram generation. This component involves extracting n-grams from the original text and anonymized text. It considers multiple n-grams with different sizes to find potential matches. Component 2. Fuzzy matching. This component compares the generated n-grams from both the anonymized and original texts to find potential matches. It uses fuzzy matching algorithms that allow for slight variations in the n-grams. Component 3. Similarity scoring. This component calculates a similarity score for each match found by the fuzzy matching algorithm. It uses a similarity metric such as Jacob similarity or Levenshtein distance to compare the n-grams. This strategy works by first generating n-grams of different sizes from both the anonymized and original text. It then calculates the similarity between n-grams from both texts and uses the similarity score to match the anonymized text to the original text. For instance, if the original text is "the quick brown fox jumps over the lazy dog" and the anonymized text is "the swift brown fox jumps over the lazy dog," the n-grams generated from both texts will have high similarity scores, thus making the strategy effective in identifying the anonymized text. A component of the denonymizer, which uses different matching strategies to identify anonymized text. The denonymizer aims to reverse the process of anonymization, allowing for the retrieval of original text from anonymized text. Advantage 1. Handles minor variations in the text. For example, if the anonymized text has a slight misspelling or grammatical error, this strategy can still identify the correct match. Advantage 2. Better at finding matches when the text has been edited. If the anonymized text has been edited, such as having words removed or added, this strategy can still find matches by focusing on the remaining n-grams that are similar. Challenge 1. Might need to be tuned for specific text formats. For example, if the anonymized text is in a specific format, such as a code snippet, then the strategy may need to be tuned to handle that format. Challenge 2. Can be computationally intensive. Generating and comparing n-grams can be a computationally expensive process, especially for large text documents. Challenge 3. May not work well with highly fragmented text. If the anonymized text is highly fragmented, such as a list of words or phrases, then this strategy may not be effective. Langchain experimental fallacy removal models logical fallacy. Definition: a model specifically designed to identify and rectify logical fallacies within text, focusing on commonly encountered fallacies such as ad hominem, straw man arguments, and appeals to authority. It utilizes a combination of natural language processing and logical reasoning to analyze textual arguments, detect fallacious reasoning, and propose corrections to enhance the quality and rationality of the text. Components. Component 1. A large language model (LLM) for understanding and generating text. An LLM is a powerful AI system capable of processing and generating human-like text. It can comprehend the meaning of words and sentences, and generate coherent text in response to prompts or questions. In this model, the LLM serves as the core component, interpreting the text and generating potential corrections for the detected fallacies. Component 2. A knowledge base of common logical fallacies and their characteristics. This component acts as a repository of knowledge about various logical fallacies. It stores information on the structure, patterns, and common indicators of different fallacies. The model utilizes this knowledge base to identify potential fallacies within the text. Component 3. A reasoning engine to analyze the text for fallacy patterns. This component employs logical reasoning algorithms to examine the text for fallacious patterns. It uses the knowledge base of fallacies to identify potential instances of logical errors in the argumentation. The reasoning engine evaluates the text's structure, identifying inconsistencies and potential manipulations within the argument. Component 4. A correction module to rewrite the text, mitigating the identified fallacies. This component utilizes the analysis results from the reasoning engine to generate a corrected version of the text. It aims to mitigate the identified fallacies by restructuring the argumentation, rephrasing statements, and providing alternative perspectives. The correction module aims to enhance the rationality and validity of the text while retaining the original author's intended message. Architecture. The model combines deep learning techniques for natural language processing with rule-based logic for fallacy identification. The model leverages the power of LLMs to process text and understand its meaning, while relying on a predefined set of rules and patterns to identify and categorize logical fallacies. This hybrid approach allows the model to efficiently analyze text and detect subtle fallacies, while simultaneously ensuring accuracy and consistency in the identification process. Role: to improve the quality and rationality of text by identifying and correcting logical fallacies. This model's primary function is to enhance the quality of text by eliminating logical fallacies. It aims to make the text more logically sound, reducing bias and misinformation. By removing fallacious reasoning, the model promotes clearer and more objective communication, making it easier for readers to understand and evaluate the presented arguments. Advantages: enhanced text quality and coherence. The model aims to improve the overall quality of the text by making it more logically consistent and coherent. By identifying and correcting fallacies, the text becomes more clear, persuasive, and believable. It helps readers understand the arguments more readily and avoids potential misinterpretations. Improved argumentation and reasoning. The model assists in improving the logical soundness of arguments presented in the text. By identifying and correcting fallacies, the model promotes stronger and more credible reasoning. It helps to ensure that arguments are based on sound logic and evidence, rather than emotional appeals or misleading claims. Reduction of bias and misinformation. The model plays a role in mitigating bias and misinformation by identifying and correcting fallacies that often arise from biased or misleading arguments. By removing these logical fallacies, the model helps to ensure a more balanced and objective presentation of information, reducing the spread of false or misleading claims. Challenges: limited ability to handle complex or subtle fallacies. The model may struggle to identify and correct highly complex or subtle fallacies, which require deep understanding of context and nuanced reasoning. This limitation arises from the model's reliance on predefined rules and patterns, which may not cover all possible variations of fallacies. Potential for misinterpretations or overcorrection. The model's analysis relies on algorithms and pattern recognition, which may lead to occasional misinterpretations or overcorrection. The model may misidentify certain statements as fallacious or apply excessive correction, altering the original meaning or intent of the text. Difficulty in capturing context and nuances in natural language. Understanding the context and nuances of natural language is a challenging task for any AI model. The model may struggle to accurately interpret the meaning of certain statements or phrases, potentially leading to misidentification of fallacies or inaccurate correction. Requires a comprehensive knowledge base of fallacies, which can be challenging to maintain. The model relies on a comprehensive knowledge base of fallacies to accurately identify and correct them. Maintaining and updating this knowledge base with new fallacies and variations is crucial for the model's effectiveness. May struggle with informal or colloquial language, which can be prone to ambiguity. Informal or colloquial language often employs idioms, slang, and figures of speech that can make it difficult for the model to interpret meaning accurately. This can lead to misinterpretations or inaccurate identification of fallacies. Difficult to evaluate the effectiveness of the model, as there is no objective standard for correct argumentation. Evaluating the model's effectiveness is challenging due to the lack of a universally accepted standard for correct argumentation. Different individuals may have varying interpretations of what constitutes a valid argument, making it difficult to objectively assess the model's performance. May introduce biases into the corrected text. The model's training data and internal algorithms may inadvertently introduce biases into the corrected text. This could occur if the training data itself exhibits biases or if the algorithms are susceptible to certain biases. Limited ability to understand and correct fallacies related to emotions and ethics. The model may struggle to identify and correct fallacies that are deeply rooted in emotions or ethical considerations. This limitation arises from the model's focus on logical reasoning and its limited capacity to understand and process complex human emotions. Requires substantial training data to achieve high accuracy. The model requires extensive training data to learn patterns and effectively identify and correct fallacies. Training a model on a large and diverse dataset is essential for improving its accuracy and generalization ability. Can be computationally expensive to train and run. Training and running a large language model like this can be computationally expensive due to the complex algorithms involved and the vast amounts of data required. This can be a significant challenge for resource-constrained applications. May not be applicable to all types of text, such as creative writing or poetry. The model may not be effective in analyzing and correcting fallacies in certain types of text, such as creative writing or poetry, which often employ figurative language, metaphors, and other non-literal expressions. May not always be able to identify the intended meaning of the author. The model may struggle to identify the author's intended meaning, particularly in cases where the text is ambiguous or employs sarcasm or irony. This limitation can lead to misinterpretations and incorrect identification of fallacies. May not be able to correct all types of fallacies. The model's knowledge base and algorithms may not cover all types of fallacies, particularly emerging or unconventional fallacies. This limitation restricts the model's ability to comprehensively correct fallacious reasoning. May be difficult to adapt to new or emerging types of fallacies. The model may struggle to adapt to newly emerging or evolving types of fallacies, which may not be included in its existing knowledge base. This necessitates frequent updates and revisions to ensure the model's continued effectiveness. May not be able to distinguish between fallacious arguments and legitimate disagreements. The model may struggle to distinguish between genuine disagreements and arguments that are based on logical fallacies. This is a challenging task as it requires a deep understanding of the nuances of human discourse. May not be able to account for the context in which an argument is made. The model may struggle to accurately consider the context in which an argument is made, leading to misinterpretations or inaccurate identification of fallacies. Contextual information is crucial for understanding the true nature of an argument. May not be able to understand the nuances of human language. The model may have difficulty understanding the nuances of human language, including subtle connotations, implied meanings, and cultural context. This can lead to misinterpretations and inaccurate identification of fallacies. May not be able to identify all instances of a particular fallacy. The model may not be able to identify all instances of a particular fallacy due to its reliance on predefined rules and patterns. This limitation arises from the complex nature of human language and the varying ways in which fallacies can be expressed. May not be able to correct all instances of a particular fallacy. The model may not be able to correct all instances of a particular fallacy, particularly in cases where the fallacy is deeply embedded within the text or involves complex reasoning. The model's correction capabilities are limited by its understanding of the text and its ability to generate appropriate revisions. May not be able to correct all fallacies in a single pass. The model may require multiple passes or iterations to identify and correct all fallacies within a text. This is due to the complexity of fallacies and the potential for them to be interwoven within the text. May not be able to correct all fallacies in a way that is both accurate and natural sounding. The model may struggle to correct all fallacies in a way that is both accurate and natural sounding. This challenge arises from the need to balance logical correctness with the preservation of the text's original style and tone. May not be able to correct all fallacies in a way that is both accurate and persuasive. The model may struggle to correct all fallacies in a way that is both accurate and persuasive. This challenge arises from the need to present arguments in a way that is both logically sound and compelling to the reader. May not be able to correct all fallacies in a way that is both accurate and ethical. The model may struggle to correct all fallacies in a way that is both accurate and ethical. This challenge arises from the complex nature of ethics and the potential for biases to influence the model's decisions. May not be able to correct all fallacies in a way that is both accurate and effective. The model may struggle to correct all fallacies in a way that is both accurate and effective. This challenge arises from the need to balance logical correctness with the practical considerations of real-world communication. Summary of Langchain experimental data anonymizer denonymizer mapping denonymizer mapping. NaN. A mapping that links anonymized data to its original form. For example, in a medical dataset, a patient's name might be replaced with a unique identifier. The denonymizer mapping would store the link between this identifier and the original patient's name, allowing for denonymization when necessary. Component 1. A dictionary storing mappings between anonymized and original data. This dictionary would contain key-value pairs where the key is the anonymized data like the unique identifier mentioned above and the value is the original data, the patient's name. Component 2. Methods to store and retrieve mappings for anonymization and denonymization. This includes functionalities for adding new mappings, retrieving existing mappings, and potentially deleting mappings. These methods could be implemented using different storage mechanisms, like in-memory dictionaries, databases, or files. Supports both key-value and list-based mappings. This means it can handle scenarios where anonymization is done by replacing a value with another unique value key-value mapping, or by replacing a value with a random value from a list-based mapping. For example, replacing an email address with a randomly generated email address from a predefined list would be a list-based mapping. Enables efficient and reversible data anonymization. It ensures that data can be anonymized for privacy reasons but can also be reversed to recover the original data when needed. This is particularly useful for research purposes where privacy concerns need to be addressed, but the ability to de-anonymize data is also crucial. Preserves data relationships for analysis. By maintaining the link between anonymized and original data, the de-anonymizer mapping ensures that data relationships are preserved. This allows for meaningful analysis of anonymized data without losing the original context and connections between data points. Supports reversible anonymization for de-anonymization. It makes it possible to reverse the anonymization process and recover the original data. This allows for data to be used in contexts where privacy is a concern, while also ensuring that the original data is accessible when required, for example, for further analysis or auditing purposes. Maintaining data integrity during mapping. Ensuring that the mappings are accurate and consistent is crucial. This involves implementing robust mechanisms to prevent errors during the mapping process and ensuring that the mappings are always up to date. For instance, if new data is added to the anonymized dataset, the mappings must be updated accordingly. Handling large datasets effectively. As the size of the datasets grows, the computational and storage requirements for managing the de-anonymizer mapping become more challenging. This involves optimizing data storage, retrieval, and update processes to ensure efficiency and scalability. Efficient algorithms and data structures should be used to handle large volumes of mappings effectively. langchainexperimental data anonymizer base anonymizer base summary. NaN. The anonymizer base class serves as a foundational building block for all data anonymizers within the LangChain framework. This class lays down the fundamental structure and concepts that all subsequent data anonymizers will inherit and build upon. Component 1. Anonymizer base is the core component of this class, defining the basic structure and methods that all data anonymizers will share. Component 2. The call method is a fundamental component within the anonymizer base class. This method, when invoked, triggers the anonymization process. It takes a piece of data as input and applies the anonymization techniques defined by the specific anonymizer to transform the data while preserving its structure and integrity. The anonymizer base class implements abstract methods for anonymizing data. These methods are designed to be overridden by specific anonymizer implementations, tailored to handle various data types and anonymization techniques. This approach promotes flexibility and extensibility within the framework, allowing developers to customize anonymization strategies based on specific requirements. The primary role of the anonymizer base class is to provide a unified and standardized interface for data anonymization within the LangChain framework. It establishes a common set of rules and methods for all anonymizers, making it easier for developers to integrate different anonymization techniques into their applications consistently. The anonymizer base class offers a consistent interface for anonymizing data. This consistency makes it easy for developers to switch between different anonymization techniques without needing to rewrite significant portions of their code. The anonymizer base class modular design allows for easy extension and customization. Developers can create new anonymizer implementations by inheriting from the anonymizer base class and defining their own specific anonymization methods. This flexibility enables developers to adapt the framework to meet the specific needs of their applications. One of the primary challenges of implementing a generic data anonymizer class is the need to handle diverse data types effectively. Each data type may require unique anonymization methods. For example, anonymizing text data might involve replacing sensitive words with placeholders, while anonymizing numerical data might involve adding noise or shifting values. Anonymizer base may need to handle edge cases and complex data structures. Data can come in various formats, and the anonymizer needs to be robust enough to handle these complexities. For instance, anonymizing nested dictionaries, lists within lists, or data with irregular patterns might pose challenges. langchainexperimental. Fallacy removal. Base. Fallacy chain. A description of fallacy chain, a tool for removing fallacies from text. A chain that uses a set of tools to detect and remove fallacies from text. The chain is built on top of the fallacy detector tool, which can identify common fallacies in text. The chain then uses a fallacy remover tool to rewrite the text to remove the fallacies. Component 1. Fallacy detector detects fallacies in text. The fallacy detector tool is responsible for identifying fallacies in text. It analyzes the text and uses a set of rules and patterns to identify common fallacies such as ad hominem, appeal to authority, straw man arguments, and false dilemmas. It can also be trained on specific data sets to detect fallacies specific to certain domains. Component 2. Fallacy remover removes fallacies from text. Once the fallacy detector tool identifies a fallacy, the fallacy remover tool is used to rewrite the text to remove the fallacy. It does this by identifying the fallacious statement and rephrasing it in a way that eliminates the fallacy while preserving the intended meaning of the text. The chain uses a pipeline architecture. The input text is first passed to the fallacy detector tool, which identifies any fallacies present in the text. The detected fallacies are then passed to the fallacy remover tool, which rewrites the text to remove the fallacies. For example, if the text contains an ad hominem attack, the fallacy detector tool identifies it, and then the fallacy remover tool rewrites the text by removing the personal attack and focusing on the argument itself. The fallacy chain is designed to help users identify and remove fallacies from text. This can be useful for a variety of purposes, such as improving the quality of writing, identifying biased or misleading information, and promoting critical thinking. For instance, a journalist can use fallacy chain to improve the quality of their articles by removing fallacies that might have slipped into their writing. Similarly, a student can use it to identify and remove fallacies from their essays, leading to more reasoned arguments. Improves the quality of writing. The fallacy chain tool can improve the quality of writing by identifying and removing logical fallacies. This results in more persuasive and convincing arguments. Helps identify biased or misleading information. The fallacy chain can help users identify biased or misleading information by identifying fallacies used to manipulate or deceive. For example, if a website uses appeals to emotion to push a particular agenda, fallacy chain could highlight this manipulation tactic. Fallacy detection can be challenging, as there are many different types of fallacies. The fallacy detector tool may not be able to identify all fallacies. For example, complex fallacies that involve subtle linguistic nuances might be difficult to detect. Removing fallacies from text can be difficult without altering the meaning of the text. The fallacy remover tool may not be able to effectively remove all fallacies without introducing new errors or changing the intended meaning. For example, removing a fallacy from a statement could lead to a grammatically incorrect or unclear sentence. Facilitates complex knowledge organization and retrieval by capturing relationships between entities. For example, a knowledge graph representing a scientific research field can capture relationships between concepts, theories, and experiments, enabling researchers to navigate and understand complex scientific knowledge. Advantage 2. Utilizes LLMs for knowledge inference, enabling the extraction of new insights and understanding. For example, an LLM can be used to infer relationships between entities in a knowledge graph based on existing information, providing new insights and understanding of the data. Advantage 3. Allows for seamless integration with various data sources and tools within the LangChain ecosystem. For example, a knowledge graph can be integrated with other LangChain components, such as a document loader or an API wrapper, allowing users to access and analyze information from various sources. Challenge 1. Managing large-scale knowledge graphs can pose challenges in terms of computational resources and efficiency. For example, a knowledge graph representing a large-scale database can require significant computational resources to process and query, posing challenges in terms of performance and scalability. Challenge 2. Accuracy and consistency of data used to construct the graph are crucial for reliable knowledge extraction. For example, inaccuracies or inconsistencies in the data used to construct a knowledge graph can lead to misleading or incorrect inferences, highlighting the importance of data quality. Challenge 3. LLMs used within the graph can potentially introduce biases from their training data, requiring careful consideration. For example, an LLM trained on a dataset with biased language can introduce biases into the knowledge graph, potentially leading to discriminatory or unfair inferences. Challenge 4. Understanding the reasoning process behind inferences made by LLMs within the graph can be challenging. For example, an LLM's reasoning process for making inferences can be complex and difficult to interpret, posing challenges in understanding the basis for its conclusions. Challenges. The strategy is limited to exact matches, meaning that any variations or typos in the data can hinder the matching process. The strategy is susceptible to false negatives, which occur when a data point in the anonymized dataset doesn't have an exact match in the original dataset. This can happen due to data corruption or missing information. LangChain experimental data anonymizer denonymizer matching strategies exact matching strategy. Definition. Matches on exact string equality. This strategy is useful for very specific and unique identifiers, like UUIDs, or hard-coded strings. It may be less useful for less structured data like names, dates, or addresses. For example, if you have a database of users with unique user IDs, you can use this strategy to match anonymized user IDs to their original values. However, if you are trying to match anonymized names, this strategy might not be effective because names can be spelled differently or have variations. Components. Component 1. The exact matching strategy is a denonymizer matching strategy that uses exact string equality to match anonymized data to original data. This strategy compares the anonymized data to the original data and returns a match if the two strings are exactly the same. Component 2. This strategy is useful for very specific and unique identifiers such as UUIDs or hard-coded strings. For example, if you have a system that generates unique IDs for each user, you can use this strategy to match anonymized IDs to their original values. Component 3. It may be less useful for less structured data such as names, dates, or addresses. For example, if you are trying to match anonymized names, this strategy might not be effective because names can be spelled differently or have variations. Architecture uses exact string comparison for matching. This means that the strategy compares the anonymized data to the original data and returns a match only if the two strings are exactly the same. Role used to match anonymized data back to its original form using exact string equality. This strategy can be used to reverse the anonymization process for data that has been anonymized using a method that preserves the original string. For example, if you have a database of users with unique user IDs that have been anonymized by replacing the original IDs with random strings, you can use this strategy to match the anonymized IDs to their original values. Advantages. Advantage 1. High accuracy for unique identifiers. This strategy is very accurate for data that contains unique identifiers, such as UUIDs or hard-coded strings. This is because the strategy only returns a match if the two strings are exactly the same. Advantage 2. Simplicity and ease of implementation. This strategy is relatively simple to implement and can be easily integrated into existing systems. Challenges. Challenge 1. May not be suitable for data with variations or errors. This strategy is not suitable for data that contains variations or errors, such as names that are spelled differently or dates that are formatted incorrectly. This is because the strategy only returns a match if the two strings are exactly the same. Challenge 2. Limited effectiveness for less structured data. This strategy is less effective for less structured data, such as names, dates, or addresses. This is because this data can be easily changed or modified, and the strategy may not be able to match the anonymized data to the original data.
Voyage AI Rank. A description of Voyage AI Rank, a powerful tool for optimizing travel search results. A powerful tool for optimizing travel search results using Voyage AI and LangChain. Voyage AI Rank utilizes the vast travel data available in the Voyage AI Knowledge Graph and powerful language model orchestration capabilities of LangChain. This combined approach empowers Voyage AI Rank to provide a more relevant and personalized travel search experience. For instance, a user searching for flights to Paris may be presented with results tailored to their specific preferences and budget. Component 1. Voyage AI is a comprehensive travel knowledge graph containing a wealth of data related to destinations, flights, hotels, attractions, and other travel-related information. It acts as the core source of information for Voyage AI Rank, providing a rich and detailed understanding of the travel landscape. Component 2. LangChain is a powerful framework designed for connecting and orchestrating large language models. enabling them to interact with various data sources and APIs. Voyage AI Rank leverages LangChain to process user queries, interpret travel preferences, and retrieve relevant information from Voyage AI. For example, LangChain could be used to extract information about flight prices, hotel reviews, and local attractions from Voyage AI's database and then use this information to tailor search results. Voyage AI Rank's architecture seamlessly combines the capabilities of LangChain with Voyage AI's travel data to achieve intelligent re-ranking of travel search results. By leveraging LangChain's ability to process natural language and interpret user intent, Voyage AI Rank can analyze user queries, understand their preferences, and then use Voyage AI's extensive travel data to provide highly relevant and personalized search results. This approach ensures that users are presented with the most appropriate and useful travel options. Voyage AI Rank plays a crucial role in enhancing travel search results, providing a more relevant and personalized experience for users. By taking into account user preferences, context, and past search behavior, Voyage AI Rank reorders search results to prioritize those that best match the user's needs. This personalized approach aims to improve user satisfaction and make the travel planning process more efficient and enjoyable. Improved search relevance by analyzing user preferences, context, and past search behavior. Voyage AI Rank effectively reorders search results, ensuring that the most relevant options are displayed first. This approach improves the user experience and makes it easier for travelers to find the information they need. For example, a user searching for a flight to London may have past searches related to budget airlines. Voyage AI Rank can use this information to prioritize results from budget airlines, providing a more personalized and relevant search experience. Enhanced user experience. Voyage AI Rank provides more tailored and informative travel recommendations, offering a richer and more engaging user experience. By leveraging Voyage AI's comprehensive travel data and LangChain's powerful language processing capabilities, Voyage AI Rank can deliver personalized insights, recommendations, and travel itineraries, making the travel planning process more efficient and enjoyable. Maintaining data freshness. Voyage AI data must be kept updated with real-time travel information to ensure the accuracy and relevance of search results. This requires a robust system for data ingestion, processing, and validation to ensure that changes in flight schedules, hotel availability, and other travel-related information are reflected in the knowledge graph in a timely manner. Scalability. Voyage AI Rank must be able to handle large volumes of travel data and requests efficiently to provide a smooth and responsive user experience. This requires efficient data storage and retrieval mechanisms, as well as optimized algorithms for processing user queries and generating search results. To handle peak travel periods and ensure smooth operations, Voyage AI Rank needs to be able to scale its infrastructure and resources dynamically. Langchain-experimental fallacy removal models. Logical fallacy definition: a model designed to identify and remove logical fallacies from text. This means that it can detect and correct flawed reasoning and deceptive argumentation within written content. For instance, it might recognize a false dilemma, where a situation is presented as having only two options, when in reality other possibilities exist. Components. Component 1. A pre-trained language model. This is a sophisticated AI system trained on vast amounts of text data. It can understand the nuances of language, identify patterns, and make predictions about the meaning and intent of text. For example, It might be a transformer-based model like BERT or GPT, capable of analyzing sentences and predicting likely words in a sequence. Component 2. A knowledge base of common logical fallacies. This component holds a collection of well-known and frequently occurring fallacies, providing the model with a reference point for identifying these errors in reasoning. For example, this knowledge base might contain examples of ad hominem attacks, where a person's character is attacked instead of their argument, and false analogies, where comparisons are made between things that are not actually comparable. Architecture. The model uses the pre-trained language model to analyze text and identify potential logical fallacies. This means that the model's language understanding abilities are used to scan text for clues that might indicate flawed reasoning. For instance, the model might look for phrases that signal a hasty generalization, where a conclusion is reached based on insufficient evidence. Role. To improve the quality and validity of text by removing logical fallacies. It aims to enhance the reliability and trustworthiness of written information by identifying and addressing instances of flawed reasoning. For instance, it could help to improve the quality of news articles or academic research by identifying and eliminating fallacies that might undermine the credibility of the information. Advantages. Can identify a wide range of logical fallacies. This means that it can detect different types of flawed reasoning, making it a versatile tool for improving the quality of text. For example, it might be able to identify fallacies such as appeal to authority, where the validity of an argument is based on the source's authority rather than the argument's merit, as well as slippery slope fallacies, which claim that one event will inevitably lead to a chain of increasingly negative consequences. Can help to improve the clarity and persuasiveness of text. This means that by removing fallacies, the model can make arguments easier to understand and more convincing. For instance, it might be able to rephrase a sentence that contains a false dichotomy, where a situation is presented as having only two options, into a more nuanced and accurate statement that acknowledges the existence of additional possibilities. Challenges. May not always correctly identify logical fallacies. This is a challenge because language is complex, and identifying fallacies often requires a nuanced understanding of the context and intent of the argument. For example, the model might misinterpret a statement as a hasty generalization, when it is actually a valid inference based on a strong body of evidence. May not always be able to effectively remove logical fallacies from text. This is a challenge because removing fallacies can sometimes require significant rewriting, which can be difficult to achieve without altering the original meaning or tone of the text. For example, the model might struggle to rephrase a sentence containing an ad hominem attack without losing the intended argument. It may not be able to handle complex arguments that involve multiple logical fallacies. This is a challenge because identifying and removing fallacies in complex arguments can be computationally demanding and require a sophisticated understanding of the relationships between different parts of the argument. For example, the model might struggle to correctly identify and remove fallacies in a lengthy debate with multiple interwoven arguments. May not be able to distinguish between valid arguments and arguments that contain logical fallacies. This is a challenge because identifying fallacies often requires a nuanced understanding of the logical structure of the argument and the relationship between its premises and conclusion. For example, the model might misinterpret a valid argument as containing a fallacy due to its complexity or the use of unfamiliar language. may not be able to handle arguments that are expressed in a highly informal or colloquial style. This is a challenge because informal language can be ambiguous and prone to errors in reasoning. For example, the model might struggle to identify a false dilemma in a casual conversation, where the speaker uses colloquialisms or slang that are not easily interpretable by the model. May not be able to handle arguments that are based on subjective or emotional appeals. This is a challenge because emotional appeals are often difficult to quantify and can be used to manipulate or distract from the core argument. For example, the model might struggle to identify an appeal to pity fallacy in an advertisement that uses emotional imagery to evoke sympathy for a cause. May not be able to handle arguments that are based on incomplete or inaccurate information. This is a challenge because incomplete or inaccurate information can lead to flawed reasoning and misleading conclusions. For example, the model might struggle to identify a hasty generalization fallacy based on an argument that relies on outdated or unreliable data. May not be able to handle arguments that are based on circular reasoning. This is a challenge because circular reasoning involves using the conclusion of an argument as a premise to support the conclusion, creating a logical loop. For example, the model might struggle to identify a circular reasoning fallacy in an argument that claims a statement is true because it is stated in a book, and the book is considered reliable because it states this statement. May not be able to handle arguments that are based on ad hominem attacks. This is a challenge because ad hominem attacks target the character of the person making an argument rather than the argument itself, attempting to discredit the argument by attacking the person's credibility. For example, the model might struggle to identify an ad hominem attack in a debate where a participant insults the opponent's intelligence rather than addressing the opponent's claims. May not be able to handle arguments that are based on strawman arguments. This is a challenge because a strawman argument misrepresents an opponent's position to make it easier to attack, often by simplifying or exaggerating their views. For example, the model might struggle to identify a strawman fallacy in a discussion where someone criticizes an opponent's argument by misrepresenting their position as an extreme or unreasonable viewpoint. May not be able to handle arguments that are based on slippery slope arguments. This is a challenge because a slippery slope argument claims that one event will inevitably lead to a chain of increasingly negative consequences, without providing sufficient evidence for this chain of events. For example, the model might struggle to identify a slippery slope fallacy in an argument claiming that legalizing marijuana will inevitably lead to widespread drug addiction and societal collapse. May not be able to handle arguments that are based on false dichotomy arguments. This is a challenge because a false dichotomy argument presents a situation as having only two options, when in reality other possibilities exist. For example, the model might struggle to identify a false dichotomy fallacy in an argument claiming that a person is either good or bad, without considering the possibility of a spectrum of behaviors and motivations. May not be able to handle arguments that are based on red herring arguments. This is a challenge because a red herring argument introduces irrelevant information to distract from the main point of the argument. For example, the model might struggle to identify a red herring fallacy in a debate where a participant shifts the focus to an unrelated issue to avoid addressing the opponent's claims. May not be able to handle arguments that are based on appeal to authority arguments. This is a challenge because an appeal to authority argument claims that a statement is true because It is made by a person in a position of authority, without providing evidence to support the claim. For example, the model might struggle to identify an appeal to authority fallacy in an advertisement that uses a celebrity endorsement to promote a product, without providing evidence of the product's effectiveness. May not be able to handle arguments that are based on appeal to popularity arguments. This is a challenge because an appeal to popularity argument claims that a statement is true because it is widely believed or accepted, without providing evidence to support the claim. For example, the model might struggle to identify an appeal to popularity fallacy in an argument claiming that a political candidate will be successful because they are popular with the public, without considering the candidate's qualifications or policy positions. May not be able to handle arguments that are based on appeal to tradition arguments. This is a challenge because an appeal to tradition argument claims that a statement is true because it has always been done that way, without providing evidence to support the claim. For example, the model might struggle to identify an appeal to tradition fallacy in an argument claiming that a particular social practice is acceptable because it has been in place for generations, without considering whether it is actually beneficial or harmful. May not be able to handle arguments that are based on appeal to emotion arguments. This is a challenge because an appeal to emotion argument attempts to sway the audience's emotions rather than their reason, often by appealing to fear, pity, or anger. For example, the model might struggle to identify an appeal to emotion fallacy in a political speech that uses fearmongering tactics to garner support for a particular policy. May not be able to handle arguments that are based on appeal to fear arguments. This is a challenge because an appeal to fear argument attempts to frighten the audience into accepting a claim, often by exaggerating potential threats or dangers. For example, the model might struggle to identify an appeal to fear fallacy in an advertisement that uses fear-inducing imagery to sell a security system. May not be able to handle arguments that are based on appeal to pity arguments. This is a challenge because an appeal to pity argument attempts to evoke sympathy or compassion from the audience to gain their support for a claim. For example, the model might struggle to identify an appeal to pity fallacy in a fundraising appeal that uses emotional stories to persuade people to donate money. May not be able to handle arguments that are based on appeal to ignorance arguments. This is a challenge because an appeal to ignorance argument claims that a statement is true because it has not been proven false, or vice versa, without providing evidence to support the claim. For example, the model might struggle to identify an appeal to ignorance fallacy in an argument claiming that a supernatural phenomenon exists because it has not been scientifically disproven. May not be able to handle arguments that are based on hasty generalization arguments. This is a challenge because a hasty generalization argument draws a conclusion based on insufficient evidence or a small sample size. For example, the model might struggle to identify a hasty generalization fallacy in an argument claiming that all members of a particular group share a certain characteristic based on observations of a few individuals. May not be able to handle arguments that are based on post hoc ergo propter hoc arguments. This is a challenge because a post hoc ergo propter hoc argument mistakenly assumes that because one event occurred after another, the first event caused the second event. For example, the model might struggle to identify a post hoc ergo propter hoc fallacy in an argument claiming that a new law caused a decline in crime rates, without considering other possible factors. may not be able to handle arguments that are based on correlation does not equal causation arguments. This is a challenge because a correlation does not equal causation argument mistakenly assumes that because two events are correlated, one event caused the other. For example, the model might struggle to identify a correlation does not equal causation fallacy in an argument, claiming that eating ice cream causes crime rates to increase, without considering that both events might be caused by a third factor, such as warmer weather, may not be able to handle arguments that are based on false analogy arguments. This is a challenge because a false analogy argument compares two things that are not truly comparable, leading to a flawed conclusion. For example, the model might struggle to identify a false analogy fallacy in an argument claiming that because a car has four wheels, it must be like a bicycle. May not be able to handle arguments that are based on misleading statistics arguments. This is a challenge because misleading statistics arguments use statistics in a way that distorts or misrepresents the truth, often by selecting biased data or using misleading graphs or charts. For example, the model might struggle to identify a misleading statistics fallacy in an argument that uses a graph with an intentionally skewed scale to exaggerate a trend. May not be able to handle arguments that are based on biased or loaded language arguments. This is a challenge because biased or loaded language arguments use emotionally charged words or phrases to manipulate the audience's perceptions or influence their opinions. For example, the model might struggle to identify a biased or loaded language fallacy in an argument that uses inflammatory language to demonize a political opponent, without providing evidence to support the claims. They may not be able to handle arguments that are based on fallacies of composition arguments. This is a challenge because a fallacy of composition argument mistakenly assumes that because something is true of the parts of a whole, it is also true of the whole. For example, the model might struggle to identify a fallacy of composition fallacy in an argument claiming that because each individual atom in a human body is invisible, then the human body must also be invisible. May not be able to handle arguments that are based on fallacies of division arguments. This is a challenge because a fallacy of division argument mistakenly assumes that because something is true of a whole, it is also true of the parts of the whole. For example, the model might struggle to identify a fallacy of division fallacy in an argument claiming that because the United States is a wealthy country, then every individual in the United States must also be wealthy. May not be able to handle arguments that are based on begging the question arguments. This is a challenge because a begging the question argument assumes the truth of the conclusion in the premise, creating a circular argument. For example, the model might struggle to identify a begging the question fallacy in an argument claiming that God exists because the Bible says so, and the Bible is true because it was written by God. May not be able to handle arguments that are based on equivocation arguments. This is a challenge because an equivocation argument uses a word or phrase with multiple meanings to mislead the audience, often by shifting the meaning of the word in the middle of an argument. For example, the model might struggle to identify an equivocation fallacy in an argument claiming that because a tree is tall, it must be tall in the sense of being morally upright. May not be able to handle arguments that are based on false dilemma arguments. This is a challenge because a false dilemma argument presents a situation as having only two options, when in reality other possibilities exist. For example, the model might struggle to identify a false dilemma fallacy in an argument claiming that a person is either good or bad, without considering the possibility of a spectrum of behaviors and motivations, may not be able to handle arguments that are based on loaded question arguments. This is a challenge because a loaded question argument contains an assumption that is not necessarily true, often designed to trap the respondent into making an incriminating or revealing statement. For example, the model might struggle to identify a loaded question fallacy in a question that assumes the existence of a phenomenon without providing evidence, such as "When did you stop beating your wife?" may not be able to handle arguments that are based on ad hominem arguments. This is a challenge because ad hominem attacks target the character of the person making an argument rather than the argument itself, attempting to discredit the argument by attacking the person's credibility. For example, the model might struggle to identify an ad hominem attack in a debate where a participant insults the opponent's intelligence rather than addressing the opponent's claims, may not be able to handle arguments that are based on misleading statistics arguments. This is a challenge because misleading statistics arguments use statistics in a langchainexperimental, graph transformers, diffbot, type option. Definition. Type option is a parameter in the diffbot application programming interface API that allows you to specify the type of article you want to extract. Components. Component 1. Type option is an argument passed to the diffbot application programming interface API which allows the API to understand what kind of article is being processed. Component 2. Type option enables the diffbot API to differentiate between various article types, such as news articles, product reviews, and blog posts. Architecture. The type option parameter is passed to the diffbot API, providing context about the type of article being processed. This parameter enables the API to tailor its extraction process to retrieve relevant data from the specific article type. Role. Type option plays a crucial role in the extraction process, as it informs the diffbot API about the structure and expected content of the article. It ensures that the API efficiently identifies and extracts the most relevant information based on the article type. Advantages. By using type option, you gain the flexibility to retrieve specific data based on the type of article. For instance, you can use it to extract product information from a product review or retrieve author details from a news article. Challenges. Type option relies on predefined article types, which might not encompass all potential article structures. For example, if an article type is not explicitly supported by the diffbot API, it may not extract the desired information effectively. The type option parameter might not capture all the desired content from an article, especially if the article type is complex or deviates from the predefined structures. It's important to carefully evaluate the specific article type and adjust the extraction process accordingly to ensure you retrieve all relevant information. Langchainexperimental, graph transformers, diffbot, nodes list. A detailed explanation of langchainexperimental graph transformers diffbot nodes list in a YAML convertible format. A list of nodes representing the extracted entities from a web page. Each node represents an entity like a person, organization, or location found on the web page. This list acts as a structured representation of the information extracted from the web page. Component 1. A list of nodes representing the extracted entities from a web page. Each node contains information about an entity, such as its type, text, and URL. For instance, a node might represent a person with their name, a brief description, and their website address. Component 2. Each node is represented as a dictionary containing information about the entity. The dictionary holds key-value pairs, where keys represent the attributes of the entity and values are the corresponding data. An example could be a node with the key name and value John Doe, indicating the name of the person the node represents. The architecture of LangChain experimental graph transformers diffbot nodes list is based on PE. Diffbot Application Programming Interface API. This API is used to extract information from web pages and generate a graph representation of PE. Extracted entities. Diffbot's API analyzes the web page, identifies relevant entities, and organizes them into a structured format that can be easily understood and processed by PE. Graph Transformer Class. The nodes list variable represents the extracted entities from a web page and is used as input to the Graph Transformer class. It acts as a bridge between the information retrieved from the web page and the graph generation process. The nodes list feeds the extracted entities into the graph transformer, enabling the construction of a visual representation of the relationships between these entities. Advantage 1. The nodes list variable provides a structured representation of the extracted entities, making it easier to work with the data. This structure allows developers to easily access and process the information related to each entity. For example, it facilitates filtering entities based on specific criteria or retrieving specific details about an entity. Advantage 2. The nodes list variable is compatible with the graph transformer class, which can be used to generate a graph representation of the extracted entities. This graph representation visualizes the relationships between entities, providing a clear and intuitive understanding of the information extracted from the web page. This visualization can be helpful for analyzing the relationships between entities and gaining insights from the web page's content. Challenge 1. The nodes list variable may not always be accurate or complete, depending on the quality of the web page and the effectiveness of the diffbot API. The accuracy of the extracted entities is influenced by factors like the page's structure, content, and the effectiveness of the diffbot API in interpreting it. There might be instances where the API fails to identify all relevant entities or misinterprets some information, leading to inaccurate or incomplete results. Challenge 2. The nodes list variable may contain duplicate or irrelevant entities, requiring additional processing to filter or remove them. In some cases, the diffbot API might identify multiple nodes for the same entity, or might include entities that are not relevant to the context of the analysis. This necessitates additional processing steps like filtering or removing duplicates and irrelevant entities to ensure a clean and accurate representation of the extracted information. LangChain experimental, graph transformers, diffbot, simplified schema. Definition. A simplified schema for diffbot's application programming interface responses. It aims to standardize the structure of data from different diffbot application programming interfaces, making it easier for LangChain to process and extract information. For example, if we want to extract information like article title, author, and publication date from a news article, the simplified schema ensures the data is organized consistently, regardless of the specific API used to fetch the article. Components. Component 1. A set of predefined field names. This set represents the key elements that are common across different diffbot application programming interfaces. For instance, these field names could include title, author, publication date, text, and URL. Component 2. A list of values associated with each field name. Each field name is mapped to a list of values that correspond to that field. For example, the field title might have a list of values containing the titles of multiple articles fetched from different sources. Architecture. The schema defines a dictionary-like structure. Each key represents a field name, and its corresponding value is a list of values. This structure facilitates easy access and manipulation of data retrieved from diffbot application. Programming interfaces. As each key value pair corresponds to a specific field and its associated information. Role. The simplified schema serves as a standardized interface for LangChain to interact with diffbots. Application Programming Interface. It simplifies data processing by providing a consistent structure for information retrieval. This means that LangChain can consistently process data from different diffbot applications. Programming interfaces using the same methods, eliminating the need for separate processing logic for each individual API. Advantages. Provides a consistent structure for diffbot application programming interface responses. By standardizing the response format, the simplified schema enables easier data processing and analysis. It removes the variability in the structure of responses from different diffbot applications. Programming interfaces. Making it more efficient for LangChain to handle data retrieved from various sources. Simplifies data processing and information retrieval for LangChain. The consistent structure allows LangChain to easily extract information from diffbot application. Programming interface responses. Instead of adapting to different response structures, LangChain can apply a single set of rules to extract data from various sources, improving efficiency and reducing complexity in information retrieval. Challenges. May not capture all the nuances of the original diffbot response. The simplified schema aims to capture the most common information elements, but it may not always encompass all the specific fields and details available in the original response from diffbot's application programming interfaces. Requires manual mapping of diffbot API fields to the simplified schema. Creating a simplified schema necessitates mapping the fields from specific diffbot application programming interfaces to the defined field names. This mapping process requires manual effort to ensure that the simplified schema accurately represents the information available in the original responses. LangChain experimental, graph transformers, diffbot, nodes list summary. NaN. A list of nodes representing the extracted information from a diffbot application programming interface response. Component 1. Node. Each node represents a distinct entity or piece of information from the scraped document. For example, in a news article, each node could represent a person, a location, or a specific event. Attributes. Each node has attributes that describe its properties, such as title, description, URL, etc. These attributes provide detailed information about each entity or piece of information. For example, a node representing a person might have attributes like name, age, and occupation. Relationships. Nodes can be linked to other nodes through relationships, representing the structure of the information. These relationships can be based on various factors, such as cause and effect, path-hole, or temporal order. For instance, a node representing a company might be related to nodes representing its employees, products, and financial performance. LangChain's graph transformer architecture leverages the nodes extracted from the diffbot application programming interface response to build a knowledge graph, representing the relationships between different entities and information. This knowledge graph provides a structured representation of the information extracted from a source document, facilitating further analysis and reasoning. The nodes list is a central data structure for storing and manipulating the extracted information from diffbot responses in a structured and interconnected manner. It enables efficient querying, retrieval, and processing of the extracted information by providing a unified and comprehensive representation of the knowledge extracted from the source document. Enhanced information retrieval enables efficient querying and retrieval of specific information based on the relationships between different nodes. For instance, one could query the knowledge graph to find all articles related to a specific person or event by navigating through the relationships between nodes. Contextual understanding captures the context and relationships between different pieces of information, providing a richer understanding of the extracted content. By understanding the connections between entities and concepts, users can gain deeper insights into the content beyond the individual pieces of information. Flexible processing allows for diverse downstream applications by providing a structured representation of the information. This structured representation enables the application of various data analysis and machine learning techniques for tasks like summarization, question answering, and sentiment analysis. Data consistency ensuring the accuracy and consistency of the extracted information across different nodes and their relationships. This involves identifying and resolving inconsistencies that may arise due to errors in the extraction process or ambiguities in the source document. Scalability handling large-scale datasets and managing the complexity of the knowledge graph as the number of nodes and relationships grows. As the amount of data increases, it becomes more challenging to maintain the efficiency and performance of the knowledge graph. This requires effective strategies for data management, graph optimization, and distributed computing. Langchain experimental, graph transformers, diffbot, type option. Definition defines the type of diffbot application programming interface request. Components. Component 1. Langchain experimental graph transformers diffbot type option is an enumeration. Component 2 represents different types of diffbot application programming interface requests. Architecture. Langchain experimental graph transformers diffbot type option is used in the diffbot graph transformer to specify the type of information to extract from a website. For example, if we want to extract the articles from a news website, we can specify the type of request as article. This will tell the diffbot graph transformer to use the appropriate diffbot application programming interface endpoint to extract the articles. Role. Langchain experimental graph transformers diffbot type option is used to specify the type of diffbot application programming interface request to be made. This allows the diffbot graph transformer to select the correct application programming interface endpoint and extract the desired information from the target website. Advantages. Provides a convenient way to specify the type of diffbot application programming interface request. Makes the code more readable and maintainable. Challenges. Langchain experimental graph transformers diffbot type option is limited to the types of requests supported by diffbot. This means that if a new type of diffbot application programming interface request is introduced, we need to update the Langchain experimental graph transformers diffbot type option enum. If a new type of diffbot application programming interface request is introduced, the Langchain experimental graph transformers diffbot type option enum needs to be updated. This could lead to backward incompatibility issues if users are relying on the old version of the enum. Langchain experimental fallacy removal, base, fallacy chain. A description of the fallacy chain, its components, architecture, role, advantages, and challenges. A chain designed to identify and correct logical fallacies in text. For example, if a text argues that all cats are bad because one cat scratched a person, this chain could identify the fallacy of hasty generalization and correct it by explaining that one instance does not represent all cats. Component 1. Fallacy detector identifies fallacies. A component that analyzes text to identify potential logical fallacies. For instance, it could detect an ad hominem attack, where an argument is dismissed by attacking the person making it rather than the argument itself. Fallacy corrector corrects identified fallacies. A component that attempts to fix the identified fallacies by providing alternative arguments or explanations. If a text claims that all politicians are corrupt based on a few examples, the fallacy corrector could provide information about the vast majority of honest politicians to correct the fallacy. Combines a fallacy detector and a fallacy corrector to remove fallacies. It works by first identifying potential fallacies in the text and then attempting to correct them. Using a variety of techniques, improves text by identifying and correcting logical fallacies. This can enhance the quality of information, reduce bias, and promote more rational discussions. Enhanced text quality. By identifying and correcting fallacies, the chain can improve the overall quality of the text, making it more accurate, coherent, and persuasive. Reduced bias and misinformation. By recognizing and correcting fallacies, the chain can help reduce the spread of misinformation and biased arguments. Fallacy detection. Detecting all fallacies is challenging, especially nuanced or context-dependent ones. Some fallacies are subtle or rely on complex arguments, making them difficult for a model to identify. For instance, a fallacy of appeal to authority might be difficult to detect if the authority cited is genuinely an expert in the field. Fallacy correction. Correcting fallacies can be complex and require deep understanding of the subject matter. Correcting fallacies might require nuanced understanding of the context and the specific arguments involved. For example, correcting a fallacy of false dilemma might require presenting additional options that were not initially considered. Language ambiguity. Fallacies can be subtle and language ambiguity can complicate detection and correction. The meaning of words and phrases can be ambiguous, making it difficult for the model to determine whether a fallacy is present. For instance, the phrase "everyone knows" can be used to appeal to popular opinion, which is a fallacy, but it could also be used to convey common knowledge, which is not fallacious. Context dependence. Fallacies can be context dependent, making it difficult to identify and correct them accurately. The validity of an argument can depend on the specific context in which it is presented. A statement like "all politicians are corrupt" might be fallacious if it's a general claim but not if it's made within a specific context about a particular group of politicians. Model limitations. Current models may not be perfect at identifying and correcting all fallacies. Models are still under development, and they might not always accurately identify or correct fallacies, particularly in complex or nuanced arguments. For example, a model might fail to recognize a fallacy of slippery slope if the argument involves a series of complex and interconnected events. Potential bias. Models might introduce new biases while correcting fallacies. Models are trained on large datasets of text, which may contain biases. These biases could potentially be reflected in the model's output, even when correcting fallacies. For instance, if a model is trained on a dataset that includes a lot of sexist language, It might inadvertently introduce sexist biases while correcting fallacies. Summary of Langchain Experimental Graph Transformers LLM Graph Transformer. NaN. A class that combines a graph transformer model with a Langchain large language model LLM. This combination empowers the LLM with the ability to reason and learn from graph-structured data, enriching its understanding and capabilities. Component 1. A Langchain LLM, which provides the core language understanding and generation capabilities. It can be any of the numerous LLMs supported by Langchain, such as GPT-3 or Jurassic 1 Jumbo. Component 2. A graph transformer model, which is specifically designed to process and understand data represented in graph structures. It learns patterns and relationships within the graph, enabling it to perform tasks like node classification, link prediction, and graph generation. A class that seamlessly integrates graph transformer models into the Langchain framework. It acts as a wrapper, encapsulating the graph transformer model and providing a standard interface for interacting with it through the Langchain LLM API. This allows developers to use the graph transformer model within Langchain workflows as if it were any other LLM. Facilitates the use of graph transformer models within Langchain, enabling applications to perform tasks that involve graph reasoning and knowledge representation. For instance, it can analyze social networks, predict interactions in complex systems, or infer knowledge from scientific datasets represented as graphs. Advantage 1. Leverages the powerful capabilities of graph transformer models to tackle tasks that require reasoning and understanding of graph-structured data. This enables Langchain applications to analyze complex relationships, discover hidden patterns, and make more informed decisions based on the graph information. Advantage 2. Provides a consistent interface, allowing easy integration with other Langchain components. This simplifies development workflows and enables developers to build complex AI applications by combining different Langchain components, including graph transformer models, LLMs, and other modules. Challenge 1. Limited availability of pre-trained graph transformer models compared to other LLM architectures. This restricts the immediate application of graph transformers to tasks where pre-trained models exist. Challenge 2. May require specialized knowledge to design and train custom graph transformer models. This necessitates expertise in graph data processing, deep learning, and model training, increasing the technical barrier for applying graph transformers in specific domains. Langchain Experimental Graph Transformers LLM Format Property Key. Definition. The format property key argument in Langchain Experimental Graph Transformers LLM controls how the output of the large language model LLM is formatted. It specifies the format of the property keys in the output dictionary. For example, if you want the output to have keys like answer and reason, you can set format property key to answer reason. This argument helps ensure the output is structured and organized for easy access and understanding. Components. Component 1. The format property key argument is a key component of the Langchain Experimental Graph Transformers LLM class, influencing the structure of the output from the LLM. It determines the format of the keys in the output dictionary, ensuring a consistent and predictable structure for the LLM's responses. Component 2. The format property key argument is crucial for managing the format of the output dictionary, ensuring clarity and consistency in how the LLM results are presented. It provides a standardized way to access and interpret the LLM's responses. regardless of the specific task or application. Architecture. The architecture of the LangChain experimental graph transformers LLM class relies on the format property key argument to define the structure of the output dictionary. It enables flexible formatting based on specific needs, allowing users to customize the output to fit their requirements. For instance, a user might prefer keys like question, answer, context, confidence score, or references depending on their use case. This flexibility makes the LLM adaptable to various applications and scenarios. Role. The format property key argument plays a critical role in shaping the output of the LangChain experimental graph transformers LLM class. It determines how the LLM's responses are organized and presented in the output dictionary. By controlling the format of the keys, it ensures a clear and consistent structure for the output, making it easier to interpret and utilize the results for downstream tasks or integrations. Advantages. The format property key argument offers flexibility in structuring the output dictionary, enabling customization for different applications. This flexibility allows users to tailor the output format to match their specific requirements. Whether it's for data analysis, research, or integration with other systems, the format property key argument enhances clarity and consistency in presenting the LLM's output, making it easier to interpret and utilize. By providing a standardized output structure, the format property key argument helps ensure that the LLM's responses are readily understandable and can be seamlessly integrated into various workflows and applications. Challenges. Properly defining the format property key argument is essential to ensure the output dictionary's structure aligns with intended use cases. Choosing the right format property key is crucial for achieving the desired output structure and ensuring that the LLM's responses are presented in a way that is easily accessible and interpretable. Understanding the different options and their impact on the output dictionary's format is crucial. For optimal utilization, different format property key settings can significantly alter the structure and organization of the output dictionary. It's important to carefully consider the specific needs of the application and choose the format property key that best suits the intended use case. Challenges. One of the challenges is that the LLM may not be able to extract all the relations from the text. LLMs, while powerful, are not perfect, and may miss subtle or complex relationships that require specialized domain knowledge or deeper understanding of the text. This limitation can impact the completeness and accuracy of the extracted relations. Another challenge is that the LLM may generate incorrect relations. LLMs are probabilistic models, and their predictions may sometimes be inaccurate due to the inherent uncertainty in language. Understanding this possibility of incorrect relations requires careful validation and verification of extracted information to ensure accuracy and reliability. LangChain experimental graph transformers diffbot format property key definition. This variable represents a function used to format property keys within the diffbot application programming interface API. It transforms keys into a consistent format, ensuring that the keys are compatible with the diffbot API's data retrieval process. For example, if a key is named article title in one data source, the function might transform it to article title for consistency. Components. Component 1. This is a key transformation function, which is a core component of the data retrieval process for diffbot. This function is responsible for taking raw data keys from various sources and standardizing them into a uniform format. Component 2. It is designed to ensure consistency and uniformity in the data retrieved from the diff-bot-p. This ensures that data from different sources can be integrated and processed seamlessly, regardless of their original key naming conventions. For instance, it might transform publication date and publish date to a common format like publication date. Architecture. This variable is part of the LangChain experimental library's graph transformers component, which enables efficient data processing and retrieval. Graph transformers is a framework that allows for building complex data processing pipelines, and this variable is crucial for ensuring data consistency within these pipelines. Role. This variable plays a crucial role in data integration and ensures that data is retrieved and processed in a consistent and standardized format. It acts as a bridge between different data sources, facilitating seamless integration of data from various formats and sources. Advantages. Improves data consistency and standardization. Enhancing data quality. This ensures that data from different sources can be easily compared and analyzed, leading to more reliable and accurate insights. Enables seamless integration of data retrieved from the diff-bot-p. This makes it easier to combine data from different sources, creating a comprehensive and unified dataset for analysis and decision-making. Challenges. Handling various data formats and key structures can be a challenge. Different sources might use different naming conventions and formats for their data keys, requiring the function to be flexible and adaptable. For example, some keys might use underscores while others use camel case. Ensuring backward compatibility when updating the key formatting function is essential. When the function is updated to handle new data formats or key structures, it is crucial to ensure that it continues to work with existing data. This is necessary to prevent issues with data analysis and retrieval processes that rely on a function. For example, if the function changes how article title is formatted, older data that uses the previous format might not be processed correctly.